Hello everyone, welcome to the lecture on Python installation for Windows. So in this lecture we're just going to go through a video on how to install Python using the Anaconda installation setup. And just to let you know, there's also a text file along with this lecture that contains all the links and everything I'm going to show you right now, so you can go ahead and feel free to just walk along through the text for installation. Okay, so first thing you're going to do is go to Google and type in Anaconda Python. And what that's going to do is it's going to take you to the link Anaconda Continuum. So Anaconda is a completely free Python distribution, and it includes a lot of the most popular Python packages, including packages for science, math, engineering, and data analysis. And it's simply probably the easiest and simplest way to download Python onto your computer. So I highly recommend it. Even if you already have a particular Python installation on your computer, Anaconda will work even if you already have a Python installation on your computer. So feel free to download Anaconda anyways, and don't worry about it interfering with any current Python installation. So what you're going to do is then click this page where it says download Anaconda now. So at the home page, continuum.io, click download for free. Then you're going to jump to Windows. Since we're on Windows, it's going to take you to this page. Now, as we discussed before, I recommend you download and install the Python 2.7 version. So you're going to click here, depending if you have 32-bit or 64-bit Windows. If you're on a newer computer, it's more than likely you have 64-bit Windows. Something to note here, and it's actually very small and very faint, this installation takes up 334 megabytes, so it may take a while to download. But go ahead, what you're going to do is download this graphical installer. Then you're going to double click the .exe file to install Anaconda, and then just follow the directions or instructions on the screen. So it's a graphical installer, should be pretty straightforward. And that's all there is to downloading Anaconda and Python for Windows. Once you've successfully installed the Anaconda distribution of Python, what you're going to do is go to your Start menu and type in Anaconda command prompt. And you should see it pop up. There's only going to be one of these. You're going to click Anaconda command prompt, and it'll take you to basically this terminal or shell looking interface. It's just a command prompt that's included in the Anaconda distribution. And what we're going to do now is install Jupyter. So let's go ahead and open a new tab real quick. So here I have this tab opened at jupyter.org. You can also click the link that's attached to this lecture in the text, or you can just Google Jupyter, Jupyter, and it should be the very first link, Project Jupyter Home. And I'll discuss Jupyter Notebooks in a future lecture, but for right now we'll just concern ourselves with installing it. So what you're going to do is go to this jupyter.org page, click Install, and you'll notice there's a whole installation page here. And what we're going to do is, depending if you're an existing Python user and new to Jupyter, existing IPython notebook user upgrading to Jupyter, or new to Python, I'm assuming you're new to Python and Jupyter, click that link. It'll take you down here. Let me zoom in a bit so you can see it. So as I mentioned, if you're new to Python, they highly recommend installing Anaconda. As I mentioned before, we're going to be using Python 2.7. So what you're going to do is, once the Anaconda distribution is done downloading, go back right here to the Anaconda command prompt that you got earlier, and you're going to type in this line that they told you here, Conda update Jupyter. It's CONDA space UPDATE update, and then Jupyter, JUPYTER, and then hit enter. You'll notice some stuff come onto this screen. Now, I've already installed it, so you'll see mine says all requested packages already installed. If you haven't installed this yet, you'll see a huge list of packages, and then it'll ask for a prompt, install yes or no. Just put in a Y for yes, and then it'll install everything for you. And that's it. Okay, so the way to check if everything worked is just type in Python here, and you should see something like this pop up. It'll say Python 2.7, Anaconda, etc., Anaconda, and you should be able to then actually type in Python command prompts into this interactive command prompt. So I should be able to say print, and do this with me, type in print, single quote, hello world, single quote, hit enter, and it printed hello world. So we're actually running Python in the command prompt right now. Okay, so let's go over just a brief overview of how to install Python. Don't worry, in the next lectures we'll talk more about the interactive command prompt, Jupyter Notebooks, etc. Right now we're just concerned with getting everything installed on your Windows system. As I mentioned, you're going to go Google Anaconda plus Python, click download for free. It's brought to you by Continuum Analytics. You're going to jump to the Windows, download the graphical installer, double click the executable file .exe. Then what you're going to do is, after you've installed it, you're going to go to Start, search Anaconda command prompt, click it, and then in order to install the Jupyter Notebooks, you're going to say conda update JUPYTER. Hit enter. You'll see a bunch of text come up. It may ask you for a prompt to say yes or no to install everything. Go ahead and enter Y. To check if everything installed correctly, what you're going to do is say PYTHON, which is just telling the command prompt, hey, I'm ready to start Python. Hit enter. You should see something like this pop up, and then you can say print, single quote, hello world, single quote, enter, and you've successfully installed Python onto your computer. Okay, great. In the next lecture, we're going to learn more about this interactive command prompt, more hello world, and we'll also talk about IDE selection, and then we'll have another completely separate lecture on what the Jupyter Notebooks actually are and why they're the best development environment for learning Python. Okay, thank you very much, and I will see you at the next lecture. Hey guys, welcome to Lecture 7. In this lecture, we'll be learning how to create arrays. So I'm going to call it Creating Arrays. Okay, so a big part of data analysis, as far as this course goes, will be array-based and matrix-based. So in order to do that, we're going to learn how to use NumPy to create these arrays. So the first thing we're going to do is import NumPy as NP. This will save us from having to type NumPy every single time. We can just write NP instead. One way to make an array is by converting from a list. So I will say make an object called myList1, and let's make a list of 1, 2, 3, and 4. Okay, so now that we have our list, we can make an array. So I will make an array called myArray1, and the way we can make an array is by using np.array, and then we can pass that list as an object. So we can say my_list1, and let's go ahead and see what that ended up being. Great. So now we have an array that we made from the list. So that's one of the ways we can make the array. So let's go ahead and make another list. We'll call it myList2. And in this case, we'll just have it be 11, 22, 33, and 44. And now we're going to make a list combining those two lists we just made. So I will call it my list plural equals my list1 as the first object in that list, and then I'm going to say my list2 as the second object in that list. And looks like I forgot the underscore. Let me add that, and there we go. Okay, so now we have a list of the two lists we made. We can make a multi-dimensional array or a matrix using this. So I can say my array2 is equal to np.array, and I'm going to pass that list of multiple lists. So I can say my lists, there we go. And let's go ahead and see what that multi-dimensional array looked like, otherwise known as a matrix. Great. So you can see now we have both lists in the array. It's 1, 2, 3, 4, 11, 22, 33, 44. And let's go ahead and see what the shape of that array is. So since it's multidimensional, I can ask NumPy what shape it is by saying .shape method. And so it looks like it's a 2 by 4, which makes sense. So that means every list you passed in that list of lists created a new row. So here was your first row, and then here's your second row. All right, great. So now we know how to make an array and a multidimensional array from a list. So we can also find out the data type of the array. And I can do that by, in the same way I asked what the shape was, I can ask for the dtype by passing the dtype method. And it'll tell me the type of objects that are in that array. There's also special case arrays. So for instance, if you wanted an array of all zeros, you could say np.zeros and then just indicate the shape of the array you wanted. So if I wanted an array, just a 1 by 5 of zeros, so just a straight vector, and there I have it, my 5 zeros. And if you notice, there's a decimal point there, and that's because they're a floating type. So to show you what I mean by that, I can say np dot, well, I can say my zeros array equal to np dot zeros 5, and then I can check the type. So I can say my zeros underscore array, and we just learned how to check the type. So let's go ahead and make sure they're floating, and they are. So they're floating numbers, which means they have that decimal point there. Excellent. Another special case array is an array of ones, and I can do that by saying np1s. And I can pass the shape here too. So I can say, for instance, a 5 by 5. So I'll make a matrix of ones, and there you have it, a 5 by 5 multidimensional array. I can also create an empty array. I can do that just by saying np empty, and that'll be the same thing as just asking for zeros there. Okay, and then last but not least, we can make an identity matrix or identity array. And it's always going to be, well, almost always going to be a full matrix, multidimensional. And you can make the identity matrix by using EYE. And since it's a matrix, you'll have to input just a square matrix. So it's going to be a 5 by 5 in this case if I input just the number 5. So I can say Alt-Enter. And then here's my identity matrix, which is just a diagonal of a 1, and then everything else filled in with zeros. And then one way we can make an array that we'll be using a ton in this course is by np.arrange. And what that does is it's going to give you can input a start and a stop and a step size, and it's going to return evenly spaced values within that given interval. So I can say just 5, and in this case it's going to output 0, 1, 2, 3, 4. Excellent. And to get more specific, I could say something like start at 5, stop at 50, and do it in steps of 2. Let's see if it can make evenly spaced. There we go. So 5, 7, 9, etc., all the way in space of 2. So we'll be using this arrange method a lot throughout the course. Okay, so that's how you can create arrays. Just to do a quick overview, you can pass a list using np.array and input the list. You can check the shape and the type of objects in for those matrices or arrays. And then your special case arrays, you can say zeros, ones, empty, I, and then you can also create an array by just using arrange. Alright, that's it for creating arrays. I'll see you in the next lecture. Hey everybody, welcome to Lecture 8. So in this lecture, we're going to be learning how to use, or using, arrays and scalars. Okay, so first off, we're just going to import NumPy as NP, and then something we can do is say, let's check 5 divided by 2. So in Python version 2, if you were to input this command, 5 divided by 2, notice you'll just get a whole integer there. You're not going to get 2.5 as it should be. If you declare 5 to be a floating point by saying 5.0, and we run this again, Alt Enter, then we do get the true answer. It treats that as a floating point. In order to take care of that, we can import from the future. I know it sounds crazy, but we can totally do it. So we can say from underscore underscore future underscore underscore. We can import division. So if you're running on Python 3 point whatever x, you won't have to worry about this. It's already going to be standard. But if you're running on Python 2, you're going to have to import from the division from the future to take care of that problem. So now let's go ahead and see 5 divided by 2, and we get 2.5. Excellent. All right, so let's go ahead and create an array. Like we've done in the last lecture, we can say we're going to call this array ARR1, and I'm going to say np.array. And like we learned in the last lecture, we can do it with a list of multiple lists. So I'm going to do just that. I'm going to say 1, 2, 3, 4. That's be the first list that I input, and then the second list that I input will be 8, 9, 10, 11. Okay, so now we got that. Let's go ahead and see what that multidimensional array looks like. So we have a 2 by 4 here. Excellent. So what can we do with that? We can try multiplying arrays. So in this case, we can say array1 times array1 times array1, excuse me. So what do we get here? So if you do this kind of command, it's going to multiply every value in the same spot of one array by the value of the other one in the same spot. So for instance, 1 times 1 is 1, 2 times 2 is 4, 9 times 9 is 81, etc., etc. So you can do some scalar operations there in a sense. You can also do subtraction. So we can say array1 minus r1, there we go. And you'll get a 0, which makes sense because 1 minus 1, 2 minus 2, etc., etc. And then you can do arithmetic operations with scalars on the array. So for instance, if I wanted to say 1 divided by every value in that array, this would be the same thing as saying every value in the array to the power of -1, so creating it as the reciprocal of a fraction. There we go. And that's what we got. So if we look at the original array, 1 divided by 1 should be 1. And then we say 1 divided by 2 should be 0.5. And if we look at some other values here, 1 divided by 10 should be 0.1. So that makes sense, the same as 1 over 10. So you can do that as well. And then lastly, you can also do exponential operations. So you could say that array to the power of 3. So every element in that array to the power of 3. And that's what you get. So 1 to the power of 3 is just 1, 2 to the power of 3 is 8, etc., etc. So that's how you can do some mathematical operations on arrays and also arithmetic operations using scalars. Okay, so we'll be using these throughout the course. Go ahead and do an overview, make sure you understand it. And otherwise, I will see you in Lecture 9. See you there. Hello everybody, and welcome to Lecture 9. In this lecture, we'll be going over indexing arrays. Okay, so we're going to import NumPy as NP. Alt Enter to get a new cell and run it. Let's go ahead and create a sample array. So in this case, I'll just call it ARR, and I'm going to set it equal to np.arrange And let's go from 0 to 11. So in this case, and then let's go ahead and show it. Think about what you expect to see here before you click Alt Enter. And let's go ahead and see it. Okay, so hopefully you figured out that the index starts at 0. So in this case, calling it all the way to 11 means I would get 10. Here we go, 11 points, excuse me, 0 through 10. And if I want to get a value at an index, I can say call the value at 8, index 8, and that should be equal to 8, which makes sense because if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, I'll end up at 8. Great. So what if I want to get the values in a particular range? I can also do that by inputting a range from 1 all the way to 5. And remember, this should go to 1 before 5, so it should output 1, 2, 3, and 4. Let's go ahead and see if that's true. And it did, so it outputted 1, 2, 3, and 4 in your array. Perfect. And let's go ahead and get the values in a range again. So how about 0 through 5? And that gets us 0, 1, 2, 3, 4. Okay, so that's how you can get values in a range. You can also set a value with an index range. So I can say from the range 0 to 5, I can set all those values equal to 100. So before you click enter, think about what's going to happen. I'm telling Python to say, hey, all the values from 0 to 5, go ahead and set them equal to 100. But remember, you start at 0, so it should be 0, 1, 2, 3, and 4. Those 5 numbers should be equal to 100. And then it'll go 5, 6, 7, 8, 9, 10. So we should expect 5 instances of the number 100, and then 5, 6, 7, 8, 9, 10. Let's go ahead and see what our array looks like now. And we got just that. So here we have the 5 100s, so 0, 1, 2, 3, and 4 were turned into 100, and then we have 5, 6, 7, 8, 9, 10. All right, perfect. Let's go ahead and just reset this array. So I'm going to say np.arrange 0, 11 again. Let's see what it looks like. So I have my 0 through 10, the 11 points. And now we can do slices of an array. So I can set an object to be equal to slice underscore of ARR and set that equal to the range from 0 to 6. So in this case, I would expect slice of R to, or array, depending how you want to say it, to be equal to 0, 1, 2, 3, 4, 5. So those are 6 values there. And then let's just type it out so we can see what that looks like. Okay, and there we have it. Here are the 6 values, 0, 1, 2, 3, 4, 5, and now we created a slice of the array in that same fashion. We can go ahead and change the slice. So I can say slice of R or array. I could say, using a colon, say all the elements in that array are now equal to 99. And let's go ahead and check if that is what happened. And that's the case. So using that colon, you can select all the elements in your array. So now note that the changes also occur in our original array. So what do I mean by that? I'm going to show you the original array. Now you might be thinking, whoa, that's weird. I was only changing values in slice of array, not in my array itself. Well, in NumPy, this data isn't copied. It's just a view of the original array. So this avoids memory problems. That way you don't have several copies of your array floating around. You only have one copy of your array, and if you grab slices of it and change the elements, it's going to affect your original array. So that's something to really keep in mind when you're messing around with arrays. If you don't want that to happen and you want to get a copy, you got to be explicit. So if I say ARR copy equal to ARR, that will still affect your original array. It's not going to actually make a copy. What I have to do is explicitly say copy. So dot copy, parentheses, no extra arguments. And then I can look at this array, and now I have a copy of it. All right, great. So let's learn about indexing in a 2D array. So let me make an object called ARR underscore 2D and use np.array. And then as we've done in the past, I'm going to put in several lists, so I can say something like, let's see, let's go ahead and go in powers of, or counts of 5, so like 5, 10, 15, that'll be one list. Then 20, 25, 30, that's another list. And then my next one I can say 35, 40, 45. All right, and then let's go ahead and show that by typing it out. All right, excellent. So now I have a 3x3 2D array. Awesome. So how can I index this? I'll type out my r underscore 2D, and if I want to see a row, I can type in the index of that row. So think about for a second before you click Alt-Enter what this should be. And remember, in Python and NumPy, your index starts at 0. So what do we expect to see here? We see the row of 20, 25, and 30. So that makes sense because your index starts at 0, and what I mean by that is if I called 0, I would see the first row here, 5, 10, 15. So here's your 0 index row, here's your 1 index row, and then here's your 2 index row. All right, great. What if you want a individual element value? Well, you can do that as well. You can just say the row you want, and then also ask for the column you want. Okay, so think about it for a second. What value should this get me? I'm asking for index 1 row and index 0 column. And hopefully you got that it was going to be 20, so that makes sense. Here's my index 1 row, and then that was my index 0 column. Great. Okay, so we can also do 2D array slicing. So how does that work? Let's go ahead and see that 2D array again. So there's my 2D array. Let's say I wanted a 2-2 shape array from the top right corner. So I wanted the 10-15 and the 25-30 as its own 2x2 array. So I can just do that by taking a slice. And so what I'm going to ask for is everything up to 2, and then 1 and beyond as far as the columns. So let's see if that works. And it does. Excellent. So if you look at, for instance, the columns here, I asked for the 1 column index and everything beyond it, so that would be these 2 last columns. And so that's what allowed it to take the 10-25 and the 15-30, and then to cut off the 40 and the 45, I asked for everything until the second indexed row. Okay, great. Now what else can we do? So we've been able to take some 2D array slices. We can check out the bottom row if we wanted to by saying 2 there. That would have been the bottom row. Perfect. And we can go on to something called fancy indexing. So fancy indexing, I'll show you what it means. So we can say something like, let's just make this array another 2D array. Won't put the underscore to differentiate it. And I'm going to make a zeros array. And if you remember from some previous lectures, we can say zeros. Then let's go ahead and input the size, so we'll make it a 10 by 10. Let's go ahead and see what that looks like. Okay, here's my 10 by 10 2D array of all zeros, and it looks like they're all floats. That's why there's a decimal there. And now I can get the length of the array. I can say object array length underscore length equals R2D shape of that first. And if I look at that, I should get, whoops, equal to 10. So it has a length of 10. So that's how I could get the length. So now we can set up the array. So I'm going to say for I in range, length of the array. So for I in range 10 basically is what I'm saying. That array element value of I equals I. Okay, so now that we've done that operation, I'm going to check out the multidimensional array, but go ahead and think about what we just did here as far as this function. So we said for every I in the range R length, and that R length was 10, go ahead and set that element there equal to 1. So what should that do? That should give you straight ones. Alright, so that makes sense so far. What if I said equal to I? Now let's go ahead and see what happened to our array. Go ahead and think about what this should look like before you check it. Hopefully you thought about it right and you got 0, 1, 2, 3, 4, 5 all the way to 9, and then everything across is yet the same. So we only change those across the rows themselves. So every row, every value in that row equals that count number. Okay, so fancy indexing allows for us to do the following. So we can say something like ARR2D and just index it by the values in that row. So we can say 2, 4, 6, 8. Great, and so that will give us the second, the fourth, the sixth, and the eighth rows for indexing. And we can do this in any order, which is why we get the term fancy. So it doesn't have to be in order, we can just do random rows here. So I can say 6, 4, 2, and 7, and that will return the 6, 4, 2, and 7 index rows. And that's fancy indexing. So main takeaways here are, again, we've reviewed how to create arrays, and the main takeaway is how to index. So remember, this is really important. If you want to explicitly make a copy, you got to state that .copy. Otherwise, changes you make in slices of the array will affect your original array. And then for indexing, you can ask for the row, or you can get the row and the column, and you can use colons to get certain slices or chunks out of your multidimensional arrays. And that's it for indexing arrays. And we finished off with fancy indexing. Okay, next up we'll have lecture 10. I'll see you there. Hey guys, this is lecture 10, array transposition. So in this lecture we'll be learning how to transpose arrays in NumPy. So let's go ahead and start off importing NumPy as NP. Alt-enter to get a new cell. Let's create an array, and we'll use arrange to do this. So that's going to give us 50 points from 0 to 49, and then let's reshape it into a 10 by 5 matrix, and then we'll just show it. Cool. So we have 0 to 49 and a 10 by 5. Since the index starts at 0, that's why it doesn't go all the way to 50, but we have 50 points, 10 times 5. So to transpose this matrix, it's actually pretty easy in NumPy. All we got to do is select our matrix and call .t onto it, and then you see it's been transposed. So the first row of our previous array has now been transposed as the first column. Cool. And NumPy also allows you to take dot products of arrays. So you can do that by calling np dot. And so we can do the dot product of the transposed array with our original array. And here we have the dot product of those two arrays. And we can also make 3D matrices. Even though we won't be using it that much in this course, we can go ahead and just see how it works. So we'll make a 3D matrix. Again, let's call a range 50 points, and we'll reshape it as a 5 deep matrix with 5 by 2 arrays. So let's see what that actually looks like. So here we have basically the 5 slices of that 3D matrix, and each slice consists of a 5 by 2 array. And if you want, you can also transpose a 3D matrix. In order to do that, we can call transpose on that matrix. And we'll have to specify which axes to use. So for instance, if we transpose it this way, we'll get on that first slice, all the first column will be all the 0, 0 of every individual slice. So if we look back at the original 3D array, matrix, we had a 0, a 10, a 20, a 30, a 40 as the first row and first column indexed value. And now that's become the first column of that first slice. You can kind of see how that same transposition carries out through the rest of the array. And last but not least, if we want to get really specific on swapping axes in an array, we can actually call swap axes onto it. To show you what I'm talking about, let's go ahead and make another array real quick. We'll just call this one, let's see, we'll have it be 1, 2, and 3, and we'll show it. Alright, so we have our array there. And let's say you wanted to be specific on how to swap axes, you can actually call swap axes. So we can swap the 0 axis for the 1 axis. And let's see what happens. And now you have a vertical array. Cool. And that's about it as far as array transposition. I'll see you in the next lesson. Okay guys, this is lecture 11 now. And this will be about universal array functions. So let's start off by importing NumPy as NP, Alt Enter, and let's go ahead and make an array to start off with. We'll just call 11 points and show it so we can have 0 through 10 in our array. So universal functions are basic functions that you can apply to every value in an array. So for instance, we can take square roots by calling np.sqrt, and we can call it in our array. And now we've taken the square root of every value in the array. So if we look at 4, we should have a 2 there. Yep. And 9 gives you a 3. Cool. So what other things can we do? We could possibly take the exponential of every value in the array. So basically have e to the power of the number, the value point in that array. So if we run that, that's what we get. First value makes sense, right? Because e to the power of 0 is just 1. So that worked out. There are also binary functions. Those will require 2 arrays because of the term binary. That makes sense. So how about, in order to see that, we'll create a random array. In order to do that, we'll call NumPy using np. Then we'll call random from the NumPy library. and then we'll call a random normal distribution, and we'll have it be 10. And let's go ahead and see that array. And if you don't quite get what we just did here, we'll be going over it a lot more throughout the course, so don't worry about that too much. Let's go ahead and Alt-Enter. Cool. So now we have our array that's a normal distribution of some random numbers. Let's create another one. np.random.randn of 10. And let's go ahead and see that as well. Cool. There's our other guy. So in order to do some binary functions, all that means is functions that use two arrays. So for instance, adding arrays. So this will add every value of A to every value of B. So this first value of A to this first value of B. Let's go ahead and see how that looks. So we have negative 0.3 blah 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 plus 0.11 gets you negative 0.23, etc., etc. Other things we can do is find the max or min between two arrays. So in order to do that, we can say np.maximum called two arrays, and this will find the maximum between the two array values. So to see what I'm talking about here, if we look at our original arrays A and B, it will compare the values at each index. So the first one was negative 0.35 in array A and 0.11 in array B. So it's going to compare those and see which one was the max, and then set that as the value for that array you just called. And it's going to do that for each of the values comparing A and B. And you can also check for minimums just by calling np.minimum. So for a full extensive list of all the universal functions, you can check out the documentation. So I'm just going to edit, copy, and edit, paste the website here. And again, like always, you can just click on the links to see the IPython notebooks from GitHub. If we want to see this website, a little trick we can do is import web browser and then call web browser to open that website link. Let's see if that works. Yep, looks like it did. So here are all the available math operations, these ufuncs, universal functions. So you can add, subtract, multiply, divide, take the log of the sum of the exponents, find remainders, find signs. There's a whole bunch of stuff you can do. Take square roots, get the squares, and we'll be using this as we need them. And you can also do trigonometric functions, get the sines of the values, the cosines, the arctans, etc., the hyperbolics, and then there's comparison functions as well, which we'll look into later. So you can go ahead and check out the documentation on these universal functions in case you're looking for extra ones or more info. Alright, so that'll be the end of lecture 11, and I'll see you at the next one. Array processing. In this lecture, what we're going to do is mesh from those arrays so we can get kind of a grid plot and see what that looks like, and then we'll do some other processing with arrays, some statistical processing, and then just messing around with some Boolean stuff as well. So this is going to be a little bit longer lecture than the last two, but so let's get to it. We'll start off by importing NumPy as NP, and then we're going to import matplotlib. Whoops. Matplotlib, and we'll pyplot library from it, and we'll import it as PLT. So we're going to do this because we're going to be visualizing some of the grids and meshes we'll be making. And then in order to see those visualizations in the IPython notebook, we need to call matplotlib inline so we can see it in line with everything. Alt-Enter, and it's imported it. Cool. And don't worry too much about the matplotlib and visualizations in general. One of the last sections throughout this course will go into much greater detail into visualizing data. So let's start with the creation of a grid. We'll do that by setting one side of the grid points. So these will be the points along one side of the grid. We'll do that by calling numpy.arrange. So we can do our start, stop, and our step value. So we'll start at -5, stop at +5, and let's go in steps of 0.01. Alt-Enter. Cool. So we have our points, and then we'll create our grid. So our grid can be a points by points grid. So to show you what I mean by that, we'll call dx and dy, and from NumPy we'll call mesh grid. And what this will do is return coordinate matrices from the vectors we give it. So the vectors we're going to give it is just points by points. And see what that actually did, let's go ahead and take a look at dx. Cool. And you'll see that dx is basically a matrix where all the rows go from -5 all the way to +5 in those 0.01 steps. And you'll see that dy is the same thing, but now it just goes along the columns instead. So this will help us make our grid. So how about we do an evaluating function? So we'll say that z is equal to np.sign of dx. So we'll take the sign of all the dx values. If you remember from one of the previous lectures, this is just a universal function, happens to be trigonometric. And we'll do np.sign of all the dy values too. And then we'll take a look at, we'll see what z actually looks like. So Alt-Enter. Cool. So these are our z values. And in order to get actually looks like, because these numbers can be a bit nebulous, we can plot this. And in order to plot this, we'll call PLT, and we'll do an image show, so that'll be IMShow, which is a good way to plot this kind of data, basically a matrix. So we'll call it Z to it. See what that looks like. Awesome. So now you can see how this is basically a sign along both the X and the Y. You can see how it has its peaks and valleys. If we want to see what that what these colors actually mean as far as values, we can plot it with a color bar. So let's call that IMShow again. Plot it with the color bar, and the last thing we're going to do is also give it a title. So we can do that by saying plot.title, and we'll say that's the plot for basically sine of x plus sine of y. So let's take a, oh, forgot to close that string there. Nice. And so now we can get a much better idea of what this image is actually showing us. So we can see the peaks here in red and the valleys. The processing is learning how to use NumPy where. In order to do that, we'll create two arrays. So let's create an A array, np.array, and we'll make this just a simple 1, 2, 3, 4. And then let's also make, scroll down a bit, also make a B array, and we'll say this is 100, 200, 300, 400. That way we can tell the form, but also know which values go with which array. So we'll input those arrays, and we'll create something, we'll create a Boolean array. So Boolean will allow us to input true and false conditions into an array. So we'll call it condition. And in this Boolean array, what we're going to do is just input Boolean values. So true, true, and false, false. So we have our Boolean array now. And we can use this for something called a list comprehension. So what that will allow us to do is, let's say we want to make an array where we choose the A value if the condition is true. Otherwise, we choose the B value. So to show you what I mean by that, we'll say a val if condition is met, else use the b val. And since we haven't defined what a val or cond or b val is, we'll say that's for every a value, b val, and cond in, and we'll use zip to input multiple arrays, a, b, and condition. And whoops, have some invalid syntax here for let's just get rid of that. That actually goes at the end, since the whole thing will be, the whole answer is an array. So Alt Enter. Cool. So before I show you the answer, let's go ahead and think about it, see what we should be seeing. So what answer is, it's gonna say, hey, in this array, show me the a value if the condition is met. Otherwise, show me the b value. And it defines a value, b value, and condition as each value in the a, b, and condition array. So if we think about this, let's see what that first value of this array should look like. A value if the condition. So it says choose the a value 1 if your condition is true. Otherwise, choose the b value. So you would expect the first value of this array to be 1, since that's true. And then again, if you go along to the second value of that array, a value, whoops, 2 if the condition is true. Otherwise, choose b. So it should be 1, 2. And then a value if condition. So on the third one, the condition is false. So we would expect it to choose the b value there. So we should see a 300. And then last, on the fourth one, again, it's false. So it's not going to choose the a value, it'll choose the b value. So let's see if we're right. We should see a 1, a 2, a 300, and a 400. And that's exactly what we see. So just take a moment to really understand what's going on here. We're just using a list comprehension to have a little bit of Boolean logic in this array for each of these values in these three arrays here. Cool. So now we'll use NumPy where. So to show you what that looks like is we'll have another array called answer2 np.where. We'll pass a condition and then we'll say a, b. So what this NumPy where does is basically the short form of this long list comprehension array. So it's going to say where my condition is met, choose A, otherwise choose B. So where my condition, true, choose A, 1, otherwise choose B. So we should expect doing this command to see the exact same thing. And let's see if that is true. We'll do Alt to enter, and then we'll show answer 2. Yep, and that's the same thing. So you can see using NumPy, we can get that same kind of logic in a much more convenient fashion. So take a moment to see if you understand what just happened, and try inputting different conditions, different array values, play with it, see if you can predict the right arrays that come up on 2D arrays for manipulation. So from NumPy .random, I'm going to import the normal random distribution, because we'll be using that in a bit. And now I'm going to make an array. Now I can just call random without calling np.random, since I imported it specifically. And we'll make a 5 by 5, and let's go ahead and show what that matrix looks like. Cool. So this is this matrix came from a random normalized function. Cool. So using the same kind of where command and logic, I can say something like np numpy.where. How about where this we'll have to feed a condition, so we'll say where the array or this matrix was less than 0, make it a 0, otherwise leave that array value. So we have our condition, the first option to replace it, otherwise do that. So let's go ahead and see what happens. Cool. So if you look on the original array, everything that was negative is now a 0. So this is a useful tool if you ever want to clean up your data. It's also used in Pandas, which is the module we'll be learning more about later. And it's just a useful thing to keep in the back of your mind. Let's create another array to go deeper into some other statistical processing stuff we can do. So we'll have np.array, and let's make it 1, 2, 3. Let's have it be a 3 by 3, and then we'll say 4, 5, 6, and then that last row will be 7, 8, 9. And let's show it just to see, make sure we did it right. Yep, so it's a 3 by 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's see what happens if I call sum on that matrix. I get 45, so it summed up every value in that matrix. I can also do it along a specific axis. So for instance, if I wanted to sum up everything in the columns, so I wanted to sum up 1, 4, 7, 2, 5, 8, 3, 6, 9, I could say array sum and specify that axis. So we'll say along the 0 and see what happens. Yep, and that's what we get. So 1 plus 4 is 5, plus 7 is 12. So this is just adding it up along the columns itself. There's other things we can call. such as the mean. So this will give us some statistical information. So the average of all that is 5. It's a useful thing to call. We can also call the standard deviation using .std. We get our standard deviation. If you want, you can also call the variance using .var. Do this true and false ones. So to show you how this works, let's go ahead and make a Boolean array, np.array, and we'll have it be, let's just say true, false, true, so it alternates a bit. We'll call that Boolean array. And we'll call any on this. So what any is going to do is it's going to return a Boolean, either true or false, if anything in that array was true. So since there are trues in there, we'll expect it to return true. Let's see if that works. Yes, it does. Similarly, we can call all. And this will return true only if all the values are true. So this should, we'd expect it to return false on the Boolean array since there is a false there and they're not all true. And that's what we got. Cool. Finally, you can sort arrays. So in order to see that, I'm just going to put a little comment here so we can know where we are at. We can say, let's make an array. It's just a random 5, and we'll see it. Alt enter. Cool. So you see it's not sorted right now. So in order to sort it, we can call .sort, and then we'll see what happens. So now it's sorted it from least to greatest. I know this is a lot already, but we're almost done with this lecture. We can use unique. So let's make an array called countries. And let's say we have France, Germany. Let's get the US of A in there as well. Russia. We'll put USA again, and you'll see why in a second. We'll put in Mexico. And then finally, Germany again. Let's go ahead and input that. So now we have this, basically this array of countries. We inputted a list of countries and transformed it into an array. If I wanted to find out which countries were unique in this array, I could say, I could call NumPy .unique on countries, and it'll tell me which ones only appeared once. So let's see what happens. I'm sorry, it'll tell me which unique values you have. So you have France, Germany, Mexico, Russia, and USA. So it'll give you each of the unique values in that array. And last, we can also use numpy.in1d. So this can test values in one array. To show you how this works, let's pass France, USA, let's call it, I don't know, Sweden, and countries. So what this command will do in 1D, it's going to check if France, USA, and Sweden are in this countries, a one-dimensional array. So it's going to say, is France in countries? Is USA in countries? Is Sweden in countries? So let's think about what it should output before we see it. Is France in countries? Yes. So it should output true there. Is USA in countries? Yes. It should output true. Sweden is not in the countries array, so it should output false. So we should get an array that says true, true, false. Let's see if it works. Yep. True, true, false. All right, awesome. So there was quite a bit in there. We just learned a lot. As always, you can check out the link to the IPython notebooks on GitHub and look at them and play around with some more stuff. All right, I'll see you in the next lecture. Hey guys, welcome to lecture 13. This lecture will be just a quick lecture on array input and output, so how to save arrays and how to open them beyond just an IPython notebook. So we'll start off by importing NumPy as np. Let's go ahead and do that. Alright. Let's just create a quick array. We'll just say np.arrange. Just make it 5 points. Take a look at what that looks like. So we have our array of 0 through 4, 5 points. If we wanted to save this array, all we gotta do is call np.save, and we can save it as my array, and then choose which array you want to save. So the actual object was ARR. And so now that's saved as an array. To show that it's saved this actual array, let's go ahead and make another array with the same name. And we'll have it be 10 points long and show you what that looks like. So now if I call ARR, it shows a 10-point array of 0 through 9. Let's make sure that we did actually save my original array, which was 0 through 4. And if we wanted to load that, we just use np.load, and we call that file. Now in order to get the actual file, you have to use the NumPy extension, which is .npy. So this was the name of the file, and then if you want to actually load it, you got to call the extension as well. So let's see if that works. Yep, and it did. Here's our original array that we had saved. You can also save multiple arrays. So for instance, let's say array1 is equal to np.load myArray.npy, and then we'll see what that looks like. And then let's set array2 equal to that 10-point array. Let's go ahead and see what that looks like. So now I have two arrays. If I wanted to save both of them, I can. I can save them in a zip file. We're going to use save again, but this time save with a Z, saves. So it's going to save it as a zip file. You're going to name that zip file. So we'll call this zip array. And the file extension you're going to use here is npz. And then you're going to choose which arrays to save with it. So we can call our first one, we'll just say it's x, and that will be the first array, and we'll have the second one called y, and that will be array 2. So let's go ahead and see if that worked. Yep, it did. If I wanted to load multiple arrays, I can just do that using the load function. So let's go ahead and call let's call it an archive of arrays. And then I'm going to load that zip file I just saved. So it's going to be zip array.npz. Let's see if this works. So it did. So let's say I wanted to look at that first array. Since I saved it as x, I can just call it. archive array, just call x here, and there's my first array, and then similarly I can call my y and I should get the second one, and I do. So that worked out well. And then one last thing, you can also save and load text files in case you don't want to save it as an array. So let's just make an array. Actually, let's make a matrix using the array function. So we'll just have it be a 2 by 3. So we'll say 1, 2, 3, 4, 5, 6, and then let's just take a look at what that looks like now. Cool, we have a 2 by 3. And if we want to save it as a .txt file, a text file, we can say save txt. And then we'll give it a name. We'll just say my text array .txt, since it's going to be a text file. We'll choose the array or the matrix we're going to save it as. And then if we wanted to save it as a text file, we can signify a delimiter. So what the delimiter is, it's just basically what's separating each value. So in your text file, when you see it, you're going to see that it's just a bunch of numbers and they're all separated by a symbol, or such as a comma. So in this case, we'll signify that the delimiter is a comma, just like a comma separated variable file or .csv. Let's go ahead and do that, see if it works. Yep, cool. And now let's just take a look at what we saved. So if we wanted to load a text file, you can just say load np.load text. And let's load my text array .text. And then I'll signify that my delimiter, the symbol that's separating each individual value, was just a comma. And then let's see what that looks like. So it says error, NumPy doesn't have a load txt text. Sorry about that. So it's load txt, not load text. So let's try that again. So we have a txt file. It should just be load txt. My apologies for that. And there we go. Now it worked. And these periods here, these dots, is just to signify that it's a floating number. It's not an actual delimiter. All right, cool. So just a quick overview. We learned how to load and save arrays either as special NumPy file formats, .npy, or multiple arrays as .npz, or we can also load and save them as text files, .txts. And we'll learn more about loading in other formats in future lectures, such as Excel files. All right, I'll see you at the next lecture. Hey guys, welcome to lecture 14 now. This lecture will be going over series. So this is going to be the first lecture where we start to take a look at the Pandas module. It's going to be a really useful module for analyzing data. So let's see how it works. First off, let's go ahead and import NumPy as np. Then we're going to import Pandas as pd. And from Pandas, we're going to import series and data frame. So series is what we're going to be working with mostly for this lecture. We're going to be using it so often that we don't want to have to write pd.series or pd.dataframe all the time. So we're just going to import those separately. So let's go ahead and click Alt-Enter. Let it import. Cool. So let's create a series. A series is like an array in NumPy, except it has data labels, so it's indexed. To show you what I mean, let's go ahead and just create an object here. And we'll call series kind of in the same way we were calling np.array. And we'll put a little list or array in it. 3, let's say 3, 6, 9, 12, just multiples of 3. And then let's go ahead and show that. Alt Enter. Cool. So let's take a look at what's different here. You can see that each value is indexed. So the 0 index we'll call a 3. If we want to just see the values of this series object, we can say call values on it, so dot values, and it'll show us the values in an array. If we want to see the index, we can also say dot index, and that will show the index values 0, 1, 2, 3. So each of these index values corresponds with the series values. So since index is a big part of series, and later on we'll see data frames as well, let's go ahead and create a series with an index that we specify. So let's go ahead and create a series. I'm going to call this one WW2 CAS. So we're going to make a series for World War II casualties. And I'm getting this information off Wikipedia. So let's say the numbers going to use are 8.7 million, so 1, 2, 1, 2, 3. And you can really put in any values you want here, but this is just for demonstration purposes. 1, 2, 3, 4.3 million, and then 3 million on this guy, 6 zeros. 2.1 million, 3 zeros, and then we'll go with 400,000, 2, 3. So those are the values of the series, and then we can say comma index equals, and now we're going to make an index for each of these value numbers. So if you know something about World War II, you might guess that that 8.7 million value belongs to the USSR's casualties. They suffered the most casualties in that war, as far as any allied nation. Then second ones was Germany's. Third one was actually China. Suffered quite a bit of casualties. Next one was Japan's casualties. And then last one was United States casualties. And let's go ahead and see what that series looks like. Cool. So now our index is actually the country name, and then the value is the number of casualties. So we can use index values to select series values. Should I show you what I mean by that? We'll type in our series name and then type in our index name. So let's say we wanted to know the casualties in the United States. We could call that, and then we'd get the 400,000 mark. A really interesting thing we can do with series is check with array operations. So let's say I wanted to check which countries had casualties greater than 4 million. The way I can do that, whoops, sorry for the spelling, add countries. So how can we do that using a series? Well, we can type out our series, and then we can just put in an array operation argument. So, for instance, we'll put in our series greater than 4 million. 1, 3, 1, 2, 3. So we're calling for the values that were greater than 4 million in the series. Let's go ahead and see what happens. Cool. So we get that the USSR and Germany are the two countries that had casualties greater than that 4 million mark. We can also treat a series as an ordered dictionary in Python. So for instance, if we wanted to just check if a index or value was in a series, we could say something like USSR in our series name, and we'll either get a true or false. We should get a true in this case since USSR is in our series, and we do get the true. Since it kind of behaves a bit like a dictionary, we can actually convert a series into a dictionary. So to do that, I'll create a dictionary name, call it ww2_dict. And the way to convert a series into a dictionary is just calling 2_dict on it. And then I'll show what that looks like. Cool. So now our series is actually turned into a dictionary. Let's say we wanted to convert it back into a series. We can call it whatever we want to name that series. And then we can just feed into the series command that dictionary name. So you can actually feed dictionaries into series. And let's just go ahead and show what that looks like. And now we have a series again. So let's say you were going to pass a dictionary into the series. The index will have the dictionary keys in order. So to show you what I mean by that, let's create a list. So how about we create another list of countries? Let's say China. Oops. These will all be strings. Germany. And you don't have to do this many, but this is just to follow along with the IPython notebook that's on the GitHub link. And let's just do Argentina for another one. So we have our countries. So we have a list of countries, and we can redefine another series. So we'll call it object2. Oops. So we'll have it be a series. We'll pass that World War II dictionary on it, and then we'll set the index to come from our list of countries. And we'll see what that looks like. So if you notice here, Argentina was not in our original dictionary list. So we scroll back up here and see ww2_dict only had China, Germany, Japan, USA, USSR. So since Argentina wasn't in there, Pandas, when you pass it through a series with a particular index that didn't have that value, it'll just give a NaN value, so it didn't find it, just that null value. Pandas has built-in methods to find null and replace them or check if they're there or not. Those are isNull and notNull. So let's take a look at what those look like. So we can call pd.isNull on that object2 we just made. And so it's going to check every value and see if it finds a null value there or not. So Argentina should have true since there was a null value there. Let's say you wanted to do the opposite command. You wanted to find where there were not nulls. So you can just call not null on the object. And then you'll get the opposite. So China, Germany, Japan, USA, and USSR were not nulls since they did have number values there. Argentina is false. It was a null. So it was not null. Sorry. Let's go ahead and check out that World War II series again. cool. So what we can do, another thing we can do in Pandas is we can add objects to series or series to series, and it'll automatically align the data by index. To show you what I mean by that, let's see what object 2 looked like. So they're the exact same thing, except object 2 has a null value for Argentina. So if we add up our World War II series, add it to object 2, what we should expect to see is in China have 6 million, Germany have 8.6 million, etc. But what we'll expect is that there's no value for Argentina. So let's just see what happens here. Cool. So it lines them up by index. You don't have to specify. Even if they're in the wrong order, it'll still add up the correct values by index. You can give your indexes or your series names. So for instance, object 2, we can name it to have a string name. So if we want to get more specific, we can call it World War II casualties. And then let's show you what happens when you do that. So it'll show you the series, and then I'll show you the name of the series, World War II casualties there. So when you're dealing with Python, it's still going to have this object name, obj2, but the actual series itself has a name, World War II casualties. You can also name the index. So since our index is just a bunch of countries, we can do that by calling index and then calling name on the index. And we'll can label that index as just countries. I don't know why I keep spelling countries. There we go. Countries. And now let's see what that looks like. Cool. And now you've labeled this index countries. It's a bit like almost like Excel, like you're labeling this index column countries. So that's a little intro to series. Next we'll learn about data frames. We're going to be working a lot with series and a lot with data frames, so you're going to see all of this often, so don't worry if you didn't quite get it this first time. You'll see it many, many more times throughout this lecture. Hi everyone, and welcome to lecture 15, and in this lecture we'll be going over data frames. So let's go ahead and start off with our regular imports. So what we're going to do is we're going to import NumPy as NP for array handling. And then what I'm going to do is import, I'm going to say import Pandas as PD. And that's the regular convention for importing Pandas. And now what I'm going to say is from Pandas, import series, comma, data frame. And the reason for that is because we use series and data frames so often in this course that it's better to just import series and data frame on their own than having to write pd.series or pd.dataframe when we use them. So these are three really standard imports that you're going to see constantly throughout this course. Okay, so we're going to learn about data frames. So in order to have a data frame and see what it looks like and how it works, we're going to need some data to play with. So we can go ahead and grab some NFL data from Wikipedia. And the way I'm going to do this is by importing web browser. And this is Python's built-in method to grab a web page. And then I'm going to say websites equal to, and I'm just going to edit copy and edit paste this link. But it's just the wikipedia.org page for the NFL win-loss records. And you can go ahead and check on NB Viewer or on my GitHub for that link there, in case you don't want to type it out yourself. And then in order to open this web page, I can just say web browser dot open, and then I open that URL, which I set as an object website. So if I hit Shift Enter, it takes me straight to that web page. So here we have a little bit of a spreadsheet, if you will, of different NFL win-loss records. We have various columns and various rows. So what we're going to do here is there's many ways to create a data frame. But for now, since we're just interested in the inner workings of a data frame and not how to create one from scratch, I'm going to show you how to copy and read data using Pandas in order to grab a data frame. So let's go ahead and just edit, copy, edit, paste the first 5 rows here. So I've highlighted them. I selected edit, copy. And now that whole section is on my clipboard. And I can copy and read data from my clipboard, which is really awesome. And what I'll do here is I'll make an object called NFL_frame. And that's going to be our data frame name. So I have NFL_frame. And to read everything I have on the clipboard, I do pd.read_clipboard. Close parentheses, no extra arguments. And now Pandas has a built-in function to try to read everything that's on your clipboard and set it into a data frame. So if we actually just see what that data frame looks like by calling that object, Shift Enter, you can see that Pandas has transformed everything that was on the clipboard into a data frame. So you can think of a data frame as almost like a spreadsheet or an Excel spreadsheet. And if you notice here on top, we have the column names. And on the left hand here, this very first column, that 0, 1, 2, 3, 4, that's actually the index of the data frame. And Pandas does that automatically. If you notice here, that wasn't actually included, so don't confuse that with the rank. Pandas will automatically make an index here. And in future lectures, we'll learn how to rename that index or make index hierarchies. But for now, let's just learn a bit about the data frame. If you want to grab the column names off a data frame, that's actually quite simple with Pandas. You just call NFL_frame dot columns, and then Pandas will return to you the name of every single column. And don't worry about this U. But now you have the names that you need to call in order to get those columns. And there's 2 ways you can grab a column name. You can have your data frame name and then dot the column name, and it will return to you a series with that those values in that column. So you can see here we have the rank, or we could also say, for instance, team, and it'll return the teams. Now you're not going to be able to do this with columns that have more than one word in it. For example, first season. The way you grab those columns is with an index call, if you will. And I say index just because of the formatting of the brackets, not because it's an actual index call. So hopefully that wasn't too confusing. But you can call it like this for first season. And now we have all the values in that first season column. So it's just important to note, you need to spell and format your column name exactly like it's spelled in your data frame. And the way you can make sure of that is just by calling this dot columns, and Pandas will report to you what it's expecting to be called if it wants you to grab that column. So first season matches up with first season here. Great. So let's go ahead and grab multiple columns. So we can do that. We can actually call a data frame. So we can say data frame, grab data from the NFL_frame, and set the columns we want to grab. And I can actually pass a list of columns. So I'll say I want the team column, the first season column, and then the total games. So what I've done now is I've actually created a new data frame from my NFL frame, and I've grabbed the columns that I wanted. So now I have my team, my first season, and my total games played. And let's go ahead and check what happens if we ask for a column that doesn't exist. So for instance, let's say I just copy and paste this, And let's say I had included in my list a stadium column. Now if you note here, in our original data frame, there is no stadium column. So let's see how Pandas deals with this. I'll shift enter here. And instead of returning an error, what's really nice about Pandas is it just fills in that column with all null or non-applicable values. So you have a bunch of null values here, but your data frame still works. Great. So now let's go ahead and see how we can retrieve rows off a data frame. So let's go ahead and see what our data frame looks like again. NFL frame. Great. Now, another quick note to say, if I wanted to retrieve just the first few rows of a data frame, I could say NFL underscore frame, your data frame name, dot head, and it'll retrieve to you the first 5 rows. Or if you pass a number through it, it'll retrieve the first 3 rows, the first 2 rows, etc., etc. And if you want the end rows, you can do the same with just tail. And now it'll give you the last 2, the last 3. By default, that number is always 5. So if you just call head or tail here, since we only have 5 rows, it'll actually just return the whole data frame in this particular case. But you can use tail and head to grab either the last rows or the first rows, depending on which one you call. So that's one way to grab rows. But let's say we want to retrieve rows on a particular index. The way we can do that is by calling our data frame, NFL frame, and then we pass the ix method for index. And then let's say I want everything that's on index 3. And that gives me back the Miami's Dolphins information. So remember Pandas, and in Python in general with NumPy, indexing always starts at 0. So I'm grabbing the 4th column or 4th row by inputting index 3. And now I have a returned object with all the information on that row. So that's one way you can retrieve information. You can also assign values to entire columns. So for instance, I grab my NFL frame, and let's go ahead and grab that stadium column. And I can set my equal sign in order to assign values to it. So I can see, let's say Levi's stadium. And something to note to be careful here, since I have a single quote there, I need to use double quotes to end my string. Just a quick note. So what is this going to do if we go ahead and check it out? Now let's see what happened to our data frame. So Pandas now, if you only pass that one argument to assigning it to an entire column, it'll fill in that entire column with that particular stadium name or whatever value you happen to be working with. Great. So let's try another example to make sure we really understand this. I'll grab my data frame column again. I'll do it the stadium column again. And let's say I wanted to pass in some numbers. So just put numbers for every stadium, 0, 1, 2, 3, 4, 5. I can do that by just calling np.arrange, as we've seen in the past. And since I have 5 rows, I need to pass one more in my arrange. And what was the error here? If we look at it, notice the length of values does not match the length of index. So I actually only have, I only have 5 rows there. So now that makes sense. Remember, the indexing starts at 0. So 5 was the correct there. I apologize for that. And now if we look at what happens with our data frame, now we have 0, 1, 2, 3, 4. So those numbers that NumPy arranged for us. And again, sorry about that previous mistake, but since you have 5 rows, you import NumPy arrange 5. Okay, great. So what if I want to add a series to a data frame? How how do I do that? I can say stadiums, let's make a new object called stadiums, is equal to series. And then let's go ahead and pass a list. So I'll say, again, Levi's Stadium. And then I'll have my AT&T Stadium as another series object. And I'll set this to have an index of 50. Okay, so let's see what stadiums looks like now. Great. So if you notice, we actually are going to be out of index, so let's go ahead and change that to 40. Make sure that works. Okay, great. So what I have here now is a series where I've put in 2 values into my series as a list, and I've assigned them that index. So 1, 4 for Levi Stadium, and then a 0 index for AT&T Stadium. So how do I input that into my data frame? Well, it's actually pretty simple. I just say NFL underscore frame. I call that data frame. And then I call that column that's on that data frame. And then just set it equal to stadiums. And now if we check out what that data frame looks like, we can see that it's actually assigned stadiums to the NFL data frame. And again, Pandas takes care of null values really, really well and fill those in for you where it didn't have the information. You can also delete entire columns, and you can do that just by calling del and then whatever the column you want to delete is. So in this case, let's go ahead and delete that stadium column. And if we check out what the data frame looks like now, you can see that entire column has been deleted. Great. So we went over how to kind of mess around with a data frame, and we constructed that data frame just by copying and pasting. You can also construct data frames by passing in dictionaries, and I'll show you how to do that right now. So let's just go ahead and make another object called data, and I'm going to make a dictionary for this. So my dictionary is going to have 2 keys. It's going to have city, and that's going to be a list that we'll fill in a little bit, and then it's also going to have population, and again that will be a list. So let's say I want 3 different entries here. So let's go SF, LA, NYC, and then my population, I just looked up these numbers a little earlier, so it's going to be 83700, comma 3881123. So LA has quite a large population, and then 1, 2, 3, 4. Okay, so now I have my dictionary here. Let's run it, make sure it works out. Okay, great. So you can construct a data frame just by passing a dictionary, and I'll show you how to do that. So we'll make a new data frame called city underscore frame. I'll have it be called data frame, and I can pass in that dictionary. And let's go ahead and see what that looks like. Great. So Pandas can automatically take in a dictionary as long as it's constructed correctly, and these lists match up as far as number of data points in them, and it'll automatically construct that data frame for you. So there's a ton of ways to create data frames in Pandas, and we'll be exploring them as we move on throughout this course. But for a full way of creating data frames, I'm going to edit, copy, and edit paste this link here. You can just check out the documentation, and if you go to the link here provided, pandas.dataframe, it gives you all the API methods you can use on that data frame, And if you just keep exploring throughout this documentation on data frames, you'll learn all the different ways you can construct data frames. So from dictionaries, from records, from CSV files, and we'll learn how to do all that throughout this course. But for now, that's just a quick overview on what the data frame is in Pandas. You can think of it just basically as a spreadsheet, and hopefully a few methods for you to mess around with columns and rows names. So this is going to be one of our main tools in data analysis throughout this course. So I encourage you to check out the documentation on the Pandas website. All right, thanks guys, and I'll see you at the next lecture. Hey guys, welcome to lecture 16. This lecture is going to be on index objects, which we've been learning about in series and data frames. Let's start off as always, just importing the regular stuff. You can go ahead and just copy and paste this if you want to. We're going to import series and data frame, and then import pandas as PD. Okay, so let's just go over quickly about series and index objects. So we'll create a series, we'll call it my_ser, and we'll create this series by, let's just make it a 1, 2, 3, 4 array, or I should say list in this case. We'll pass a list, and then we'll define the index as A, B, C, and D. Okay, and then we can just take a quick look at what that appears. Alright, so now your index is A, B, C, D, since you specifically set that through that list, and your series is 1, 2, 3, 4. Let's say I wanted to get the index. I can set that as an object. I can say my index, and you might remember this from previous lectures. You can just get the index by saying .index. Let's go ahead and show what we set. Cool. So now we have our index unit. Just don't worry about this U. It won't actually be part of the index. It's just indicating that it is the index. So we have A, B, C, D. And it's object type. We can grab index values just by calling them. So let's say you wanted to grab that number 2 index value. Think about what you'd expect to pop up. So it's C. If you were thinking B was going to pop up, remember that the index starts at 0. So it'd be 0, 1, 2. So out of that list, the third object appeared since we called it 2. 0, 1, 2. So that should be letter C. Let's say we wanted everything past 2. Then you might remember just from knowing Python that you can use a colon to indicate everything. So this should get us everything past the second index marker. And it does. It gives us C and then D. So those are basically the main ways to mess around with an index. .index to call it off the series, and then you can input specific values you want just by calling them through the array's index value. What happens if you try to change an index value is a good thing to test. So check my index, the very first one, 0. We should get an A out, and we do. If we wanted to change this, let's say we try to do 0, and let's say we try to change it to Z. What would happen? Well, you get an error, which is good. So indexes don't support mutable operations. And what that means is that indexes are immutable, so you can't change them like this. You'd have to pass an entire new index. which is good because that makes the data frames or series really stable. You can't just be changing index values willy-nilly, in a sense. If you wanted to re-index, we can do that. So that will be lecture 17 on re-indexing. Take a look and just make sure you understood everything in this lecture. We'll be doing tons of indexing and re-indexing in the course. This is just a brief intro on it. So you'll see this again and again. Alright, I'll see you at lecture 17 to learn about re-indexing. Hey guys, welcome to lecture 17. This will be on re-indexing. So last lecture we went a little bit over indexes, how they work, how you can call certain index values. We're going to learn how you can re-index and change the index if you wanted to. So we're going to import the usual NumPy as NP from Pandas. We're going to import series and data frame. We're going to import Pandas as PD. And the last thing we're going to do, which is a little different from usual, is from numpy.random, we're going to import the rand_n, which will grab numbers with a normal distribution. So we'll just use this later in this lecture just to grab some random numbers. So let's go Alt Enter, import all the libraries we'll be using. Let's go ahead and create a new series. We'll just call it SCR1. And we'll build this series the usual method. So we'll call the self to be just a list, 1, 2, 3, 4. And then we'll set the index as A, B, C, D. And then we'll show what that looks like. Cool, so now we have a series A, B, C, D indexed, and the values are 1, 2, 3, 4. So let's say you wanted to re-index, to rearrange the data to a new index. How would this work? To show you, let's go ahead and start building a new series. We'll call it SCR2. And this new series is going to be built off series 1. And now we're going to call re-index on SCR1, our first series. And we'll pass a new re-indexing list. So we'll call it A, B, C, D, and we'll go all the way to F on this new index and see what happens. Let's go ahead and show it. Awesome. So Pandas, since it's very good at dealing with missing value points, when you re-indexed it, E and F didn't exist in your first series, this SCR1, so it automatically just gave it null values for E and F, which is really nice. So you won't have to worry about doing a perfect re-index or not having values for your re-index. Pandas will automatically give you null values there. We can also fill in values for new indices we write. So for example, if we re-index our second series that we just made, we'll go A, B, C, D, E, F, and now we'll bring it all the way to G. If we wanted to fill certain values, we can pass the argument fill_value and set that equal to something. In this case, I'll set it equal to 0. So what that should do is instead of passing a null, it will pass a 0 as the new index values. Cool, and that worked. So our original series 2 was 1, 2, 3, 4, null, null with E and F. I re-indexed it, and I added G to the index, and I also passed the argument fill_value equals 0. So since G was the new index, it'll be filled as a 0 which we saw here. E and F stay null since those existed in the previous index. All right, cool. You can use particular methods for filling values. So to demonstrate that, let's go ahead and create a third series. We'll call it SCR3. And in this case, let's go ahead and pass just a list of countries as the series. USA, Mexico, and Canada. Alright. And we'll have the index just be some list of numbers. Let's go 0, 5, 10. Alright. Let's go ahead and show that. Cool. So we have our third series. The values are just USA, Mexico, Canada, and the index is 0, 5, 10. Let's say we wanted to re-index this all the way from 0 to 14. How would we do that? And what would we want to fill? So we can call reindex, and for the reindex self, we'll just pass range 15. And to give you a better idea of what the range will do, I'll actually pass it separately. So I'll make a new object called ranger and call this range 15. And let's take a look at what ranger is. So range just makes a list of 15 points, as we've seen before in NumPy. And it goes from 0 to 14, since the index starts at 0 for arrays. So back to reindexing this third series we made. I'll call ranger, which would be the same as just typing range parentheses 15 in there as the argument. And I can pass the argument method. So what kind of method do we want to fill for interpolating values between the new indices that we're going to put into it? So one argument we can pass is ffill. So this stands for forward fill. So what's going to happen is, right now our index on series 3 is 0, 5, and 10. But we're going to be filling it with a bunch of values. So 0 will have USA. 1, 2, 3, 4 would be null if we didn't have a method argument here. So what's going to happen instead when we say forward fill, it's going to grab the previous value, USA, and forward fill it for the next indices until it hits something that already had a value. So that will be 5, Mexico. And then for 6, 7, 8, 9, it's going to forward fill those with a previous value, which was Mexico. And then once it hits 10, that already has a value, Canada, and it'll forward fill the rest of them, Canada. So let's see if that works. And that's what we get. So it forward filled USA into the next 4 index values. It forward filled Mexico into the next 4 index values, and it forward filled Canada. There's different methods you can pass. You can check out the documentation for the different methods. You can do a backwards fill, which would be basically opposite. Mexico would then fill everything back, and Canada would fill everything back, and then these guys would be nulls since there's nothing ahead of them. So let's say you wanted to reindex rows, or not just rows, but columns, or even both of them. How would you do that? So in order to see that effect, we'll make a whole data frame. So we'll call this object dFrame. We'll call data frame. And how should we build this data frame? Let's say, what do we want the self to be? We'll call 25 random numbers, And then what we're going to do is pass or call reshape on this. So rand and 25 will just get you a list from 0 to 24. And then if we call reshape, we can actually, instead of having it be just a straight vector, we can indicate it to be a matrix. So this can be a 5 by 5 matrix. So those will be the values of the data frame. It should be a random numbers 5 by 5. Let's go ahead and give it an index. So the index for all the rows. Again, we'll just use a letter index here. And let's skip C just to show you an effect that later on. And we'll go to F. So we have 5, one for each row of this 5 by 5 matrix. And then if we want to set the columns, we just pass the columns argument. And we'll just label them call 1, call 2, and I'm running out of space here, so I'm actually going to start this on a new line. Remember to have the comma there. Call 2, call 3, call 4, and there's going to be 5 columns since it's a 5 by 5 matrix, so we'll stop with call 5. So that will be our data frame. It's going to be, we asked for 25 random numbers, we reshaped them into a 5 by 5 array, so that's the values of that data frame. Then we set the index of the rows just to be A, B, D, E, F, we skip C. And the columns will just be called call 1, 2, 3, 4, 5. You can call the columns whatever you want. And then we'll type dframe just so we can see what it looks like. Cool. So like I said, A, B, D, E, F is your index for your rows, and we have our column names, and you can see the random numbers that are filled in the data frame. So since we forgot C, let's re-index onto the data frame. So we'll call a new data frame, dframe2, and we'll have that be equal to the old data frame with a re-index called on it. And in this new new index, we won't forget C. And then we'll go all the way to F. So what's going to happen when we do this? Let's find out. We'll call dframe2. Think about what you think is going to happen and how Pandas deals with the re-index values. And if your intuition is right, then you should have guessed that it would add null values in for that entire C row, just as if we scroll up, it did before for the values in the series when it was re-indexed. Cool. We can also explicitly re-index columns. So let's go ahead and just make a list called new columns. Call it call 1, call 2, and let's go all the way out to call 6 this time, since we only went to 5 previously. So we make a list new columns, and now we're going to grab the dframe 2 that we just made. It's this one here above with that new C row. And we're going to call reindex on it. And the reindex, for a reindexing of the columns, you have to call columns specifically. And then you can say equals. And we could either manually type in this list or just call it using its name, new columns. So think about what you expect the data frame to look like now. Hopefully you guessed right. Column 6, you added it in, and Pandas automatically put in null values for that entire column. Cool. You can reindex really quickly just using .ix. We'll see more of this in the future. We've seen a little bit of it in the original indexing lecture, but we'll see about much more in the future. Just to give you a little taste of it, let's see the original data frame, D frame. And we can call IX to reindex. The first argument it takes is your rows. So we'll just call it A, B, C, D, whoops, E, F. And then the second argument it'll take is the columns. So we'll just pass new columns. So this is our original D frame. Remember, it's missing the C and it doesn't have that column 6. And now using IX, we're going to really quickly reindex it just in one single quick step. So Alt-Enter to see that. And boom, now you have the same D frame that was D frame 2. So instead of having to reindex everything separately, the faster way to do it is using IX. And we'll see more of this in the future. Alright, excellent. So I'll see you in lecture 18, and we'll learn more about data frames and how they work. Alright guys, welcome to lecture 18. This will be about dropping entries from data frames in series. We'll just call it drop entry. So let's take a look at how this works. First off, we're going to import the usual. You might just be copying and pasting now, but I'll just always be typing it out. Import NumPy. Then from Pandas, we're going to import series and data frame. And then we're going to import Pandas as PD. Alt-Enter. Alright, great. So let's create a new series to play with. We'll call it SCR1. Call series, and what are we going to pass as the series? Well, we'll just pass NumPy's arrange function. We'll have it just be 3, which should be 0, 1, 2, and then I'll set the index as A, B, C. Alright, let's go ahead and show that series. Cool, so we have our range 0, 1, 2, that was 3 points, and our index A, B, C. So what if we wanted to drop an index? How would we do that? Well, in Pandas, it's actually pretty easy. You just say call drop on your series, and then put the object you want to drop, so that index label. So let's say we wanted to drop B, and then boom, that whole row is dropped. Anything that was indexed with B is now dropped. So let's look at how this works with a data frame. In order to do that, let's make a data frame. So we'll make dframe1, call data frame, and let's go ahead and input. We'll use NumPy arrange to create a array of 9 numbers, and then we'll call reshape on it like we've done in the past, and we'll just make it a 3 by 3 matrix. Awesome. So now that we have our data value points, let's create an index. In this case, I'm just going to make the index city initials, just to mix it up a bit. And last, we just need to name the columns. And we do that by passing the columns argument. And let's make a list. So I'll make one pop for population, maybe another for size, and then a year column. We won't actually be filling this with real data, so you can call them whatever you want. And let's go ahead and show the dframe1 to see what we got. Alright, so we have our range of 9 points, 0, 1, 2, 3, 4, 5, 6, 7, 8, arranged or reshaped into a 3x3 matrix. We have our index, SF, LA, and Y, and the column names, pop, size, and year. So if we want to drop a row, we do it just like we did for a data frame. We call a drop on the data frame, and then give the index of the row we want to drop. So if we wanted to drop the index LA row, we'll do that, and that will get rid of that. So this doesn't actually permanently affect your array. If you wanted that to happen, you'd have to save another array with the drop. And now if I see dframe 2 and show it, it's going to drop it permanently. But the original dframe, dframe 1 will still retain LA. So what if we wanted to drop a column? Well, it's a very similar process. So dframe 1, drop. You give the column name, year. But now since we're not going to be dropping a row, we need to specify which axis we want to use. And in this case, the axis for the columns is axis 1. By default, the drop uses axis 0, which would be your rows. The columns would be axis 1. And so you can see we've dropped the year column and now just have a 3x2. And that's about it for dropping entries. You just use .drop. If you want to drop a row, you just gotta name the index of that row and it'll drop it for you. If you want to drop a column, just gotta name the column and then specify that it's on the 1 axis, or axis equal to 1. Cool. So next we're going to learn about selecting entries in the data frame. Alright, I'll see you there. Hey guys, welcome to lecture 19. This will be selecting entries. Oops. Alright, so as always, import the usual. Import pandas as PD, and then from pandas import series data frame. Alright, awesome. So let's just create a series. We'll call it SCR1. And let's go ahead and again use the NumPy arrange method. We'll just have it be 3 points. And we'll set the index as usual for 3 points, just A, B, C. Awesome. And what I'm going to do here is I'm going to set series 1 equals to every value doubled in series 1. And I'm going to do that to avoid some confusion in the future, and you'll see what I mean later. So we created a series. Originally it would have just been 0, 1, 2, but we doubled every value in it with some multiplication. So now it's 0, 2, 4. And that created our series, or SCR1, that series. Alright, so let's learn how we can select some data. So we can grab entries by the index name on a series. So if we call that series, we can just grab it by the index. So for instance, if I wanted the 2 value, its index is B. So if I call that, I'll grab that 2. Or I can just grab it by its numerical value of the index, that is. So the index will always have a numerical value starting at 0. So A is 0, B is 1, C is 2. This is why I multiplied the values by 2 to avoid any confusion. So if I said SCR1 and call the 1 index on it, that will be the same as the b index, and I'll get the 2 value out. We can also grab it by a range, so I can call from 0 to 3, and that will give me all of them. Awesome. So that's the 0, 1, and 2. 3 was not inclusive there. And we can also grab it by a range of index values as well. So the actual index value names. And I can do that by passing a list. So let's say I just wanted those first 2 values. That'll get me the A and B value. So instead of using the numerical index values 0, 1, 2, I can actually call them by their names. We can also grab by logic, and what I mean by that is just using some Boolean logic or just basic equations. So I'll show you an example. So we have our series, and what do we want to grab from it? We can say, go ahead and grab everywhere that the series is greater than 3. And if I select that, it gives me C4, which was the only value that was greater than 3. And we can also set values using this kind of method. So we can say, where it's greater than 3, where series 1 is greater than 3, let's go ahead and set those values equal to 10. And then let's show what it looks like. And now it's replaced any values that are greater than 3 to 10. Awesome. So now that we've seen how selecting entries works in a series, let's go ahead and see how it works in a data frame. So we'll start by making a data frame. First thing we're going to pass are the actual entries, those values. So we'll do it by just getting an array of 25 entries, and let's go ahead and reshape this into a 5 by 5 array, or a matrix, sorry. What's next? We gotta set up the index if we want to have it actually labeled, and we'll use cities again. What else is there? San Francisco. Let's go with DC for Washington DC, and then maybe not sure, Chai for Chicago. And then we can also have the columns by passing the columns argument, and I'm going to start a new line here. Make sure you have this comma here before you start the columns argument. This comma. And then we can go ahead and pass a list. We'll need it to be 5 letters long, so we'll just do A, B, C, D, E. Perfect. And then we'll just show that D frame, that data frame. Cool. So we have our index labeled by cities and our columns labeled by letters. The data itself was just an array from 0 to 24 that we've reshaped into a 5 by 5 matrix. So how do we select data from a data frame? Well, you can select it by column name. So you can call the B column, and that will grab you all the values in that B column. So 1, 6, 11, 16, 21. You can select multiple columns in this same manner just by passing a list. Notice how I'm using 2 sets of brackets here. So if we wanted BE, we call that, and then we get the BE columns. And just like we did in the series, we can use Boolean logic as well. So we can say, give me the data frame values where C column, is greater than 8. And if we pass that, it's going to give us this as a return. So it's giving you every row as the answer where C was greater than 8. So if we look back at our original D frame, the first 2 rows C was less than 8, the last 3 it was greater than 8, so it passed. It gave us the last 3 rows of the entire data frame. You can also show a Boolean data frame, and a Boolean data frame will just have Boolean values, so true and false. And I can do that just by asking, hey, where is D frame greater than 10? And then it'll give me a Boolean data frame, so everywhere that's labeled false, you can see the data frame was less than 10, and everywhere that's true, it was greater than 10. Cool. And as we previously discussed, we can use IX to label index. So to show you an example, we can say dframe IX, and we can pass LA, and it's going to give us those LA values. So that LA row was 5, 6, 7, 8, 9, and it's given us 5, 6, 7, 8, 9, and the columns as the index values. So another quick example, we can also do this by asking for the 1 row value. So remember, indexing starts at 0. So 0, 1, so that should also be LA. 0 was NYC. And if we check that out, what do we get? We get the same thing as calling LA. Cool. So we'll be selecting entries a lot during this course, so you're going to be seeing this over and over again, and hopefully as we create more data frames and create more series, you're going to feel really comfortable just making data frames right off the bat with NumPy arrange and then creating index lists and column lists. Alright, awesome. So the next lecture we'll learn about data alignment. I'll see you there. Hey guys, welcome to lecture 20. So what we're going to learn about here is data alignment. Alright, so we're going to learn about arithmetic between data frames with different index values. Start off as always, import NumPy as NP, import Pandas as PD, and then from Pandas import series and data frame. Okay, so let's go ahead and start by making 2 series. First one, we'll just pass a list 0, 1, 2, and then we'll make the index letters. Whoops. We'll have to pass a list of letters for brackets. There we go. A, B, C. And let's go ahead and show that. Alright, so we have 0, 1, 2, index A, B, C. Let's go ahead and make the second one. We'll call series, and we'll call 3, 4, 5, 6. So it's going to be one longer than the first series we made. And the index will pass A, B, C, D. Now let's go ahead and show that just to see what it looks like. Alright, 3, 4, 5, 6, A, B, C, D. Awesome. So what's going to happen when we add these together? Let's go ahead and find out. So SCR1 plus SCR2. So let's take a look at what happened. Pandas added up the values where the index matched. So A in the first series was 0, A in the second series is 3, so 0 plus 3 is 3. What it wasn't able to do is add where series 1 didn't have an index value matching. So series 2 had a value of 6 at D, but since series 1 didn't have a D index, it's going to replace it with a null. So the null values will be added automatically if you don't have a matching index in both series. So let's see what's going to happen with data frames if we try something similar. So I'll make D frame 1 my first data frame. And we'll pass NP arrange. We'll have it before long, and we're going to reshape this into a 2x2 matrix. We'll make columns. An interesting way to do this is we can call list, which is a Python function, and we can put in A, B as a string, and what list is going to do is it's going to make a list out of A and B. So the columns are just going to be A and B. This is just a little trick we can use in the future to save some time. And then index, well, I'll just use cities again. Oops, LA. Alright, and then let's go ahead and take a look at what that data frame looks like. Whoops. So I accidentally forgot a non-keyword argument after a keyword, and that is the equal sign here. So we forgot to say index equals. Now let's see if it works, and it does. Awesome. So I have my data frame 0, 1, 2, 3. It's got reshaped to a 2x2 matrix, and the cities are the index and the letters are the column values. Let's make a second data frame in a similar fashion. In this case, I'm going to make a 9 point array and reshape this into, you probably guessed it already, a 3x3. We'll have the columns. We'll use our little list function trick again. And in this case, we're going to need 2. So I'm going to say ADC. I'm skipping B on purpose so we can see its effects later. And then index will equal NYC SF and LA, since that was in the last one. And notice something I was accidentally doing here. I accidentally dragged this parentheses, and you can see that IPython will highlight which one it's matched up to. So I'm going to delete it here and bring it back down to reshape. Awesome. And then let's go ahead and see what that looks like. Cool. So now we have our 3x3 ADC column data frame. So what happens when you add D frame 1 to D frame 2? Take a moment, pause the video, see if you can guess at what's going to happen. Look back and see what happened to the series, and try to think of what's going to happen when we add these two data frames together. Alright, let's take a look. So the only two that it was able to successfully add was the A column for the values LA and NYC. That's because those were the only two where the row index and the column matched up. The rest of them had null values. So what if we wanted to replace the null values? What could we do? Well, we can call our D frame 1, take a quick gander at what it looks like, and then say D frame 1, we can use add. So this is a we can call add to it instead of adding it directly with that plus sign. So we'll say add. First thing we're going to do is what are we going to add to this D frame? I'm sorry, D frame 1. Well, we can add D frame 2 to it, And then another argument we can pass are the fill values. So I'll put fill underscore value, we've seen this before in the past, as 0. So what's going to happen now is something a little different. You can see we only have one null value now, and that was the B for SF. So if we look at dframe2, I'll just type it out again. For instance, B of LA or LAB was a 3 value in dframe1, and there was no B column here. So previously that would have resulted in a null, but since we had our fill value be 0, it filled in zeros for the data frame, the second data frame's value. So then it kept the original dframe1 value. So BLA was 3, and now BLA is 3 in this added data frame. So this is going to be a really important tool if you're going to be adding different size data frames but don't want to lose all your data to null values. You can just select fill values to be 0 and it'll use the original values of the dframe1 unless there is a value. So what about operations between a series and a data frame? So we see what the second data frame there looks like. Let's go ahead and create a new series. We'll call it SER3. And we're just going to make it from the second data frame's 0th row. And I can do that just by calling it like that. And let's take a look at what it actually looks like. So here's dframe2. That was a 0th row, so the NYC row, I made a series out of it, 0, 1, 2, and its index are the column names ADC. So we can use arithmetic on it, just some operations. So we can say something like dframe2 minus that third series we just made, and that'll just work perfectly since there's values for every column in that NYC row, so it's going to subtract it completely from dframe2. Alright, so up next we're going to learn about sorting and ranking. I'll see you there. Hey guys, welcome to lecture 21. In this lecture we're going to be learning about ranking and sorting. So how to use rank and sort. Let's go ahead and check it out. First off, we're going to import the usual stuff. Import NumPy as NP. From Pandas, we'll import series and data frame. And then finally we'll import Pandas as PD. Alt-Enter to get a new cell. Alright, cool. So, as usual, how about we make a series to play with? So I'll make the series and I'll call Python's range function. I'll get 3 points, and then I'll pass an index argument, and we'll say it's CAB index, and let's just see what that looks like now. And the reason it's not in ABC order is so we can actually use sort. So if I wanted to sort this index, how would I do it? It's really easy. You just take your series name and then you call sort index on it with close parentheses. We don't have to pass any additional arguments there. Let's go ahead and see what happened. Awesome. So now my index is sorted, A, B, C, and it sorted its values associated with that index along with it. Let's say you wanted to order a series by its values, not by its index. Well, you can do that too. So if I wanted the order 0, 1, 2, basically what we had before, I can take my series and the argument I can, or what I can call on it is order with close parentheses. And order will order it by the values themselves, 0, 1, 2. When sort index, we'll sort it by the index values A, B, C. So that's sorting. And let's get an idea of how ranking works. So in order to do that, I'm going to import, as we've done before in the past, from the NumPy random library. I'll import rand_n. Let's go ahead and do that. And then make a new series. And this series is just going to be 10 random numbers. So I'll pass in the 10 argument, and we'll see what that looks like. Awesome. So now we have 10 random numbers. And let's say I wanted to sort them and see how they rank. So let's just sort them. ser2.sort. And now let's check it out. All right. So now we've sorted all the values in this series from lowest to highest. That means that every value in this series had a rank. If you notice, the index values are all jumbled up because they were in order at first, but the values weren't. So when you sorted it, it sorted it by value, and now your index values are a little jumbled up. What if you wanted to know the actual ranking of each value in the series? Well, I can show you by calling rank on our series. And you notice rank then shows in perfect order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this rank value is what is actually being sorted. So previously all these numbers had a rank value, and then what sort does is it takes the rank value and just puts it in ascending order. And that's how ranking and sorting works. So on the left column we see the original index value, and on the right we see its rank value. Let's go ahead and, just to get a clearer picture on that, we'll do it one more time. We'll make a third series. I'll call another random 10. See what that looks like. Okay, so I have, again, 10 random numbers. Let's go ahead and check out their rank right now before I sort them. Oops, sorry. Series 3. Alright, so you see the ranking, while the index is in perfect order, the rankings are all over the place. So what will happen when I sort and then check the rank, you'll see that the rankings are now in order, but the index that was associated to each value is all mixed up. And then let's check out what the series actually looks like now, series 3, and like we saw before, everything is now sorted by its rank. So that's the relationship between rank and sort. Each of these values has a ranking, and sort just ranks them, or yeah, sort just ranks them by that ranking value. Alright, cool. So next up on lecture 22, we'll learn about using descriptive statistics on data frames. I'll see you there. Hey guys, welcome to lecture 22. In this lecture we're going to be going over some summary statistics. Sorry. So Pandas comes with some really good methods you can call on data frames. They're all built in, and you can summarize data in these method frames. So let's go ahead and start off with importing NumPy as NP. Basically our usual stuff, importing from Pandas, import series and data frame, and then import Pandas as PD. Awesome. First off, what we're going to want to do is create a data frame to work with, and I'm going to construct this data frame from a matrix that I built using np.array, like we've done in the past before. Let's go ahead and make this a 2x3 matrix. So the first row, I'm going to give it 1, 2, and then I'm going to do something a little different that we haven't seen in the past before. I'm going to make the third value np.nan, so I'm going to make it a null value, and you'll see why I do that later. And then same thing for the first value in the second row. It's also going to be NaN, and then I'll give it some numbers there. So let's go ahead and make that matrix. And now to build my data frame, we'll call it dframe1. I'll pass the matrix I just made. We'll give it an index. Index will be AB. And the columns, we'll call them 1, 2, and 3. All right, let's see what that looks like. So for my matrix, that was 1, 2, null, null, 3, 4. Now we have it in a data frame with A and B index, and the columns are called 1, 2, and 3. Cool. So let's see the sum method in action here. Just take a look at what happens. So what is this going to do? So sum on a data frame, it's going to sum up all the values for each column. So for instance, the 2 column, 2 plus 3 is 5. And you notice something that's really nice about Pandas when you're calling sum. It's going to ignore null values, so it's not going to crash on you just because you have null values there. It's going to be able to just ignore them and treat them as zeros, so it's just going to skip them over. Okay, what if we wanted to add up the rows? Well, you can do it the exact same way. You just got to indicate that your axis is 1, and now you've summed up the rows instead. So row A, 1 plus 2 is 3, and then row B, you have 3 plus 4 equals 7. Cool. What other methods can you call on a data frame? Well, you can call the min method on a data frame. And what is that going to do? Let's take a look at our data frame again just to get a picture. The min method is going to find the minimum value in each column. So with the 1 column, the 2 column, 3 column, the minimum value, if we take a look at the 2 column, it was 2. Since it's comparing 2 and 3, 2 is the smaller number there, so 2 was the minimum value. So it returns the 1, 2, and 4 values there, the minimum values for each column. What if you wanted to find the index of the minimum value in each column? There's a method we can pass there as well. In that case, it's just going to be idxmin, and that's going to give you the index of each of those minimum values. So if we take a look back at the minimum values that were 1, 2, and 4, which index were they in? So the 1 column, its minimum value is 1, and if we look back at our data frame, the index for that value is A. So A is the index of the minimum column for, or the minimum value for column 1. Let's go ahead and look at column 2. What was its minimum value? Its minimum value was 2, and the index for that minimum value was A. And then finally, column 3, its minimum value was 4, and the index for that one was B. And so idxmin will return the index of the minimum values in each column. All right. You can do the same thing with finding the maximum values. They're the exact same methods, but instead of writing min, you just write max. So let's go ahead and see our data frame one more time. 1, 2, null, null, 3, 4. We can also do an accumulation sum if you wanted to. The way to do that, it's really easy. Just come sum, call it on. Whoops. Remember we called it dframe1. Go ahead and pass that. And now you have the accumulation sum along the columns. So the only place you're going to see the difference there is in column 2, where column 2 index B, its value is now 5. Since the accumulation sum was 2 plus 3, it changes that value to 5. Cool. So now that we've gone over some basic methods, let's get into the real useful features of Pandas. So one of the most useful features is something, a method called describe. Let's go ahead and just see what that looks like. So if we call describe method, I'm sorry, there we go, D-frame 1. So what does describe do? So describe is going to provide summary statistics for your data frame. So it's going to give you a bunch of statistics on your data frame. It's going to count how many objects you have, going to give you this mean, the standard deviation, other statistics to find values within certain distributions or probabilities beyond the mean. And you can get that all just by passing describe. Cool. So speaking of statistics, what else can we get? We can also get information. We can get information on the correlation and covariance of your data in your data frames. So what I'm going to do now is from ipython.display, I'm going to import YouTube video. And this is going to allow me to actually show you some YouTube videos. So in case you're if you feel like you need a refresher on covariance and correlation, or you just want to learn a little more statistics, since you're going to need to understand covariance correlation for the rest of this lecture, there's some really great videos on YouTube, the best sources on the internet that I found for learning basic statistics. And I'm going to go ahead and put the links here so you can see it. And again, you can just grab these from the IPython viewer notebooks on GitHub. So this first video, this is for understanding covariance. The videos are made by a man named Brandon Foltz. They're really great videos. And the second video is on understanding correlation. So go ahead and check out these videos if you're feeling not so fresh on covariance and correlation. And then once you've gone over these two videos, you can come back to this lecture and learn how you can find the correlation and covariance on values in your Pandas data frame. Okay, so now that you understand covariance and correlation, let's go ahead and make a data frame, get some information. So what kind of information do we want? It might be interesting to see correlation and covariance on some stock prices. So in order to do that, we can actually use Pandas to get information off the web. We're going to learn how to do this in much more detail later, so that you can think of this kind of as a sneak peek of what you're going to learn in the future. So what I'm going to do first is import pandas.io.data as pdweb. This is going to allow us to get some information off the web. Then I'm also going to import datetime, just a Pandas library for date input. And then I'm going to create a data frame called prices. Well, let me import these first, make sure I didn't make a mistake. Perfect. So what can we do to get some prices? Well, we'll call pdweb, and then we're going to call get underscore data Yahoo. So there's a lot of built-in methods to get stock prices automatically from the web. And all you got to do is input symbols, the dates you want them for, and then what kind of values you want off the stock. You can also get it off Google Stocks and various other sources. We'll be learning about this much more in detail later on. So this is kind of just a preview. So for correlation and covariance, let's go ahead and check out maybe some oil companies. So I'm going to put some stock symbols for oil companies, such as ExxonMobil or British Petroleum. These are some of the largest corporations in the world, so it should be interesting to see their stock price data. And we'll say the start, this is where we're going to use date time. So I'm going to start it from 2010, January 1st. And I'm going to end datetime dot datetime. And let's end it just 3 years later, so 2013, January 1st. And then the value I want off of this is the closing price, which in this case is going to have to be pass the string adj space close. Alright, and again, don't worry, we'll be going over this in much more detail in the future. This is kind of just a sneak peek on how to get information, financial information off the web. Let's see if this worked. Alright, took a little bit, but it got it. Prices.head. So .head just allows you to see almost like a preview of your data frame. So it's just going to show you the first couple values. So we have our 3 stock tickers symbols as the columns, and then the date as the index, and the actual stock price. So now we have a data frame full of stock prices, so that's pretty awesome. Let's go ahead and get the volume of the trades. So in order to do that, I'll do something really similar. I'm going to say pdweb.get_data_Yahoo. We'll pass the same ticker marks, the symbols. Whoops. And let's capitalize that X. And we'll do it for the same time frame. So the start time frame will be datetime.datetime 2010-11. And we'll have, whoops, forgot to put the day. We'll have the end be datetime.datetime 2013-11. And in this case, what I'm going to call for is the volume. Last time we called the closing price, this time I'm going to ask for the volume. And it looks like I messed up some syntax, and what I forgot was a comma to separate the start and the end. Let's try that again. Okay, and let's go ahead and just use the method head to see the head of that data frame. Just get a preview. Cool, so this is the amount of stocks that were traded on each of those days. So the total volume of stocks. So what would your return be? So the return would be the percentage change in prices in your stocks. So let's go ahead and call an object rets for returns. And then from your prices data frame, the method you can call is %change. So now you have the returns on your stock, and let's say you wanted to get the correlation of the stocks. How would you do that? Well, we can set another object, and we'll say we can pass the correlation argument, which is .corr, on that new returns object that we made, by getting the %change on the prices data frame. Let's run that and see if that works. Awesome, it did. So let's just get a rough idea of what these prices look like. So in order to do that, I'm just going to call plot method on this data frame, prices. And again, in the future we'll learn a lot more about all this. This is just to get you a little taste of the correlation and covariance. So it's going to plot that from prices. Okay, so notice that I didn't actually see the plot. If I want to see the plot, I have to call a special command. We've seen this in the past. We've got to call matplotlib inline. So let's try that again. All right, awesome. So now I'm actually seeing the price of each stock, and you can kind of see how they relate to one another, especially the tickers CVX and XOM. You can see that they're really correlated to each other, especially around maybe September 2011. There's a dip, and then the rises seem to be really similar. The British Petroleum stock, it doesn't seem to be as quite high of a correlation, but there's still definitely some correlation there, just not as close as the CVX XOM. So what if you wanted to plot out this correlation? Well, again, here's another sneak peek at what we're going to be learning in the future. We're going to import Seaborn as SNS, and I'll go over this in much more detail later, but Seaborn is going to be a plotting library to help us visualize some data. And then I'm going to import matplotlib.pyplot as PLT. And let's go ahead and import those two. Let's see how they work. And now we can use Seaborn SNS to make a correlation plot. And Seaborn can do that just by passing core plot. What we're going to want to do is get the data. So if you remember before, we have our returns data set as the object RETS. That was just a percentage change in prices. I'm going to set annotation as false so we get a clear picture. And I'm also going to set diagonal names as false. And this is just to make a clear picture, but we'll have a whole section on learning Seaborn in the future. We're going to learn a lot about it. It's going to make some really great plots. This is just to give you a preview of what that looks like. And here you have a really nice plot here, and it's actually showing you the correlations between them. So it looks like XOM and CVX have a really high correlation, 0.8. That's pretty high. And if we look up here to the actual prices, that really makes sense. If you see, they're really correlate with each other. When one goes up, one goes down. I mean, these curves look very similar. And that shows in the correlation data as well. So awesome. So now you've seen it visualized, one kind of in the back of your mind. You can see how this would be highly correlated. And then mathematically, you've actually done the correlation, seen that it has numerical values to it. And then last thing we can do after that preview, let's get back a little more on track to stuff we want to learn right now. We can check for unique values and their counts. So in order to do that, I'm just going to make a quick series. And let's just make this, let's just have it be a bunch of letters. So I'll say WW, throw in an X, throw in a Y, throw in a Z, throw in another W, and just a couple more letters just so we get a good feel for this. And then finally I'll put an A at the end, something unique. I'll show the series. And whoops, sorry. I should be passing a list into the series. So we need those brackets there. Let's go ahead and see what it looks like. Alright, so you got your series, bunch of letters. If we wanted to grab the unique values, I can do that by passing the unique method. And now I get an array return with each of the unique values. So W, X, Y, Z, A were all the unique values. What if I wanted to know how many of each of the unique values there were? I can say value counts. And now I know how many W's, X's, Y's, A's, and Z's there were. Okay. That's it for summary statistics. Next, we're going to learn how to deal with missing data. Let's just quickly scroll up and see what we learned. So the important takeaways here are learning how to call different summary methods onto a data frame, such as .sum, .min, or .idxmin, or .idxmax, or calling min. Really useful feature. The main thing you get out of this, describe. Describe is super powerful, and we'll be using it quite a bit throughout this course. To give you a little taste of the future, we went over covariance and correlation, and how we can grab information off the web using Pandas, just to give you a little taste of what you can really do some amazing stuff with Pandas. And then how we can plot, and how we can make really good looking data visualization plots using Seaborn, which we'll learn about Seaborn and plotting in the whole other section on data visualization. Alright, awesome. And then we can check for unique values in a series or data frame, and we can also get their value counts. Cool, so that was summary statistics. I'll see you on lecture 23. Thanks. Hey guys, welcome to lecture 23. And this will be on missing data. So we've seen a lot of examples of how Pandas deals with null values and missing values, so we're just going to go and dive a little deeper into that. So, as always, just copy and paste or type out the usual imports. NumPy, from Pandas, import series and data frame, and import Pandas as PD. Alright, so we're going to learn how to deal with missing data. It's going to be a really common task when you're analyzing data sets. So let's go ahead and make a series. We'll just call it data. And we'll pass a list in it. We'll just say 1, 2, a missing value, and then 4. Let's go ahead and see what that looks like. Alright, so we have our series 1, 2, null value 4. So how do we find these missing values? So Pandas makes it pretty easy. You can just pass the method isNull, and it will tell you true if there is a null there. So in our data, index 2, we had a null value. If we pass the method isNull, it'll find it and relate it back to you as true. We can also just simply drop and remove all null values, and if we want to do that, we can just say drop NA and pass that method on our data set. And so anything that had a null value is now gone and it's been dropped. Let's see, so that's how it works in series. Let's see how it works in a data frame. So let's make the dFrame object. We'll call it data frame. And let's go ahead and we'll make the first row of this data frame 1, 2, 3. We'll make the second row start off with a null value 5, 6. We'll make the next one 7, null value 9. And then the last row, I'm just going to make this all null values. Alright, and then let's go ahead and see that data frame. Cool, so now we have a data frame, it's a 4x3, and there's several null values there. And now let's go ahead and make another data frame called clean dFrame, clean underscore dFrame, and see what happens. We'll set that equal to drop NA. So what's going to happen is if we drop every null value from a data frame, let's go ahead and see that result. So you end up only getting 1, 2, 3, that first row at index 0. What Pandas does if you just drop NA with no additional arguments from a data frame. Any row that has any null, even if it's just one, is going to be dropped from that data frame completely. So we can also specify to only drop rows that are completely missing all data. The way we can do that is drop NA, and we can specify the method how. And if we specify how all, then that's going to drop rows where all the data was null value. So you can see here now only the third row was dropped, since that was the only row that had all null values. We can also specify to drop columns instead of rows, and the way to do that is by just specifying the access. So we'll say access equals 1, and we'd expect this to drop all of them. And why is that? Because if we look at our original data frame, every single column had a null value in it, so every single column got dropped if we just specified access equals 1 with no additional arguments. Cool. So we can threshold the missing data as well. For example, if we only want rows with at least 3 data points. So to show you how that works, let's go ahead and make another data frame. We'll call it dframe2. And I'm just going to make this I'll make it a 4x4. And to make this go a little faster, what I'm going to do before I start this data frame is I'm going to set npn equal to np.null, or excuse me, np.nan. That way I can just write npn. So let's start off with our first row. I'm going to say 1, 2, 3, and then last value npn. Second row we'll do 2, npn, 5, 6. Next row the list we'll put in is npn 7, npn 9. And then the last one will just be 1 with the remaining 3 values be npn. So that should give us a 4x4. And then let's go ahead and see what that looks like. Cool. So now we've created our data frame with a bunch of null values. So if you want to threshold by number of actual data points, points that don't have a null, you can do that. So you can say drop NA and then pass the thresh argument. So that's thresh, and let's say I only want rows that have at least 2 data points. So I can pass the threshold 2, and let's see what that comes up with. So now, since the last row, 1 null null null, didn't have a minimum of 2 data points, it was dropped. The other rows, even though they have null values, have at least 2 value points. So they weren't dropped when I put the threshold. Let's go ahead and just make sure we understand it. So I'm going to drop NA with a threshold of 3. So just think about for a second which rows you think are going to be dropped. Remember, threshold is going to drop any row without at least 3 data points. Cool. So the first 2 rows, index 0 and 1, have at least 3 data points, so they got to stay. Let's take a look at dframe2 again, the original. Alright, so let's say you wanted to fill where you had null values instead of just dropping them. You can do that with the fill NA method. So if I wanted to fill all the null values with a 1, I can pass the argument 1 into fill NA, and now any values that had null, for instance, this last row, now have a 1 value there. Great. And let's go ahead and, sorry, I called the original dframe. Let's check it on dframe2. There we go. Now that makes sense. We have our 4x4. Awesome. So what else can we do? We can also fill in different values for different columns. So to show you how that works, we'll call it on our dframe2. Let's just see what that looks like. The original still has all our null values. Remember, since we're not setting anything equal to these method calls, since I'm not saying dframe2 equals dframe2.fillNA, we're not making actual permanent changes to the dframe. So I can always call it and still have those null values. So dframe2.fillNA, if I want to fill in different values for different columns, what I can do is I can pass a dictionary. So let's say the 0 column, I want any null values filled with 0. The 1 column, I want any values filled with 1, null values that is. And then we can do the same thing for the other 2 columns. Take a minute, think about what this is going to look like before we see it. Let's see if we got it. Alright, cool. So now anywhere there was a null value in a particular column, we replaced it with the number of that column. So if we look at column 2, for instance, the last 2 now have a value of 2. Excellent. If we want to modify the existing object, there's 2 ways we can do that. We can either say dframe2 equals dframe2.fillNA, etc., etc., or that's a method of affecting the data frame permanently. But if you want to modify it in place and not have to type in equals like that, we can pass the argument in place. So fillNA, that would fill all those null values with a 0. Now notice I call dframe2 again. Those values go back to null. If I want to make the change permanent, then I can say fillNA 0, and I'm going to pass the argument in place. If I set it as true, that means it's going to modify the existing object. So let's go ahead and take a look at dframe2 now. And you'll notice just calling the dframe2, I no longer get null values. It's been permanently changed to have zeros instead of that null value. Alright, so now that we've learned how to deal with missing data, next we'll learn about index hierarchy. I'll see you there. Hey guys, welcome to lecture 24. This is going to be on index hierarchy. So in this lecture we're going to learn about hierarchies and index formation. So you're going to be able to have almost like an index of an index. And I'll show you what I mean about that later in this lecture. So let's go ahead and start off by just importing the usual. Import NumPy as NP from Pandas. Import series. Data frame. Import Pandas as PD. And then since we're going to be using random numbers later, as we've done in the past, we're going to import from numpy.random. Going to import rand n. Okay, cool. So Pandas allows you to have multiple index levels, and I'm going to show you with a quick example on a series. So let's go ahead and make a series called SER. We'll call the series. Let's construct it using np. Well, we can construct it using random 6. Just make 6 random numbers. We'll create an index. And you'll notice that my index is going to be 2 lists. So I'm going to pass 2 lists in my index. First list, I'm just going to say 1, 1, 1, 2, 2, 2. And then my second list, I'll have it be letters. So we'll say A, B, C, whoops. And then we'll repeat it again, A, B, C. So usually we're only passing one index, but now since we're going to learn about index hierarchy, we'll be doing multiple indexes. Let's go ahead and see what that looked like. Cool. So what Pandas did is it created a multiple index level, so it matches up the two lists you gave it and assigns one index level to the other one. So for instance, since your first three values of your first index list were ones, then it assigned that one index to the first three values of your second list. So those first three ABCs were all assigned on the one index, and then you have a sub-index of ABC. And then similarly, the three twos were assigned to the second set of ABC. So we can also check multiple levels. So if I, for instance, call the index method on my series, it'll give me the number of levels and their labels as well. And let's say I wanted to check a specific subset. So if I wanted to check, for instance, the first A, B, and C set, so the one in index 1, I can call it, and I'll get those first three values. And if I called the second index, I would get the second ones, 0.93, 0.157, and then 0.411. Let's say I wanted to call an index from an internal index level. So let's say I wanted to know everything on the series that was associated with an A. So I want to know both this value, 1A negative 0.34, and I also wanted to know the second A, 0.934. The way I can do that is by selecting everything using a colon in the higher index level, and then specifying that I want all A's in that lower index level. And there you go. It gives you that outer index level, and then the two values that were associated with the inner index of A. So we can also create data frames from a series of multiple levels, and we can do that using a method called unstack. So we can name our data frame dFrame, and then call the unstack method on that data frame. And then let's go ahead and take a look at what happened there. So since you had multiple index levels, now you can create a dFrame using unstack, and it'll create the lower index levels as columns, and your higher ones will be now the index of the rows. And we can also apply multiple level indexing to data frames since the very beginning. So if you wanted to construct a data frame with multiple index levels, we can do it like this. So I'll show you an example. So you have your data frame, you have np.arrange. So we're going to choose 16 points, and then let's reshape this into a matrix. We'll just have it be a 4x4 matrix. And then we're going to create an index. And again, so we're going to pass two lists in the index. First list, I'm going to have it be two pairs of letters. And the second list, I'll have it be a set of numbers. And then we can also do subsets of columns. So how can I do that? Well, we can specify that the columns is also going to be a set of lists. So let's have a first column be cities. We'll call NY and Y. Let's say LA and SF. And then the next one we'll do cold, hot. Let's just do hot, cold. All right, awesome. And then we'll have dFrame 2 to show it. So let's just see what happened, and let's go over what we just did. So we created a data frame. We arranged our 16-point array and we reshaped it as a matrix. So if you look on the inside, you have 0 through 15, so that makes sense, and it's a 4x4. And then we passed 2 index lists, AA, BB, 1, 2, 1, 2. So each of these gets matched up. So now these first 1, 2s are associated with A on the outer index, and then the second set of 1, 2s are associated with B on the outer index. So that's what we got going on those index of rows. And then if we wanted to make an index hierarchy for the columns, we can do the same thing. We created NY and YLASF. That's going to be your outer index. And then your sub-index there, we decided to be cold, hot, hot, cold. And that's what we got here. And they're associated with the first value on your first list is associated with the first value on your second list that you pass, and so on. Second value NY associated with the second value here, hot, so you get that going on your data frame. So if you want to keep better track of your index levels, you can name your index levels. So let's see how to do that. So let's go ahead and name our index levels. And we can do that by passing index.names method. And since we have multiple index levels on the rows, we can just pass a list. So we'll say index, index 1 for that first row index, index 2 for that second row index, and then we can also name the columns. And we can do it by just passing the method columns and then passing a names on top of that. And let's call our column names. So it looks like, so the first index for the columns are cities. So I'll call it cities. Oops. And the second index is temperature, well, more or less hot and cold. So we'll call it temp. And then after doing that, let's just see what the data frame looks like. Cool. So now we have the names of those indexes. So your first index, the AB, your second index, the 1, 2, 1, 2, and then your column names, cities, and temperatures, cold, hot, hot, cold. Cool. Let's say you wanted to interchange the level orders for some reason. You can do that. So if I wanted temperatures to be the outside index and cities to be the inner sub-index, how could I do that? So you grab your data frame and you pass a method on it called swap level, and then you give it the two index levels you want to swap. So we want to swap cities and temp, and we're going to set the axis equal to 1 because we want to swap the columns. If we don't put an axis, it'll try to swap the axis 0 by default, and that would be the rows. So since we're swapping columns, we're going to input 1. Let's see what happens. Nice. So now you can see we've swapped the levels. So now the temperature is on the upper level, cold, hot, cold. And you have your cities that are associated with those temperatures. You can also sort levels. So if you wanted to sort a level, you just pass the method sort level. And let's go ahead and pass that and see what happens. So now if we look at the row indexes, they've been sorted. So 1, 1, 2, 2. And what this, the argument I passed here in sort level is for which sub-level of the index to sort. So let's say I passed a 0 instead. Well, now it's going to sort it by the outer index, A's and B's. So those are already sorted. If I wanted to sort it by the 1 index, so remember index 1, that's your 0 index here, index 2, that's your 1 index. Since it starts at 0, and now we've sorted it by the second index, so 1, 1, 2, 2. we can then perform operations on particular levels. So this is where it gets interesting. We take our D frame, and let's say we wanted to compute a sum. But if we only wanted to compute a sum on a certain level, for example, we can pass the level argument, and I only want to compute sums on the temperature level, and I want to compute the sums on the columns, so I'll pass access equal to 1. Let's see what happens. So now I've kind of ignored the cities since I specifically stated the level to be temperatured, and I've added based on the temperature level. So let's look and see what happened there. If we look at our previous data frame, index 1 is A, index 2 is 1. What are all the cold values equal for this index? Well, it was 0 plus 3, and now you have 3 as your cold. And then the hots were 1 plus 2, so now you have 3 by your hots. And you can take that and expand it to the rest of the rows and columns, and that's what you get. Cool. So we'll be messing around more with index hierarchy in the future. It's going to be a really useful tool. That's the end of this section. Next up, we'll look at section 5. It's going to be working with data, the first part. You can go back on previous lectures, get a little more familiar with data frames and series if you want to, and we're going to be reviewing and using those tools a lot through the rest of this course. So, hey guys, this is lecture 25, reading and writing text files. So throughout this section, we're going to be inputting and outputting different file formats for Pandas data frame. In order to do that, I've just already imported the regular NumPy's NP, Pandas PD, and then from Pandas I've imported series and data frame. So first things first, we're going to have to get or make a CSV file. You can either get this from the additional material or you can make your own. So I've opened up Notepad, or you can open up really any text editor. I've put in just some letters or numbers, and then at the end a word, all separated by commas. And so I'm going to say file save this as, I'm going to go to where my IPython notebooks are saved. And these are actually saved in IPython notebooks, and let me just check to see that they're all there. So I select all files, and so yeah, all the lectures I've been doing are here. So our lecture 25 is here. So I'm going to say .text, actually I'm going to say all files, and then save this as a .csv file. So let's go ahead and save that. So now I have lec 25 saved as a .csv. Let's see how we can open it. So it's in the same location as lecture 25. So I don't need to call a specific file location. So all I have to do is say read underscore CSV, and then the name of the file, lec25.csv, and it's read it. So let's go ahead and see what that looks like as a data frame. Nice. So if you notice, something that happened here is it used the comma as a delimiter, and it also set that first row as the index of the columns, or as the column names, I should say. So what's another way we can do that? Well, if we didn't want that first row to be the column names, I can say dframe equals pdread underscore CSV. Again, I put in the name of my file, lec25.csv, and in this case I'm going to say my header equals none. So there is no header, so it's going to just index it automatically. So let's see what happens. Now let's take a look at my dframe. Nice. So now you can see it's inputted the full thing as a 4x5 data frame, and it's automatically indexed the rows and columns just numerically. So we didn't use that first row there. A different way to import CSV files is using the read table method. So the read table method is just a more generic version of read CSV. So I can say read table. Again, I just import that file name as an argument, and then I have to, since it's read table, it doesn't know it's a CSV file, I have to indicate what that delimiter or what that separator is. And then we're going to say header equals none. And let's see if we get the same thing here. Dframe, and we do. We get the same thing. We just had to indicate that the separator was a comma. So read table can then read anything no matter what its delimiter is. And delimiter is just a thing separating every variable. Yeah, so we can also do it that way. We can also indicate a particular number of rows to be read. So if we have a really big file and we don't want to read all the rows as a data frame, we can indicate the specific number of rows. The way to do that is we can just say pd read CSV. I'm not going to save it as a data frame, just want to show you guys. So I'll say lect25.csv. Again, I'll state the header equals none, and then I can pass the argument n rows, and that's the number of rows to be read. So if I only wanted to read, let's say, the first 2 rows, I just pass n rows equals 2, and it'll only read the first 2 rows. So let's see the whole data frame again. The original one, dframe. Cool. So what if I had a data frame, but I wanted to export it, so an output of the file? Well, that's also really easy. I can just say dframe. In this case, if I want to do a CSV file, I just say to_CSV, and then the argument I have to pass is what I want to call the file. So in this case, I'll just say my text data _out.csv, and now it's saved it as a text file. So you'll see this file where your IPython notebooks are saved. So go ahead and check your folder, see if you actually see this file there. I'll open up my folder, see if it's there. So I'll go to my documents, go to my IPython notebooks, and let's sort it by date modified. And here it is, my text data out. Cool. So we've learned how to export it as a CSV. We can also use other delimiters, so we can separate it with other things that are not just commas. I'm going to import right now SYS system. In order to do, I'm doing that so I can see the output directly and not have to save it. You'll see what I mean in a second. So let's say I said dframe.to_CSV. Instead of writing a file name, I'm just going to write std or sys.std out. That's just to show you guys what the output is. So I'm not actually saving this file, I'm just showing you the output. And then back to the idea of using a different delimiter, I'm just going to write std out, and I can indicate what's separating every variable. So let's say I wanted to use an underscore as a separator. I can do that too, and now instead of commas, it'll do underscores. So if you wanted to save this file with a different separator, you can go ahead and do that. I'll show you another example just to make sure you understand the concept of the delimiter. Let's just say sys std out, and I'll use a different separator, in this case one that you probably wouldn't want to use, but question mark. Let's see what happens. Think about what you expect to happen. Check if you're right. So now every variable is separated by a question mark. So that makes sense. We can also choose to write only a specific subset of columns to the CSV file. If I wanted to do that, I can just say to CSV. Again, I won't name the file, I'll just use std out to see the output. And let's say I only wanted the first 3 columns. So I'll say columns equal to 0, 1, 2. And if we scroll back up and look at our data frame, that would be these first three columns, 0, 1, 2, the QRS 2, 3, 4, ASD 5, 2, 5 columns. Let's go ahead and see what happens. And that's what I get out on the CSV, 0, 1, 2, QRS 1, 2, 3, 4, with the index still there. So that 0, 1, 2, 3 is that index in case you ever wanted to import it again. So there's tons of built-in CSV reader methods for Python, and I'm gonna just put the link as a string so you can check out this URL. It's in your it's in the IPython notebook that goes with this lecture. It's just the docs Python for CSV for other built-in native methods in Python. Let's go ahead and check out the link. So there's a nice comma separated value reader format, and there's a bunch of stuff you can do. This stuff is integrated directly with Python, not Pandas. So you can also mess around with that in case you want to do something outside of Pandas with CSV. So I'll let you check that out on your own. We won't really be using it throughout this course since Pandas already has a really nice built-in CSV reader. Cool. So that's about it for text files and CSV files. Next we're going to learn about reading and writing JSON data. Alright, I'll see you there. Hey guys, welcome to lecture 26. In this lecture we'll be learning how to use JSON with Python and Pandas. JSON is the JavaScript object notation, and it's used a lot around the web. So I've imported the usual NumPy's NP, Pandas, series data frame as well. So let me show you an example of what a JSON object looks like. I'm going to copy and paste this from the IPython notebooks that you have links to. So you can go ahead and open up that link and then just copy and paste it into your own IPython notebook. So it almost looks like a dictionary in Python. It's very, very close to that format. In this particular JSON object, we have a zoo animal category, if you will. We have it called lion. We'll have the food it eats. It eats meat, veggies, and honey. We'll have a descriptor for its fur. It's golden. It doesn't have any clothes because it's an animal. And then we have its diet, and that will consist of, for example, if there's a zoo animal, gazelle, its food that it eats is grass and its fur is brown. So we can have several layers of zoo animals within the JSON object. So we currently have two zoo animals here, the lion and the gazelle can be part of the lion's diet. Okay, so we're going to import the JSON module to work with it. And in order to load the JSON data, we're going to say data equals JSON.loads, and then the object name we gave it. Let's go ahead and see what that looks like. We'll type out data. Cool. So now we've loaded the JSON object as the term data. We can also convert this back to JSON if we wanted to. We can just say JSON.dumps, and then you pass whatever you want to dump onto as a JSON object. And now we have our JSON object here. Looks almost like a dictionary. So what else can we do? If you wanted to open up a JSON data after loading with a data frame, you can do that. So we can name our data frame dframe, and then load. Let's say we wanted to see our data and we were just interested in the diet. Let's go ahead and see what that looks like. And so now we have the diet section of the lion, and then we have information on that. So it was a zoo animal, gazelle, its fur was brown, and the food it eats is grass. We won't be working a whole lot with JSON objects with Python, So I'll leave this to you guys if you want to learn more about it. There's a lot of different arguments you can pass in custom selections. So you can specify a specific number of rows or columns to read off from the JSON object. But really, we won't be using them that often in this course. This is just almost an in case if you want to use JSON objects. And if you're already familiar with JSON objects, then you'll be familiar with their formats, and this is just to teach you how to import and load. But this isn't really a huge part of this course, so it's just for the more you know, basically. Okay, so in the next section, we'll go over quickly XML and HTML file formats of Python, and that'll be lecture 27. So I'll see you there. Hey guys, this is lecture 27, and in this lecture, we're going to be learning how to work with HTML with Python and Pandas. So we're going to import the usual, import Pandas as PD, and then from Pandas import series and data frames. Something we're going to import in order to read HTML data is from Pandas. We're going to import read underscore HTML. So to get HTML data, we're going to grab a URL for a list of failed banks. And that URL, I'm going to copy and paste it from the IPython notebook link. And that's the URL right there. An important note, you're going to need two things installed in order to do this. You're going to have to either pip or conda install depending on your installation. You're going to need a pip install Beautiful Soup. It's a scraping tool to use for web scraping, and then you're also going to need to install pip install HTML 5lib. So you should be already pretty familiar on how to use pip install or conda install based on your Python installation that you chose. So that you're going to need to install both Beautiful Soup and HTML5 in order to do this lecture. Alright, so once you have those guys installed, you can grab data from HTML and put it to a list of data frame objects. So to show you what I mean, I'm going to create an object called dFrameList. And then from that, I'm going to use pd.io.html.read HTML. And I'm going to read that URL that I just did. So this is going to grab data from the HTML and put it into a list of data frame objects. So let's set our dFrame, our data frame, equal to the first object in that list. And then we're going to show it as well. Nice. So now the first object in that data frame list, we just took it and then we acquired this data frame. If we take a look at the actual website, so I will copy and paste this into my browser. So we just copied this this list right here, this failed bank list. Cool. Now we got that going. Notice how we have null values where Pandas wasn't able to find any other values. So let's say you just want to know the columns. We can just, as we've learned before, just ask for the column values. And let's see what we got. So we got the bank name, the city, the state, CERT, acquiring institution, etc., all the way to the closing and updated date. So we got all that information, and it's now in a data frame. So we can do a bunch of stuff with it. What we learned in the past on working with data frames, or yeah, whatever you really want to do with this information. So that's how you open up HTML files with Pandas and Python. The main takeaways here are just you're going to need to use read HTML. using pd.io.html.read_HTML on whatever that URL you decided to use that happened to be in HTML. And then that will get you a list, and you can grab from that list to create your data frame. And then just make sure that you have installed Beautiful Soup and HTML5 lib. Okay, that's it for this lecture. Next we're going to learn how to work with Excel files. I'll see you there. Hey guys, welcome to lecture 28. In this lecture we're going to learn how to use Excel files with Python and Pandas. So I'm just going to start off by importing Pandas as PD, and then the important thing to know here is you're going to need to install two modules, either using pip install or const install. Pip install is pretty easy. Just go to your command line like you've done before and just type in pip install xlrd is what we're going to need. And we're also going to need a pip install openpyxl. So once you've pip installed those guys in your command line, you can use Pandas with Excel. So how do we open an Excel file? Well, I've made an Excel file, so you can go ahead and open up Excel, make a file. In this file, I've just put on the first row and first column, this is a test, and then I just made a 5 by 3 set of numbers. They're just random numbers, doesn't matter. I'm just going to go ahead and save this. It's called lec_28_test, and I only have information on sheet 1. And I just saved that in the same folder where my IPython notebooks are stored. So go ahead and make an Excel file or download one, store it in the same place where your IPython notebooks are. Once you've done that, you can go ahead and name an object XLS file. And then using pd.excelfile, we can type in the name of that file, xlsx, really similar to how we imported CSV files. Whoops. Lec. There we go. That's what I call the file. And then we can set a dframe to parse that. So we can say xls file dot parse, and we're just going to parse that first sheet in the Excel file, which was called sheet 1. And let's go ahead and look at what that dframe looks like. And there we have it. So we have that this is a test as that first column name. It's automatically indexed all the rows 0 through 4. It's put our numbers where we didn't have named columns. It just left them as unnamed 1, unnamed 2, etc. And that's how you import Excel files using Pandas. There's a lot of extra features you can use if you wanted to open up a certain amount of columns or rows. If you want to learn more about that, you can just go to the Pandas documentation. There's a lot of different arguments you can pass. You can pass headers, you can say skip rows, you can index the columns in a certain manner, you can parse the columns. So there's a lot of options you can do. At this point, it'd be kind of up to you depending on what you want to do with this certain Excel file you're opening. So I'll let you go ahead and check out the documentation there. But as far as just opening Excel files, all you need to do is pip install these two modules, xlrd, openpyxl, set an object, and use pd.excelfile to open it, and then you can parse through the Excel file to create your data frame. Okay. That's it for this section. Next up, we're going to learn about a lot of various data frame techniques that we can use on our data to perform analysis. Alright, I'll see you there. Hey guys, welcome. This is lecture 29. In this lecture, we're going to be learning about merge. So we'll learn how to merge data sets together by linking rows by keys. So we're going to import the usual. Oops. And from Pandas, import series data frame. Alright, so let's make a quick data frame. We'll call this data frame just dframe1. We'll do that with a data frame, and we're going to go ahead and pass a dictionary. So in this dictionary, we'll set off key, and I'm just going to put in some letters for the key. Let's just say X, Z, Y, Z, and let's say just XX again. Okay, and then the next entry in this dictionary is going to be the data set, so I'll just say data set underscore 1, and I'll set this equal to np.arrange 6. Let's go ahead and show that. Okay, so what happened here, we created a data frame, we did it through a dictionary. Dictionary data frames, you just set up your column name, and then you just set up a list of the data you want in that column. So the first column is data set, and then that second column was key. Nice. And then since we're going to be merging data frames, we need more than one. So we'll make another data frame, we'll call it dframe2. And we're going to do the same thing. We'll pass a dictionary. First entry we're going to call key. We'll pass 3 letters there, Q, Y, let's say Z. And then we'll pass the next entry, second data set, and in this case I'm just going to have it be a list 1, 2, 3. And then type dframe2 so we can take a look at it. Alright, so now we have data set and then a column called key. So now we can use the merge method, and this is a many to one method. So the merge will automatically choose overlapping columns to merge on. To show you what I mean, I'm going to call the method merge using pd.merge, and I'll call dframe1 and dframe2, the 2 data frames we have. Let's go ahead and see that. Okay, so what did merge do? If we look at the original ones, what are the keys they share? So data frame 1 has X, Z, and Y. Data frame 2 has Q, Y, and Z. So that means the only ones they have in common are Z and Y as far as the keys. And then if you look at their index, they happen to also be similar on 0Z and 1Z. So it merged those together and automatically overlapped where the keys matched. And I just chose this column and labeled it key for convenience so you could realize where it was being matched. Okay, so let's say I wanted to match on a specific column. I could do that too, just by saying pd merge. You would enter the 2 data frame names, and then you can say on, and here you would choose which column you would want to merge on. So in order to get the same result by specifying this, I can specify to merge on that column labeled key, and I should get the same result as the automatic merging. And we did get the same result, so we know that works. We can also choose which data frames keys to use. And so to show you what I mean by that, let's go ahead and call pd.merge. We'll create dframe1, dframe2, and then we'll say on the key column, and we can specify how. So if I say how equal to left, let's see how that looks. We can pass that left argument, and let's see what happened there. So now we've passed them using the left data set. So you can see the data set's key values and index values are now being used. So if we look at dframe2, let's go ahead and find out why there are certain null values. So dframe2 had no x values, so it's going to say null for all the x values of the data frame on the left. And if we look at dframe1 and look at its key column was x, z, y, z, x, x. And since we specified we wanted to use that left data frame, it's kept the same key, x, z, y, z, x, x. To make sure you understand, let's go ahead and pass the right data frame. So the one on the left will be dframe1, the one on the right will be dframe2. We're going to label it on key, and how we'll label it now right. So we're going to pass using the right data frame's key. So let's go ahead and see what happens. So if we take a look at dframe2, let's look at its key column. It was QYZ, and since we're on key, it only passed Q, Y's, and Z's. And the reason Z here is doubled was because it matched twice on both data sets, depending on the 0 index or the 1 index. So now you can choose on either data frame whose key column to use, either the right or the left. If you want to use both of them, you can create a union of both keys. The way to do that is, again, just pass the merge method. We'll call dframe1, dframe2, and then we'll label it on that key. And then if we want to use both the union of the keys, we can label the method how as an outer argument. Okay, and now we've been able to pass the union of both the keys. So the x's, the z's, the y's, and the q's. Since dataset 2 didn't have any values for x, it's still going to show null values there. So now we're going to learn how to do a many-to-many merge. And for those of you familiar with SQL, those terms will be familiar to you. So let's go ahead and make another pair of data frames. Let's see, we're going to have dframe3, and let's go ahead and pass a dictionary. We'll say key, and we're just going to input then a bunch of letters again. Let's say XX, Y, and then ZZ. And then that's one column. Let's go ahead and set up the dataset column. This is dataset 3. And we'll just set that up to be a range of 6 points, since we have 1, 2, 3, 4, 5, 6 in the key. So we'll set that to be a range of 6. Alt enter. Then let's make another data frame. We'll call it dframe4. Let's go ahead and see what we can do here. Let's pass a dictionary. We'll label one of the columns key. And now I'm going to pass a shorter list. I'll say Y, Y, X, X, Z. And let's make a fourth data set, and we'll set the values as a range of 5, since our key is 5 long. Now you need to use parentheses there. 5 long, and let me get a curly bracket to finish that dictionary input. Okay, so let's take a look at what data frame 3 looks like. Okay, and then let's take a look at data frame 4 as well. So these are the two data frames we're going to be using. Look at how their keys are. Got X, 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 Y, Z, Z on the third data frame, and Y, Y, X, X, Z on the fourth data frame. Cool. So let's go ahead and merge them, see what happens. PD merge, dframe3, dframe4. see what we get. Alright, so now the data sets are merged based on both their index and where they matched on that key column. So you can see dataset 3 and dataset 4, those values are now on the same row if they were able to get matched up by that key and by that index. Now if you notice something, the values are a little different, if you might have noticed. So for instance, let's look at dataset 3 on 0 and dataset 4 on 0, and they were both 0 on the key Y. Let's look where dataset had the key of Z. So you have dataset 4 and dataset 3, key of Z. Dataset 4 was 4 on that. Dataset 3 was 5 on that. And so now you can see they've been matched up there. You also had a 4 on dataset 3, so it got matched up. And dataset 4, it pulled that same value to make that match on the Z. So now you don't have a null value there. Okay. So we can also merge with multiple keys. So I'm going to make another data frame. So I'll say df left equals data frame key 1 and let's go ahead and pass some city initials as those values. Then let's go ahead and make a second key, and we're just going to pass let's just say 1 2. Let's just say 1 2 1. And then I'll make one last entry into this dictionary. I'll say the data itself, set that equal to 10, 20, 30. Okay, and then let me just format this a bit so it's easier to read for you guys. So I have my key 1, SFSFLA, my key 2, 1 2 1, and then my data is 10, 20, 30. Let's make another data frame. We'll call it df right. We'll pass another dictionary here. We'll say key 1, we'll call it SFSF LALA. Let's make another key 2, and then we'll just make it 1 1. Let's go ahead and make it 1 2 after that. And then lastly, we'll have write data. And we'll make the write data equal to 40, 50, 60, 70. Okay, so let's go ahead and take a look at those data frames separately before we merge them. So data frame left, we made a key 1 and a key 2 column. Key 1 is the cities, key 2 is just the 1, 2, and 1 names. And then we have left data, which is 10, 20, 30. df right, we have key 1, again city initials, key 2, 1, 1, 1, 2. And then write data, 40, 50, 60, 70. So let's see what happens if we merge them. So if we're going to merge on multiple keys, I can input df left, my write data frame, and then I'm going to try to merge them on both key 1 and key 2. So let's see what happens. I can input a list for multiple keys. or column names. So I'm going to merge them on key 1, key 2, and I'm going to say outer, so it does the union of those. And let's see what happens. So now I have key 1 and key 2, and now the left data and the right data have been merged to match up together by their keys. Right data had no data for SF2. So if we look at that right data, there is no SF2, there's only SF1. So it's going to give you a null for that data there. So using the above, you can check multiple data sets for multiple key combinations. So for instance, if you wanted to know, what was the left data set have for LA1? So you can then look up LA1 and check that the left data set had 30 and that the right data set had 60. Okay. So now you're going to note that the left and right data frames have overlapping key names, key 1 and key 2. So Pandas can automatically add a suffix to them. And we can do that by just saying pd merge df left df right, and let's just do it on one key this time. We'll say on key 1. So now we've merged those data frames on key 1. So if you notice, since I only merged it on one key and the rest of the data frame still had multiple columns, and they were named the same thing, so they each had a column named key 2, Pandas automatically added a suffix to it. So it said for the left data frame 1, it gave it a suffix of _x, and for the right data frame 1, it gave it a suffix of _y. So if you accidentally weren't paying attention, or you wanted to do this on purpose, and you just only wanted to merge by one column, and they happen to have two columns that were named the same, Pandas will automatically keep them separated for you. Okay. Since there's the suffix, if you didn't want it to be automatic and you wanted to specify what that suffix was, you could merge it yourself. So df left, df right. Let's merge it on key 1. And then we can also pass the argument suffix, sorry. And we can decide what we want that suffix to be. So we can say lefty for the first one, and then _righty for the second one. So instead of automatically saying _x _y, we can say _lefty _righty. And let's see what happens when we do that. And there you go. Since key 2s were in both of them, now you can choose a suffix _lefty _righty, or whatever you want to decide to put there. So there's a ton of info on merge parameters in the documentation. So if you want to check more stuff, some more specific things, you can check out the documentation. The link is in the IPython notebook on the GitHub link for the notebook viewer. If you want, we can just check this out real quick on merge. So let's go ahead and check that out. So like I said, we have the how method. We can label the indexes, which indexes we want to use, and choose the suffix to use if there's the same name index or column on both of them. Alright, so that's the basics of merging. You just do pd.merge, put in your two data frames, define which key you want to merge it on, define how you want to merge it, either left, right, or by the union of both keys, and then you can also choose a suffix for each key to be merged. So that's all you really need to know as far as right now. Next up, we're going to learn how to merge on the index and not by the columns. I'll see you there. Okay guys, welcome to lecture 30. In this lecture we'll be learning how to merge on index. So previous lecture we saw merging and how we used columns to do that and keys. Now we're going to use indexes to do that. Same thing. So import the usual, pandas as PD. From pandas, import series and data frame, and import NumPy as NP. Okay, so let's go ahead and make two data frames. I'll make a data frame called df_left, and we'll construct it using a dictionary. So I'll set a column to be called key, and I'll pass a list. So let's just go with x, y, z, then x, y. All right, and then next column we'll say it's we'll call it data. Sorry, one of my keys was sticking. Okay. We'll call it data. And we'll pass a list there as well. Actually, we won't. We'll just call it a range. We'll say we want 5 points. That's dr left, or data frame left. Let's go ahead and take a look at what that looks like. All right. Then we have a key column, x, y, z, x, y, our data column. And then let's make a data frame right, df_right. Construct it in a similar manner. We'll say, we'll pass the dictionary. Let's call one column group data. And it'll be a list, just 10 and 20 will be the values. And that's it, actually. And then we'll give it an index, and the index will be x and y. So notice how in this first part for the data frame I have my dictionary, and then the second part I label my index. And then just take a quick look at what that looks like. So I have x and y indexed, and then I have my group data, which is just 10 and 20. So we'll merge, and we'll use the key for the left data frame, and then the index for the right. So let me show you what I'm talking about. pd.merge. We'll put in the left data frame we want to merge with the right data frame. And now I can pass left on, and we'll say key. So the left data frame will merge on the key, and then I'll say right index equal to true. So let's go ahead and take a look at what happens there. So if you noticed, we were able to use the index for the right and the key for the left data frame. So key for left data frame, x, y, z, x, y. We use that in combination with the data from this group data. So now every x in group data was a 10. So the keys from the left data frame, x, y, z, x, y, since there was 2 x's and 2 y's. In the merging we have 2 x's and 2 y's, but we're using the group data 10, 10, 20, 20. And then we also have the data column from our left data frame. So if you want, you can go ahead and mess around with different left ons and with the right index true and false. See if you can predict the data frames that come out, and that way you'll know if you understood it or not. Let's try a little something different. So how about using a hierarchy index with merging? So I'll make another data frame. I'll call it df_left HR, because it's going to have an index hierarchy. I'll construct it using data frame. And let's go ahead and make a dictionary. We'll call this key 1. And I'll use city values in this case, or city initials, I should say. SF, SF, and then we'll have the last two be LA, LA. And then next entry in that dictionary will be key 2. We'll leave values, how about 10, 20, 20, 30. And we'll keep dataset. And this column will just say np dot arrange 5. And I'm going to add a point here to let it know that it's a floating point number. And it looks like I forgot a comma here and a comma there. All right, excellent. Let's make sure that was all inputted correctly. I accidentally put one extra R. And whoops, what did I mess up? Arrays must be all the same length. Do I have them all the same length? Let's see. Key 1 was 5, key 2, I accidentally have it. So let me add another number there. So now that should be 5 points. Okay. And let's just take a look at what we got. Nice. So our data set is just 0 through 4, so 5 points there. Key 1 are the cities we put in. Key 2 are those numbers we put in, 10, 20, 30, 20, 30. Now let's make another data frame. We'll call it df_write HR. This data frame, I'm just going to say np.arrange 10. I'm going to reshape that into a matrix as we've done in the past. I'll make it a 5 by 2. So those will be my data points. Then I'll set up my index. My index is going to be, so I'm going to have an index hierarchy here. So that means I'm going to pass a list of lists. So I'll have LA, whoops, not Alabama, LA, SF, 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 and then since this is an index hierarchy, we'll make another one and we'll call it, let's just have it be some numbers, 20, 10, 10, 10, 20. And since we have our index, we need to make some columns. And we should have the columns equal to, I'm just going to call them call 1 and then call 2. And let me put an underscore so it's a little more readable. Okay, let me just look over this to make sure we wrote it all in right. Our data is np.arrange 10.reshape 5.2. And then we have our index, which is 2 lists, LA, LA, SF, SF, SF. And then we have 20, 10, 10, 10, 20. And then we have our columns. So let's see if we got that right. Looks like I should have had a apostrophe there. Okay, now let's try it out. Okay, cool. And let's check out the data frame. All right, so we have a index hierarchy here. So we have the cities, and then their separate values, and then our 2 data sets of column 1, column 2, with the random number or the arranged numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 from np arrange 10 reshape 5, 2. Okie dokie. So we can merge the left by using keys and the right by its index again. So let's go ahead and see what that looks like when we do it with index hierarchy. So we have df left HR and then the data frame on the right, which call HR as well. I'll say merge the left on key 1, key 2, and then the right index will say true, so it merges the right by its index. Let's go ahead and see what we got. Okay, so if we take a quick gander at that first left data frame, we have our data set and then key 1, key 2, and then on the right we had LASF, its sub-index, the 10s and 20s, and the 2 columns. So now when we merge them, we have our data set values merged by the key 1 and key 2, and then the right index. So it kept this SF, LA, and the 10s and 20s. Nice. So our data is now merged and formatted. If you don't want to put in so many arguments, Pandas does have another method of joining stuff, or merging stuff I should say, and you can just do that by using the method join. So join is what we're actually going to be using most of the time. So let's go ahead and take a look at those original data frames, df left and df right. So df left was 0, 1, 2, 3, 4, the key was x, y, z, x, y, df right was x, y, 10, 20, and when you said left, join it with the right, you got the data and keys lined up, but group data, since it didn't line up with any of the indexes, it left it as straight nulls. And you can pass the same arguments through join as we were doing through merge to get specific columns or indexes that you want. Okay, so we'll probably be using join more than merge in most of the lectures in this course, but it's important to know how merge works in order to understand how join works. So go ahead and mess around with inputting different keys and indexes, right index set to false, or choose different keys to merge on, just to make sure you get a good understanding of what exactly is being merged and how it's being merged. So that's how you merge on index. Next up, we'll learn about the concatenate function. So I'll go ahead and end this lecture here, and I'll see you at the next lecture. Hey guys, welcome to lecture 31. This will be on concatenate. So we're going to be able to join data frames and matrices together, almost like a sandwich, if you will. So we're going to import the usual. NumPy is NP, Pandas is PD, and from Pandas we'll import series and data frame. So first let's learn about concatenate in NumPy. So I'll create a matrix. I'll just call it ARR1, and I'll construct it using np.arrange. I'll get 9 points, and then I'll reshape it into a 3x3 matrix, and I'll type it so I can see it. Okay, perfect. So we have our 3x3 of 9 points. So we can concatenate along axis 1. So to do that, we just pass np.concatenate, and then the list of matrices or arrays you want to concatenate. So for instance, I can just get 2 copies of that matrix and specify axis 1. Let's see what happens. So now they've been sandwiched together, so I have a 3x6, and you can kind of see how they were attached. So 0, 1, 2, 3, 4, 6, 7, 8, and then a repeat of the same matrix. If you want to do it on a different axis, you totally can. You just got to specify. So for instance, let's say we wanted top to bottom. We could again just get 2 copies of those arrays, and then specify axis equals 0. And now you'll see we have done it from top to bottom. Cool. So that's how to concatenate in NumPy. So how about we try it in Pandas now? So we'll start off by making some series. So SER1, we'll just call it, we'll make a series with the points 0, 1, 2, and we'll set its index to be T, U, V. And we'll make another index. We'll say series, and this one we'll just give it 2 points, 2 values, and then its index will only be 2 values as well. We'll just choose some other letters, let's say X and Y. And then let's just see how they ran correctly. Cool. Let's see them both real quick. So there's our first series, and there's our second one, so 0, 1, 2 TUV, and the second one is 3, 4 XY. Awesome. So how do we concatenate in Pandas? We can do that by saying pd.concat. So that's the method you can call, and then similar to NumPy, you just give the 2 series you want to concatenate, and it will add them it will concatenate them together. So now we have 0, 1, 2, 3, 4, and the letter in this index for both of them. You can also specify which axis. So we can say concat, pd.concat. Again, we'll pass in those 2 series. And we can specify, for instance, axis 1. And if I do this, it will produce a data frame. So it'll create an index 0 and 1 for the column names, and then it'll create a data frame because you have some null information. So your second series didn't have TUV information, and your first series didn't have XY information. So it fills those with a null value. But now you have a whole data frame from concatenate of those 2 series. Awesome. So let's say we wanted to add markers or keys to the concat result. So we could do this by using index hierarchy, which we've learned about in the past. So I can call concat on the 2 series, SCR1, SCR2, and I can set keys for them. So I can call one, let's say cat1, and I can call the other one cat2. Let me make sure those are strings. Alright, and let's see what happens if I do that. So now it was able to concatenate both of the series, but it's also labeled them through a hierarchical index, so I can remember which series was which. So cat1 is my first series, and now cat2 is the higher index of my second series. And then lastly, everything that we've done works really similarly in data frames, not just series. So let's go ahead and make 2 data frames. We'll make dframe1, call it data frame, and we'll call np.random.randn since we didn't import it specifically. We'll make a 4x3 random matrix, and then we'll set the columns equal to, let's just say x, y, z. And then we'll make a dframe2, and we'll start it from data frame. Again, we'll say randn, and in this case, let's make a 3x3 random matrix and set the columns equal to y, q, and x. So now that we've created those data frames, let's go ahead and take a quick look at each one so we know what we're dealing with. That's what our data frame 1 looks like. That's what our data frame 2 looks like. So they both have x and y columns. One of them has a z, the other one doesn't. The second one has a q, the first one does not. So let's see what happens when we run them through concat. So we'll say pd.concat to concatenate them, and we'll run them through a list, dframe1, dframe2, see what the result is. So as you'd expect, it binds them together, and you're going to get null values for where each data frame didn't have any values under the columns of the other data frame. So data frame 1 didn't have any q values, so it'll leave them all as none. Data frame 2 didn't have any z values, so it puts a null there. If we don't care, so you'll notice if we don't care about the index information, we can get rid of it. So if we look at the concat result on the index specifically, you'll see 0, 1, 2, 3, and then again the index 0, 1, 2. So it kept the index information when you use concatenate on the two data frames. If you didn't care about that index information and just wanted it to keep going, for instance 0, 1, 2, 3, 4, 5, 6, you can make that happen. You can just have it ignore the index. So in order to do that, we can call concat, again on dframe 1, dframe 2, and I can pass the argument ignore underscore index, set it to true, and it should ignore that index and give us a continuous index now. And that's what we got. So now we have 0, 1, 2, 3, 4, 5, 6. So that's about it as far as using concatenate. If you want to get a little more specific, there's always more information in the documentation. So there's a link in the IPython notebook, and I'll also write it down here. I'll copy and paste it from the IPython notebooks that we have in the viewer, and I'll leave it there for you. So to go, just a quick overview, using concatenate in NumPy, it's np.concatenate, and then in Pandas, it's pd.concat, and it works on both series and data frames. And data frames, Panda will take care of index values and null values for you automatically. And you can ignore the index to get a continuous index if you wish to do so. Alright, so you can check out the documentation if you want even more detailed information. But until then, we'll go ahead and head off to lecture 32, and we'll learn about combining data frames with overlapping indexes. Okay, I'll see you there. Hey guys, welcome to lecture 32. In this lecture, we're going to learn how to combine data frames. Alright, let's get started. So we'll import the usual. Import NumPy as NP, import Pandas as PD, and then from Pandas, import series and data frame. Let's go ahead and take a look. Okay. Let's make some series to work with. So SCR1 series. Let's go ahead and pass a list of values. I'm going to put some null values in there so we can see how Pandas deals with that. So I have a total of 6 values there, and then let's give it an index, and we'll just make that index Q, R, S, whoops, T, U, and V. Alright, and then we'll check that out. Okay. And then let's go ahead and make another series. This series, we're just going to get some numbers, so we'll say np.arrange. And to make it the same length as series 1, we'll just do len, the length function on our first series. And then we'll specify, pass the argument dtype, and that will specify the type of object. So we'll say np float 64 to specify that they're floating numbers. And then index, we'll just we'll copy and paste the same index from before. So let's go ahead and do that. Okay. And then let's type to make sure everything worked out correctly. Alright, so we have 0, 1, 2, 3, 4, 5, and then QRSTUV. Awesome. So now that we have those two series, let's get a series where the value of series 1 is chosen if series 2 is null. Otherwise, we'll let the value be series 1. So to show you how to create that kind of series, I'll call the series command, and I'm going to use NumPy's where method. So I'm going to say np.where. So I'll say pd.isNull. So where pandas is null and will put in series 1 as the argument. Select a value from series 2. Then we'll say otherwise, select a value from series 1. And then we'll set the index to equal the index of the first series. So let's just look at this before we click enter here. We're using NumPy's where, so we're saying np.where, and then wherever series 1 is null, put in the series 2 value. And if not, then just put in series 1. Okay, so let's see what we got then. So now I have QRSTUV 214365. So if we look at the null values for series 1, it was on the R, the T, and the V. And now if we look at the R, the T, and the V, those values had now been obtained from the second series, SER2. So that's how you can use NumPy's where command to do a little bit of logic. Just take a moment to make sure you really understood what happened here with asking for the null and then choosing SER2, otherwise choosing SER1. We can do the exact same thing using the combine first method, which is built into Pandas. So I showed you the long way, now I'll show you the shortcut. So the shortcut you can say is just combine underscore first SER2. So this will do the exact same thing as that where command. It'll say take series 1, combine it with series 2, but if there's a null value there, then use the value from series 2. And we get the exact same result. So that's kind of the shortcut method to this longer version using NumPy's .where method. So that's how it works on series. Let's go ahead and take a look at how it works on data frames. So we'll make a D frame, and we'll call it D frame odds. And then we'll pass a dictionary into the data frame. So we'll say X, and we'll give it a list. We're going to say 1, we'll put in a null value, and in fact what I'll do, since we're going to be using a lot of null values here, I'll set nan equal to np.nan, so I don't have to type as much. Going back to that dictionary, we'll go 1 dot, put in a null, 3, the dots are to signify indicate the floating numbers, and then another nan value. And then we'll have another null value, a 5, a null value, and a 7. And then the last entry will be z, so we have x, y, z. And then we'll make it have a null value, a 9, a null value, and 11. So this data frame only has odd numbers. Let's go ahead and make sure it took. Okay, and now let's make a data frame called data frame underscore evens. And we'll pass another dictionary through that. And in this case, we'll just say X. We'll set it equal to 2. Let's say 4. I'll put in a null value, 6, 8. And then we'll make Y with its entries list be a null value, 10, 12, 14, and let's just say 16. Okay, and we'll skip the Z on that one. Let's make sure that took. Alright, so let's go ahead and show them. We got D frame odds. Alright, there's our data frame, XYZ columns with the odd values. And then let's get the evens one. Okay, XY columns, only even values, a couple of null values spattered throughout. So let's combine them now. So we'll say dframe underscore odds, and we're going to do the exact same thing we did on the series. So we'll say combine underscore first, and then we'll pass dframe evens object through it. So take a minute to think what the result should be of this. So it's going to take dframe odds, and where there's a null value, it will pass dframe evens. So let's just imagine what that first column should look like. First column, x, we have a 1 null, 3 null. So that means if we combine it, we should get a 1. We'll take a null, so then if we look down here at dframe evens, that should be a 4. The 2, we have a value, so that one's good. On the third index, we have a null, so that will be 6. And then the fourth one doesn't exist on dframe odds, so it'll input the dframe evens. So your first column after issuing this command should be 1, 4, 3, 6, 8. And it will carry the same kind of operations on the y and z columns. So let's go ahead and see if we were right. Yeah, so the x column, like we expected, 1, 4, 3, 6, 8. And then you have the y and z columns. If there were null values on both of them, then we'll keep the null values in the combined first result. You can go ahead and make your own data frames and pass different combinations using the combine underscore first method, just to make sure you really understand how it's working. So just to overview, you could use np.where with the isNull logic and specify the index, but the shortcut method that Pandas has built in is combine underscore first. And you can do that on data frames as well. So that's how you combine data frames. Next up, we'll learn about reshaping. Hey guys, welcome to lecture 33. This lecture is going to be on reshaping. So we'll import the usual as always, NumPy as NP, import Pandas as PD, and then from Pandas, I'm going to import series and data frame. All right. So first we're going to see how the stack and unstack methods work. In order to do that, I'm going to make a data frame. So I'll say dframe1 is equal to data frame, and we'll create this data frame using NumPy arrange. We'll get 8 points, and then I'm going to reshape them as a 2x4 matrix. And then we'll set the index equal to panda index pd.index, and we'll have the list just be, how about some cities, and I'm going to name this index equal to city. The reason I passed the index as pd.index instead of just saying index equals this list of LASF is because by passing the pd.index, I'm also able to name it at the same time. And then using columns, I can do the same thing. I can say columns equals pd.index, and I can pass A, B, C, D. And I'm going to set this name equal to just letter, since they're letters. And then we'll show it. Hopefully there are no typos. Okay, awesome. So we have the columns, our letters A, B, C, D, and the index city name, LA and SF, and then we have 0 through 7, 8 points on a 2x4 matrix. So how can we use stack? So we can use stack to pivot the columns into the rows. So to show you what I mean, I'll make a new data frame. I'll call it data frame underscore st for stacked. And I'm going to set this equal to data frame 1, and I'm going to call the stack method on it. And let's see how that goes. Cool. So now, in a sense, we've pivoted it, and now we have the city and a sub-index of the letters. If we want to rearrange it back into a data frame, we can do that. We can just take dframe st that was pivoted, and I can say unstack to turn it back into a data frame. We can also choose which name to unstack by. So instead of unstacking that way, I could also say dframe underscore st. I can call the unstack method on it and specify that it should be unstacked by the letter. Let's see what happens there. The exact same thing, since that was the default unstack. What if I unstacked by the city though? Let's check out what happens. If I unstack by the city, then it's basically reversed, and now you have the cities being the columns, and letter is now your index for that data frame. So you can specify and unstack what you want the columns and index to be. So let's see how stack and unstack handle null values. So in order to do that, I'm going to make two series. I'll call the first one ser1. Set it equal to series. Let's say 0, 1, 2. And then I'll make my index equal to just some letters. Q, let's just say XY. I'll make another series, ser2, equal to 4, 5, 6. And then we'll have my index be X, Y, and Z, for instance. Okay, let's make sure that worked. Cool, so I have my two series. So I'm going to use, I'll set my D frame so I can make a data frame. I'm going to use concat, remember from concatenate. I will use that to make the data frame out of the two series. So we have a little review of what we've done before. And I'll set the keys equal to alpha and beta. And then we'll just check out what that data frame looks like. Awesome. So it's not quite a data frame yet. It's just two series that have been pushed together with concatenate. If I want to make it into a data frame, I'll have to unstack it. So I'll say dframe unstack, and now it shows up as a data frame. Cool. So we have null values. How do I get rid of those? Well, using pandas, if we have our dframe unstack, and let's say I stacked it again, that will automatically filter out the null values. So let's make sure of that. Cool. So again, just like before, the null values have been filtered out. So you get null values when you unstack into a data frame, but if you stack it back into that combination of those two series, you don't get those null values anymore. If we don't want to do this and we actually want to keep these null values from the data frame, we can do that as well. So let's set our data frame to equal dframe.unstack. So now if I call my data frame, I have this permanent data frame with two null values there at q beta and beta z. Or I mean, sorry, alpha z. And now, if I were to call stack on this normally, it would get rid of the null values. But if I wanted to keep them there, I could call stack and pass the argument drop NA equal to false. And now I've kept those NA values, the alpha z and the beta q. So that's about it for reshaping. It's mainly just being able to use the unstack and the stack. And next up, we'll learn more about pivoting data frames. in a similar fashion. All right, I'll see you there. Hey guys, welcome to lecture 34. In this lecture we're going to be going over pivoting and pivot tables. So we're going to import NumPy as NP, Pandas as PD, and then from Pandas we're going to import series and data frames. So the important thing about pivot tables, they can really depend on what information you're actually looking for. So if you're not familiar with pivot tables in general, we can just come over here to the pivot table Wikipedia page. So a lot of times for databases, for data entry and storage, your data is going to appear in a flat table. So if we look at this first table example, you have multiple regions, east and west, but then you have multiple entries for each region. So for instance, you have the boy and girl subset of the east and west regions. And what you want to first start off with when you're creating a pivot table is what am I seeking? So what information do I want to know? And that's going to be one of the most important questions you can ask yourself when analyzing data, or just data science in general, is what information do you actually want to know? So in this example, they wanted to know how many units did we sell in each region for every ship date. And so they create this pivot table, and this pivot table will basically sum up all the shipment units for each date, depending on the region. So this kind of pivot table can really depend on what information you want. So you could have also asked, how many units did you sell to boys versus girls on particular dates? What was the average price based on the regions, etc., etc. So in order to kind of just see how to do pivot tables in Pandas, we're going to create some data to play with. This data I'm going to get from using the Pandas testing utility, and the way I'm going to do that is I'm just going to copy and paste from one of the IPython notebooks on the GitHub. So it's really outside the course to know, it's outside the course's frame to know how I made this data frame to work with. We're just using the Pandas testing utility, but it's outside the scope of the course to need to know how I created this table. We're just basically creating an unpivot function, which gives us a bit of a sloppy, flat data table to work with. So let's go ahead and look at what the frame looks like. Cool. So I have multiple instances of the variables A, B, and C, different values for each one, and then different dates for each one as well. So again, don't worry about how I made this data frame. It's just using the testing utility, but you won't need to know that for this course. It's just a convenient way to make data frames to test certain things. If you want, you can look in more on the documentation about utility testing, but this lecture is just to show you if you had a certain data frame and you wanted to know a certain thing, how could you make the pivot table for it? So this data frame, we can think about this as stacked. So note how there's multiple variables and values for the dates. And let's pivot the data. So let's say we wanted to know the variables, let's say A, B, and C, and D for particular dates. What were their values? So we can go ahead and say dframe underscore PIV, so our pivoted data frame. In order to pivot it, we just call the pivot method on that data frame. And then what we pass is the row and column indexes, and then optionally a fill value. So I'm going to want my rows to be the date, so I'll pass that first. I'm going to want my columns to be the variable, and I'm going to want my value, my fill value, to just be the values. So that's how you do a pivot table. You decide what you want for the rows, the columns, and what you want the fill value to be. So I can take this stacked data frame and basically unstack it and pivot it. So let's go ahead and do that. And then let's see what it looks like. Alt enter. Alright, cool. So now I've pivoted this table, and I can see some of the values for A, B, C, and D depending on the date. So this is just a general introduction to pivoting and pivot tables. It's going to really depend on what specific information you want to know and how you want to present it. but it's good to know that you can easily pivot data frames just calling the pivot method and then deciding what you want the row, column, and values to be. It's pretty much that simple, and it's really going to depend on what your flat data table, your stack data table looks like, and what information you want to come out with it. Okay, so that's about it for pivoting. Again, you don't have to worry about how I made that data frame. It's just using some testing utility that we won't be using in the future. And next up, we're going to learn about how to find duplicates in data frames, so if you have duplicate values. Okay. Hey guys, welcome to lecture 35. This is going to be about duplicates in data frames. Alright, so import the usual. NumPy is NP, Pandas is PD, and then from Pandas we'll import series and data frame. Alright, so let's go ahead and make a data frame. We'll call it dframe, and we're going to make it with duplicates on purpose. So we'll have data frame. We're going to pass a dictionary, so we'll just say key 1. And then we'll have it be, let's say, we'll pass A, and we'll have 2 instances of A, and then we'll also add 3 instances of B. How about that? Whoops, that should be a comma. And then we'll make a second key, and we'll pass just a list, which is kind of the reverse. So this is different ways of making it a list key. So this instance, I just multiplied A by 2 to get AA, and then I added 3 B's on top of that. Here I just wrote out manually 2, 2, 2, 3, 3, 3. Okay, and then let's go ahead and show that data frame. Nice, so we have key 1, key 2, letter AA, and then BBB, and then key 1 and key 2, and their values that match up. So, how can we find duplicates? It's actually really easy with Pandas. We can pass the term duplicated with no additional arguments, and it'll tell us if rows are duplicates. So for instance, that first row, it's going to yield you a false since it hasn't seen a duplicate yet, A2. And then the second row, the index 1 row, it's going to say that it is duplicated true because its previous row was also key 1A, key 2, 2. And if we look at the very last row, B3, it's also true duplicated because it's the second instance of the B and 3 row. So that's how you can find duplicates. Let's say you wanted to get rid of those duplicates. You can drop them, and you can just simply pass the method drop underscore duplicates with no additional argument, and it'll get rid of any duplicates it found. So now we only have those false values from before, the 0 index row, and then the second and third index row, 0, 2, 3, and now we have those rows. So we were able to drop the duplicates. You can also filter out which duplicates to drop by a single column. The way to do that is, again, just say dframe underscore drop duplicates, and you can pass the column name that you want to drop from. So now I dropped duplicates specifically from the key 1 column, so that means anything that was duplicated as far as the letters has now been dropped. So anything that had an additional A after the first one or an additional B after the first B showed up has been dropped. So you only end up being left with the 0 and 2 indexed rows. So that makes sense. Let's go ahead and show the original dframe. Alright. By default, the first value was taken for the duplicates, but we can also take the last value instead. To show you what I mean by that, we can say dframe. Let's bring this to center. Dframe drop underscore duplicates. We'll pass it on key 1. So if you notice last time, we just took the first instance and then dropped later duplicates. Let's say instead of doing that, we wanted to take the very last duplicate. So we can do that by saying, passing the argument take underscore last equals true. So what do we expect to happen in this case? So that means the very last time, since we're calling it by key 1, that it sees the duplicate, it'll keep it. So before we press enter, let's go ahead and try to imagine what's the result going to be. If we look at key 1, the last time an A shows up is in index 1, so it's going to keep that row. And then if we keep going down key 1, the last time a duplicate of B shows up is at the 4th indexed row, so we should expect rows 1 and 4 to be kept, since we're taking the last setting equal to true. Let's see if that works. And that's what we got. We got the 1st and 4th indexed rows. Awesome. So that's about it for finding duplicates. It's pretty straightforward. You just pass the method either duplicated to find the Boolean value if they're duplicates or not, and you can just say drop underscore duplicates, and you can pass specific columns as an argument. And you can also pass take last true if you want to get the last duplicate value. That's about it for duplicates. Next up, we're going to learn about mapping. I'll see you there. Hey guys, welcome to lecture 36, and this lecture will be on mapping. So we're going to import the usual, import NumPy as NP, import Pandas as PD, and then from Pandas import series data frame. Alright, so mapping is a great way to add columns to data frames. And I'll show you what I mean by that in a second. So let's create a data frame to work with. We'll say dframe equals, let's make a data frame. And then we're going to say, let's have it be a column for city. We'll pass a dictionary, and then this key will have, let's go ahead, I'm just going to get some information off Wikipedia. These are some of the highest elevation cities in the United States. So we got Alma, Bryan Head, Fox Park. And let's create another entry, another key in that dictionary. We'll create altitude. And here's the altitude for each of these cities. 3,000. And this is in meters, I believe, 2762. Alright. And then let's go ahead and show that data frame. Cool. So now you have a data frame that has the altitude of the cities and the city names themselves. So let's say you wanted to add a column to this data frame, but you wanted to add a column for each state that the city is in. So you can use mapping to map the column so that your states match and map onto your cities. So I'll show you what I mean by that. So let's go ahead and create a dictionary. We'll say state underscore map equals curly brackets for the dictionary. So Alma is in Colorado. Bryan Head is in Utah. And Fox Park is in Wyoming. Alright, so now we have our dictionary state map. And then let's go ahead and we'll call dframe. We'll create a column, say dframe state equals dframe. And this is how we're going to map it. We're going to say call the city column and then pass the method .map. And what we're going to map to it is that dictionary we made called state map. So what we're doing right now is we're creating a new column called state, and we're calling the map method onto the city column. So now wherever these cities match up in our state map dictionary, it'll add the state into a state column. So we'll do that. Now let's see what our data frame looks like by calling dFrame. And so now we have an altitude, the city, and the state. And the states have been correctly matched with their cities. Cool. So mapping is a great way to do element-wise transformations and other data cleaning operations. There's lots of different ways you can use this, but as far as the overall method, the simplest way is just creating or modifying a new column and then just using the .map method to pass a dictionary object and map it to a column that already exists in your data frame. Okay, so that's it for mapping. Next up, we'll learn how to replace values. I'll see you there. Hey guys, welcome to lecture 37, and this will be just a quick lecture on how to use replace with your data frames. So, copy and paste, or just type out the normal imports, which is import NumPy as MP, import Pandas as PD, and then from Pandas, import series and data frame. Alright, awesome. So let's go ahead and make a series. We'll call it SCR1, and the series we'll just build it using a list. So I'm just going to go 1, 2, 3, 4, and then again 1, 2, 3, 4, and then let's go ahead and show that series. There we go. So we have it indexed, and it's 1, 2, 3, 4, 1, 2, 3, 4. So using replace, we can select which value we want to replace with the new value, and a new value to replace it with. So for instance, the way this works is you call the replace method, which is just .replace, and then you select the value you want to replace, and then the new value you want in its place. So for instance, I can say that I want every one value in that series to be replaced by a null value. Let's go ahead and see if that worked. Awesome. So now every value that was 1 has been replaced with a null. You can also input lists into the replace method to show you how those work. Let's say I want to replace the 1s and 4s, and I want to replace them with 100 and 400 respectively. So the lists need to match up so that every value of your first list will be replaced by the value in your second list. So every 1 will be replaced by 100, and every 4 will be replaced by 400. So let's go ahead and pass that. Cool. So that worked, and that's how you can do multiple replaces at once. And then the last thing, you can also input a dictionary. So for instance, I have my scr1.replace, and I can pass a dictionary so that in a similar manner every 4 gets replaced by a null value. So you can just input a key and a value to be replaced. So let's go ahead and see how that works. And so now every 4 value was replaced by a null value. So that's it for replace. Just a quick overview. You can just call .replace onto your series, and then you call the value you want to replace and then the value you want to replace it with. You can also pass lists to do multiple values at once, and you can also pass dictionaries in a similar manner. You replace the key with its value. So that's it for replace. Up next, we're going to learn about renaming an access index. I'll see you there. Hey guys, welcome to lecture 38. This lecture will be on renaming indexes. I'll call it rename index. And so we're going to import the usual. Going to import NumPy as NP, import Pandas as PD, and then from Pandas we'll import series data frame. Alright, so now that we've done that, let's go ahead and make a data frame. We'll say dFrame equals data frame. Let's go ahead and just get some numbers, a number matrix to fill out some values. So we'll say np.arrange, and then I'll reshape this array into a 3x4 matrix. After that, I'll just set my index equal to some city initials. And then I'll set the columns equal to just some letter values. So we'll say A, B, C, D. Okay, and now we have our data frame. So just like a series, access indexes can also map. So we can use map to lowercase the city's initials. So how can I do that? I'll show you. So for instance, we can say dframe.index, and then I'll call a map on the index, and using that map I'll input the command str.lower, so this will lowercase that index, and so now my array is the lowercase of each of those cities' names, or initials I should say. If I want to assign this to the actual index, I can use dframe.index equal to the value I wrote above, index.map, and then str.lower to lowercase everything in that index. And now if I look at my dframe, the effect will be permanent. Cool. I can also use rename if I want to create a transformed version without modifying the original version. So if I want to do that, I could say dframe.rename, and this is where we're going to learn more about renaming indexes, and then I'll say index equals str title. That's the way to make it capitalized. And then I'll set my columns equal to str lower. So I'll lowercase the column letters. Let's see if that works. And so now using title, it's capitalized the first letter of the row index values, NYLASF, and then it's lowercase the column names. So I can use rename to create the transformed version of that data frame. I can also use rename to insert dictionaries providing new values. So I can say dframe.rename, and then I can pass index equal to, let's say, a dictionary, NY, and I'll call it New York. Get the full name. Then I can also pass columns equal to A, and then I can rename that as alpha. So what I'm doing here is I'm passing dictionaries with the arguments index and columns using the rename method. So that's going to rename my index and my column. So let's go ahead and see what happens. So as we expected, now NY has been renamed to New York, and that A has been renamed to alpha. Cool. So you can actually edit the data set in place. The way to do that is I can say dframe. Well, to show you what I mean first, let's just take a look at the original data frame. So those effects weren't permanent. If I want to make them permanent, I can say dframe.rename, input the original stuff we just did, New York, finishes that dictionary, and then since I want to make an edit to the data set in place, I can just set in place argument equal to true. And now when I call my dframe, those effects are permanent, so it actually edited the data frame in place. So that's about it for renaming indexes. So just to go over it, you can map things to an index to edit it, but you can also just use rename, and you can rename and input arguments index, either a dictionary for renaming, or you can pass arguments or methods onto the index and columns themselves, such as lowering or uppercasing the column or index values. Hey guys, welcome to lecture 39, and in this lecture we'll learn about binning. as always, we'll import the usual pandas as PD, and from pandas we'll import series and data frame. Okay, so we'll learn about binning right now. To start off with, let's go ahead and make a list. We'll just call it years, and I'm going to just go 1990, let's see, 1990, 1991, 1992, and let's skip ahead to 2008, 2012, 2015, and then we'll go back so it's not in order, 1987, 1969, 2013, 2008, and 1999. Alright, so now I have kind of just a random list of years, and then I'm going to make another list called decade underscore bins. So I'm going to be using this list to separate these years by decade. And so for this list, it's going to be pretty simple. It's just going to be 1960, 1970, just all the decades, 1980, 1990, 2000, 2010, and then 2020. Whoops. 2020. Okay, and I forgot to put brackets to make it into a list, so let me do that real quick. Alright, Alt-Enter, perfect. So now we'll use cut to design something that's called a category object. So Pandas has these category objects that's going to help us do this binning. So I'm going to make an object called decade underscore CAT for category, and then I'm going to call the cut method. So I'll say pd.cut. And for this method, I'm going to pass in an x and then my bins. So what that x is the object that I want to cut into a certain amount of bins. So I want to cut my years into different decade bins. Alright. So now let's go ahead and see what this decade category object looks like. So if you notice here, it counts off how many categories we have. So we have 6, 1960, 1970, then to 1970 to 1980, 1980 to 1990, 90 to 2000, etc., etc. And it's been able to cut my years into certain bins, depending on whether or not that year is in the decade. So I can check my categories using decade underscore cat, just the category's name, and I can call the method categories on it. And so that's going to tell me the index of the categories. So basically each decade, 60 to 70, that's a decade, 70 to 80, that's a decade, 80 to 90, etc., etc. Alright, so now the important part, I want to check the value counts in each category. So I can say pd.value underscore counts, which we've seen before, and I'm going to pass that category object into it. So this is going to count how many years I have in each category, or how many objects I have in each category in a general case. So in this case, I have 3 years between 2010 and 2020. I have 1 year between 1960 and 1970, and then there were 0 years between 1970 and 1980. We can also pass data values to the cut. So for instance, if I just wanted to make 2 bins evenly spaced based on the max and min year, I can do that. So to show you an example, I can say pd cut. I just want to say, go ahead and cut up that years list, and then just cut it up into 2 bins, and I'll state my precision to be within plus or minus 1 year. So let's go ahead and see what happens. So now my years, there's only 2 bins. They've been evenly cut. So now the bins are between 1969 and 1992, or between 1992 all the way to 2015. So all those years have been separated into 2 bins. So it's everything in the first bin, which is a time era of 69 to 92, and then it cut up the years into a second bin from 1992 to 2015. So that's about it for binning basics. Just a quick note, as far as the values of the bin itself, the notation of, for instance, right here I'm highlighting a parentheses versus a bracket. So that notation is the exact same thing as in math notation. Parentheses means open, while using the square brackets means it's closed, so it includes that number. So for instance, this 2015 bracket, that means it's including 2015, and the parentheses means it's just open. So next up, we'll learn about outliers and describing data. Just an overview on binning, what we learned. You can use cut to bin an object either by declaring your bin list or by just saying how many bins you want to cut it into. And then that creates a category object, and you can call categories and take value counts on the category. And that's it for binning. It's just separating your data into different bins. That'll be useful for histograms in the future and that sort of thing. And I'll see you at the next lecture for outliers and describing data. Okay, I'll see you there. Hey guys, welcome to lecture 40. And in this lecture we'll be learning about outliers. Okay, so as always we'll import the usual. I'm just going to start copying and pasting since we're doing this so often. Okay, so we got NumPy is NP, Pandas PD, series and data frame. So we're going to see how we can find outliers in a data set. So in order to do that, we're going to use the NumPy generator. So let's just say np.random, and we'll use .seed. Let's just say 1, 2, 3, 4, 5. And so we've seeded our random generator, and now let's actually use random data frame random, and I'm just going to use randn, and we'll say 1004 as your inputs. So now we have our data frame. Let's go ahead and check a preview of it. So we'll just see the first few rows. Okay, and then let's go ahead and we can use tail to see the last few rows. Alright, so we got 1,000 rows and then 4 columns, index 0 through 3 and index 0 through 999 on the rows. Okay, so we got all our information. Let's go ahead and just describe the data. And if you remember from our describe summary statistics lecture, all you got to do is say .describe method. And so now we have the mean, the standard deviation, the min, the max values, and also the counts for each column. Let's just go ahead and select that first column. So I'm going to make an object called col, C-O-L, and then I'll say it's dframe 0. And then let's go ahead and look at col. Okay. So now I have the first 4 values in that column. 5 values, excuse me. So now we can check which values in the column are greater than 3. So for instance, I'll call column, and then as we've seen before, we can ask logic. So I'm going to say np.abs, so that's going to be the absolute value, col greater than 3. Okay, so what I'm asking here is show me column where the absolute value of the column is greater than 3. So let's go ahead and check that. Okay, so it looks like I got 2 of those. So I have row 523 and row 900. So those are both rows where the absolute value of the row in column 0 was greater than 3. So that makes sense. So we know now in column 0 the rows 523 and 900 have values with absolute greater than 3. What about all the columns? So how can I do that? So in a similar fashion, I'll now apply this to the whole data frame. Whoops, should be square brackets there. And now I'm going to say np.abs of the D frame, the entire data frame, where it's greater than 3. And then I'll say any, and I'll pass the 1 as the argument. So I'm going to use the any method to do the same thing. So now you see here, it's returned every row in my data frame where any value that had a column that had an absolute value greater than 3 was returned. So I told my data frame, hey, look at the data frame, and where you see an absolute value that's greater than 3 in any column, return that row. And so these are the rows, and we can look at any one of them. So for instance, 3, 2, 4. That one, its value in column 2 was 3.26. So that's greater than 3. Okay. So we could possibly cap the data at 3. So how will we do that? We could say dframe np.abs dframe, so the absolute value of dframe again, greater than 3. So I'll set all those values, and I'm going to say np.sign of the dframe multiplied by 3. So what does that mean? What is this going to do? If we look at it again, let's see what we're actually asking the data frame to do. So we're saying anywhere in the data frame where the absolute value at that point is greater than 3, where the absolute value at that point is greater than 3, let's go ahead and set that equal to the sign of that value, which will either be -1 or 1, and then set it equal to that sign times 3. So that means values such as -3.18 here will turn into -3, and values such as 3.36 here will turn into +3. So we're going to go ahead and run that. Okay, and now let's go ahead and look at dframe and describe. Let's see what we get. So if we scroll down to the min and the max values, you'll notice now every min has been capped at -3, and every max has been capped at +3. Let's go scroll back up and see what we got before. So you see we had minimums below -3 and maximums above 3. So using this any method, we've been able to cap outliers. So you can use the logic and the .any in order to do that. Okay, so that's about it as far as outliers and capping them. Now, next we're going to learn about permutations. So I'll see you there. Hey guys, welcome to lecture 41. This lecture is about permutation. So let's go ahead and get started. We're going to learn how to randomly reorder either a series or the rows in a data frame. And that reordering is the same as a permutation. So we'll start off with the classic imports. NumPy is NP, Pandas is PD, and from Pandas import series and data frame. So let's go ahead and make a data frame. I'm going to say my dframe equals data frame. I'm going to use np.arrange. Let's just call 0 through 15 there, and reshape this as a 4x4 matrix. So that will be my data frame. And now I'm going to create an array with a random permutation of the numbers 0, 1, 2, 3. So I'll call this object blender, and then I'll say np.random, and I can pass this method called permutation, and I'll say 4. So what that's going to do is from 0, so if we count from 0 4 times, we'll get 0, 1, 2, and 3, and then that blender is going to create a random permutation of it. So if we see what blender actually looks like, Alt Enter. So we got 1, 2, 0, and 3. That's the random permutation it came upon. So if we take a look at our data frame, right now all the rows are in order, 0, 1, 2, 3, and it's a 4x4 matrix from 0 to 15. What we can do to get a permutation of those rows is use the take method. So I can say dframe.take, and I can take blender from it. So what this is going to do is it's going to say, okay, from that data frame, take index 1, then index 2, then index 0, then index 3 rows, and put them in that order instead. So let's see what that happens. That results in, alright, so now I have 1, 2, 0, and 3 as the index rows, and it's grabbed all the values from that row and it's permutated the entire D frame based on the results of Blender. Cool. So what if I wanted to do permutation with replacement? So to show you what I mean, I'm going to make a little example. So I'm going to make an object called box. And let's imagine a box that has 3 marbles in it, labeled 1, 2, and 3. So I'm going to say box equals np.array. I'm going to say 1, 2, 3. So now I have my box with my 3 marbles labeled 1, 2, and 3. So just like Blender, let's create an object called shaker. And really similar to Blender, I'm going to say it's random, but in this case it's not a permutation since I'm going to do a permutation with replacement. So I'm going to say, in order to do that, I can use the method rand int. So this can be permutation with replacement. And so I have to do from low to high. So I'll say it goes from 0 to the length of the box, so the size of the box. And then I can say size, and what size will be is how many times I will pick from that box. So that will be 10. So what this is doing is it's basically just like if I scroll up here, made with Blender. It's going to do a permutation, but it's going to be able to do a permutation with replacement. So let's go ahead and see what this looks like. So I'll type in shaker. Okay, so shaker is now basically an array, and when we pass it through take, it's going to say grab the 0 index, then grab the 2 index, then 2 again, and 2 again, then 1, then 2, then 2, then 1, 0, 1. And let's go ahead and see what that looks like. So I'll make an object called hand_grabs, and I'm going to pass the take method on my box, and I'm going to pass the shaker on it, and then we'll see what that looks like. Cool. So now hand grabs is the simulation of taking a marble, seeing what number is on it from that box. So first I grab marble number 1, then I put it back in, I shake the box, grab another marble and see what number it has, etc., etc. And I can do that 10 times by taking that permutation of shaker. Okay, so that's it as far as permutation, and congrats, we're all done with this section. And up next, we'll start the next section, which is working with data part 3. Alright, I'll see you there. Hey guys, welcome to lecture 42, group by on data frames. So in this lecture, we'll be learning how to use group by on data frames. So, import the usual, NumPy is NP, Pandas is PD, and then from Pandas import data frame and series. So we're going to start out by making a data frame. So we'll say dframe equals data frame, and I'm going to construct this data frame using a dictionary. So let's go ahead and start off with the first column, K1. Then I'm going to just have this column be a list of letters. So we'll say X, X, Y, Y, and finally we'll have it be Z. Okay. Next column will be K2, second key, and this one I'm just going to have it be a series of alpha and betas. So alpha, beta, alpha, beta, and then alpha finally. And then we'll have 2 data sets that will just be random numbers. So I'll say data set 1. I'll call this guy np.random.randn. Have it be 5 numbers. And then we'll have data set 2. and we'll just have this be np.random.randn, have it be 5 as well. Okay, and then let's just take a quick look at what that data frame looks like. So we have a series of 5 by 2 random numbers, that matrix there, and we have our 2 data sets and essentially 2 keys for those data sets, the K1 and K2 columns. So how can we use group by? Well, we can use group by to create what's called a series group by object. So I'm going to say, let me grab the data set from the dataset 1 column and group it by the K1 key. So I can say group 1 equals from the dataset column, the dataset 1 column. I'm going to say group by, and then I'm going to group it by the K1 column. And then if we want to see what this looks like, we actually are just going to get a confirmation that it's a series group by object. We won't actually see what it is. So there's the kind of object it is. If we want to see stuff, we can perform operations on the particular group. So I can say group 1 and then check out the mean. And now I have K1, the key, and X, Y, and Z, the means for each of the dataset 1. So I can use group keys that are series as well. So to expand on this example, let's go ahead and make some arrays to use as keys. So I'm going to say cities equals np.array, and now I'm going to put in some city initials. So I'll say NY, let's put in LA, put in LA again, and then I'll have 2 more New Yorks, NY. Okay, those are my cities, and then I'm going to have some in the month array as well. So I'll call NumPy array, and then we're going to make a list of just months. So Jan, February, January, I'll just have it be alternating. January. Okay. So let's run that. And now using the data from dataset 1, I'm going to group the means by city and month. So to show you what I mean, let's go ahead and try that out. So let's grab dataset 1 column. Then we call group by. And what do I want to group by? I want to group by cities and month, those 2 arrays, and then I want to grab the mean by that. So what does that look like? So it's lined up the cities first and then the month, so it's grouped them in that fashion, and then it's averaged out the dataset 1 based on those 2 arrays that I assigned to it onto dataset 1. Let's see the original data set again, so I'll call dframe. So here's the dframe, and I can see the values that line up. So I have my 0.899, that was LA February, 0.533, that was the January for that guy, and then the 252 was New York February. Alright, cool. So those values lined up. We can also pass column names as group keys. So let's go ahead and try that out. So for instance, I can say dframe dot group by K1 and then get the mean from that. So now I've grouped my data frame by this K1 column. So I grouped up all the X's, all the Y's, and all the Z's together. And then I grabbed the means of those 2 data sets based on their K1 key. So for instance, if we look at data set 1 on the X row, that result is just the average of negative 0.3 and 0.89, since those two were assigned the x on the K1 column. Okay, and then we can even say something like group by method to get the group sizes. So I can say group by. Well, before we do that, I can just show you real quick that I can get the mean on multiple columns. So I can say group by, let's say we just did the mean on K1. If we wanted to do the mean on both keys, I could just pass a list and then ask for the mean. And now it's giving you the average based on both keys. So the average for every term in the data sets that had both x and alpha, or x and beta, or y and alpha and y and beta, or just z and alpha out of those two data sets. So hopefully these examples are starting to get a little more concrete as we call by certain keys and get the means. And now back to getting sizes, I can say dframe dot group by. I'll group it by the K1 key and then get the size. So this means I have two terms as x that have x and K1, two terms that have y and K1, and then one term that has z and K1 in that data frame. And if I look at that data frame, I can see that was the case. Cool. So we can iterate over groups as well. So to show you an example of this, I will say for name and group in dframe dot group by. We'll say it's K1. I'm going to print, this is the group name, so I'll say this is the parentheses s to get that string. This is the group, label it name. I'm going to print group and then print a new line. So what this is going to do is it's going to print out, it's going to check the name and check the group, and it's going to print out this is the blank group from key 1. So it should say this is the, since K1 is x's, y's, and z's, so it's going to iterate through all those names. So it's going to say at first this is the x group, and then it's going to give us this data set here, since that was the x group. Then it's going to say this is the y group, and it should give us this data set here, since those both have y as their K1 value. And then it's finally going to give us the z group. So let's go ahead and see if that worked. So that's what we get. We say this is the x group, and it gives us the data sets and the two columns for that group, and again for the y and the z group. So that was iterating by a single key. We can do the exact same thing for multiple keys. So I can say, for instance, for K1, K2, group in dframe dot group by, and I'll say K1, K2, and I can print, I can say key1 equals the string, which we'll see in a second, key2 equals the other string, close that off, and then we'll call K1 and K2 to fill out those keys. I'll say print the group, and then print a new line to get some separation. So let's think about what this is going to do. What this should do is it should print out both keys for you. So right now our keys that we're using are K1 key and K2 key. So key 1 is going to be your letters, so your x's, your y's, your z's. Key 2, since it's K2, it's going to be your alpha or your beta. then it's going to print the group that belongs to both of those keys. So for instance, the first thing we should see, and I will print the D frame so we have a reference. For the first iteration, I should get the first key, which is K1. So it's going to say key 1 is equal to X, and then it's going to say key 2 from K2 is equal to alpha, and then it's going to print the data set where that's true. And for this, it just happens to be one row, so it should be printing out that data set. And then it's going to do that for the rest of them. So let's go ahead and see if that works. And there you have it. You have key 1 equals X, and then key 2, I forgot to write equals, so let's run it again. Okay, now we've added an equals there. Equals alpha, and it's giving you the data set where those keys matched up. Alright, and it's done that. It's iterated that through the entire data frame. And you can see that data frame there. Great. So, what else can we do? So a possibly useful tactic for this is creating a dictionary of the data pieces. So if we wanted to do that, I could say something like, have an object, group dict, and I will create a dictionary by using dict, and I will pass a list through it, and that list is going to come from dframe group by, and I will group it by the first key, that K1. So let me run that. So now I have my group dictionary. And so now let's show the group with X. So we can say group dic, and we'll pass it with X. And now it's shown us every row that had X as K1 value. We could have also chosen to do this with access equals 1. So let's create a dictionary for D types of objects. And that's D types as in the letter D. So I'm going to say, make another object, group dict, and I'm going to label it also access 1. I'm going to do the exact same thing, dictionary list, and then I'm going to do this by creating dframe group by dframe.dtypes, and I'm going to do this on access equal to 1. So let's run that, and then let me show you what that looks like. So what did we end up getting? We ended up getting basically a separation of your types. So here you have the D types, which are just your floating numbers, and then you have your letter types, which were the K1 and K2 columns. So it's actually separated the data frame by the types of data, and it did it along the axis equal to 1. Alright, great. So we can use group by to actually separate data by the actual data type. So if you wanted to separate numbers versus words or something of that manner. Next, we can learn how to use group by with columns. So let's go ahead and make an object called dataset2 group. And for this example, let's say if we only wanted to group the dataset2 column with both set of keys, I can say dframe dot group by. I'll pass a list of both keys to it, and then say it's equal to dataset2 right here, and then we can get the mean of this. So dataset2 underscore group dot mean. So this is going to find the mean of dataset2 using both keys. So it's going to look at all the dataset2 values, then group it by both keys, anything that has x's and alphas, x's and betas, Y's and alphas, Y's and betas, Z's and alphas. And then it's going to average up all the objects that share that. So if we look at that, that's the result we get. And since there's only one of each object, the average is going to be the same as that data itself. So it's grouped it, averaged it, but since they all only had one entry for that both keys, it's the same as the value. So we have, for instance, negative 0.19, negative 0.19 here, and it's x is an alpha, x is an alpha. So that's about it as far as group by. We'll be using this tool slightly in the future. So go ahead and then look back at the examples. The main takeaways is that you can group by, and you can either group by columns or group by your certain keys, and you can get certain information off your data frame and leave other things behind. Alright, so next we're going to have a quick lesson on grouping with dictionaries and series. I'll see you there. Hey guys, welcome to lecture 43. This lecture we'll be going over group by in a little more detail and how to use it on a dictionary and on a series. Alright, so we're going to import the usual. You can either copy and paste this or just type it out. NumPy as NP, Pandas NP, and then from Pandas import series and data frame. Okay, and wait for a second for that to import, and it's done. Alright, awesome. So let's learn how to use a dictionary series with group by. So first thing I'm going to do is make a data frame. Let's call this data frame animals. There's my data frame. It's going to be just some random numbers. So let's just make it, well, actually let's make it some a range of numbers. Let's say NP arrange. We'll have 16 numbers, and we're going to reshape this into a 4x4 matrix. So those will be our values. Our columns, we're just going to have letter columns, so we'll say W, X, Y, and Z. And then our index will just be some animals. So we'll say a dog, we'll have a cat index, we'll say bird, and then mouse. Okay, so that's our data frame. Let's check it out. Animals. Alright, now I'm going to add some null values to this. So to do that, I'm going to say animals dot ix. So let's say through 1 and 2 on the W and Y columns, I'm going to say those values, set them equal to null. Okay. Let's do that, and now let's see animals. So what we should expect is on cat, yep, here we go, that W and Y are null. Okay, and you can choose whatever null values you want to replace with null. So let's say I had a dictionary with behavior values in it. How could I use that? So let's make a dictionary and call it behavior map. And we're going to be creating a dictionary for this. So I'm going to say W, let's set that to good. Let's set X to bad behavior. We'll set Y to be good as well. And we'll set Z to be bad. Alright, so now we have our behavior map dictionary relating each of the columns to either a good or a bad behavior. And now we can say animal underscore COL. Let's make another object. So we'll make a group by object and say that's going to be equal to animals, and we're going to group that data frame using that behavior map. And we're going to schedule it along axis equal to 1. And then let's say animal column, let's get the sum. So show the sum according to the group by using that mapping we just did. Okay, so what do we have here? We have dog, cat, bird, and mouse, and now we have a bad and a good column. So what this was is it summed up all the values that were good and bad for each of the index rows. So for instance, let's take a look at bad dog and good dog. So bad dog, well, for good dog, we have 2 there. So that should have been equal to the good values, and the good values were W and Y. So let's look at W and Y for dog. So W for dog was 0, and Y for dog was 2. So if you sum up the quote-unquote good values on that behavior map for the dog, you'll get 2, 0 plus 2. And then for bad, the X and the Z, you'll get 1 plus 3, which is 4. And it did that for all the index, for dog, cat, bird, and mouse. Cat being null, since there was no good cats. And I may have done that on purpose, since I don't like cats. Anyways, let's try it with a series now. So, we'll make a behave series, and we're going to make a series out of behavior map, and then let's go ahead and show that behave series, or behave, I guess, since I forgot the E. So now we have our map. The W was good, X was bad, Y is good, Z is bad. So that's our series out of that dictionary. And now let's group by the series. So let's take our data frame, animals, and we're going to say group by that series, and again do it along axis equal to 1. And now let's count. So now we're going to count the total of bad and good instances for each animal based on that series. So now we get 2 and 2 for dog, since it's just doing a counting, not a summing of them. So let's show our D frame again. Yep, sorry, our data frame is called animals. There we go. Okay, excellent. So, what does that mean? That means the dog had 2 instances on the bad columns and 2 instances on the good columns, since it was counting. Let's assume that we wanted to group by the length of the animal names. So we can just pass the length function into group by. So this is going to be a really interesting thing we can do with group by. So look at the animals, look at the length as far as characters of each index. So dog and cat are 3 letters long, bird is 4 letters long, and mouse is 5 letters long. So we can say animals group by, and that's going to take the length of each index, and then we can get the sum. Alright, so now our index is the number of letters in the animal name, and then it's summed up, those guys. So for instance, if we look at index that's 3, that summed up the column values for the 3-letter animal names, dog and cat. So let's look at dog X was 1, cat X was 5, and now since we grouped it by the length of the animal name, 5 plus 1 on that X column equals 6. And it's done that for each of the column values, and bird and mouse as well, since they were 4 letters long and 5 letters long respectively. We can also mix functions with arrays, dictionaries, and series for group by methods. So let's check that out. We can say get a set of keys. So I'm going to make a list for this. I'm going to say A, B, A, B. So I have my keys. And now I'm going to group by length of name and the keys to show the max values. So I'll say animals dot group by, and then I'll group by the length and those keys, and I'm going to find the max values for each of those. So what has it done here? It's set that key list onto that previous data frame we had. It's pushed it onto it. So now that index of 3 now has a sub-index of A and B. And then it's found the max values for each of those cases on every column. Great. So we can use group by with index hierarchy levels. So let's create a hierarchical column index. So we'll say higher COL equals PD multi-index, and then we can call the method from arrays. So this will allow us to build a multi-column, or issue multi-lists, excuse me. So let's say we want some cities initials, since we've been doing that a lot. NY and Y, make NY again, and then let's just have the last two be SF or San Francisco. And then we're going to pass a list of lists, so let's add another list in there. This one will just be numbers. We'll say 1, 2, 3, 1, 2. Alright, so that's our list of 2 lists. And then for this, we'll name each index. So the names of the index, we pass the argument names, and we'll say it was the city, and then the second one we'll just give it a generic name, sub value, since it's just some numbers, 1, 2, 3, 1, 2. So let's make that. Alright, now let's create a data frame from that hierarchical index. We'll say data frame underscore HR for hierarchy is a data frame. We'll pass, let's say, a 5 by 5 matrix, so I'll create arranged. I'm going to reshape this to be 5 and 5, and then I'll set my columns equal to that index hierarchy. Cool. And now what I'm going to do, I'm going to say dframe underscore HR is equal to dframe underscore HR times 100. So that what that's going to do, it's going to multiply every object in that data frame by 100. And I do that for clarity reasons later on, just so it's really obvious that you have a 0, 100, 200, 300, 400, all the way to 24. So now we have a hierarchy index. Top index is cities, NY and SF. That sub-index is 1, 2, 3, 1, 2. And then we have our index on the side. So we have the column index and the regular index. So that's how you can use group by. We have those data frames, and you could use group by on them as well. So you could use multi-index from arrays to build a hierarchical index for your data frame. That's about it for this. You can check out the documentation on group by if you want to know some more details on it. We'll continue using it throughout the course, so if you don't feel 100% on it, you'll still have way more chances to see it again. Alright, up next we're going to learn about data aggregation. I'll see you there. Hey guys, welcome to lecture 44. This lecture is going to be on data aggregation. I'm super excited for this lecture because after the previous 43 lectures, we're finally going to be able to look at some real data sets and do a lot of analysis on them. So let's go ahead and get started. You're going to import NumPy as NP, Pandas as PD, and from Pandas import series and data frame. We do that for most of the IPython notebooks we start, so we're definitely going to do it now. So data aggregation consists of operations that result in a scalar. For instance, the mean, the sum, the count, those operations that we've done in the past. So let's go ahead and get some data to play with. So here's the URL we're going to use. We're going to look up the archives of UC Irvine machine learning class. So this is the link. When you click this link, or you can copy it from the IPython notebook viewer, you'll come to this page, and it's the machine learning database wine quality. And we're going to go ahead and mess around with the red, so the wine quality red CSV file. Alright, cool. Once you've downloaded it, go ahead and save it where you're saving your notebooks. And if we open up that file real quick, I'll open up in Notepad. Notice that it's separated by semicolons, not commas. So we're going to use read CSV like we learned in the past to set up a data frame, but we're going to have to set the delimiter as a semicolon, not just a comma. So let's go ahead and do that. We got dframe wine, that's what we'll call our data frame. And then we're going to use pandas, so pd.readCSV, and then go ahead and input the name of the file. So this one is wine quality.csv. Actually, it's wine quality _ red, the way I called it. You can just call it whatever you want. And then remember, the delimiter or the separator was a semicolon. Okay, so now we have our data frame. Let's go ahead and get a preview. Let's just see the first 5 rows. And we can do that again like we've done in the past by calling just the head of the data frame. Alright, so what do we got here? We got our index 0, 1, 2, 3, 4, etc. Pandas has done that automatically for us. We have different acidity values, residual sugar levels, the chlorides, the dioxides, the density of that wine, the pH level of that wine. And then the interesting ones we're going to play with for this lecture is the alcohol content of that wine. So for instance, this wine was 9.4% alcohol, and then the quality rating for that wine. So they rated it on quality. Okay, cool. So how about we find out the average alcohol content for the wine? How can we do that? Well, just like we've done in previous lessons, we're going to say dframe wine. We'll choose the alcohol column. And since we wanted the average alcohol content, we're just going to get the mean. So this is a data aggregation, since it's going to produce a scalar. So the average alcohol content for all these wines was 10.4%. Alright, great. So what else can we do? We can, if we want, just take a quick peek at what the entire data frame looks like. So the entire data frame is a whole lot of wine. It's 1,599 rows. So we got tons of information here to play with. We know that the average alcohol content of the wine was 10.4%. What else can we do? So that's an example of data aggregation. Can we make our own data aggregation? So there's built-in methods such as mean, but can we make our own? And yes, we can. So what we can do is create a function. We'll use def to create that function. And we're going to create a function called max to min. So max to min, we'll have it accept just ARRR as its input. And then we're going to return the max value of that array, and then subtract the minimum value of that array. So we're going to basically serve this as a peak-to-peak function. So it's going to find the max and subtract the minimum. So now we have our function max to min. So using that, let's go ahead and keep that in the back of our minds. We've learned a lot about group by, so let's go ahead and implement that on our data set. So let's make a data frame called wino, or a group by object called wino, sorry. And we'll take our data frame, dframe wine, and we will group by, and we're going to group it by quality. So this was the quality rating of that wine. So we've done that, and let's go ahead and see the statistics on that. So we'll use describe like we've done in the past. Alright, so now we've grouped all the wines by their quality rating. So the quality goes from 3 all the way to 8. And we have stats on all the wines. So we have their alcohol content, their densities, their acidities, sugar, etc., etc. And we have their counts, the mean values, the standard deviations. Alright, awesome. So we're going to be messing around with that later. We can now apply our own aggregate function. So this function takes the max value of the column and subtracts the minimum value of the column. So let's go ahead and take that group by object we just made, wino. And the way we pass a general aggregation method is .agg. And then you're going to pass your function, max underscore to min, that we just made. Let's go ahead and run that. Okay, so now what this has done is it's gone through wino, that group we just made, that was sorted by quality, and it took the max of each column value and subtracted the minimum. Okay, so that's what we got as the result. And we can also pass string methods through aggregate. So to show you what I mean by that, we call the method wino.agg, and we can actually pass mean as a string instead of .mean method. We could actually just do a more generic mean. It's going to give you the same result, but it's just good to know that you can do it that way as well. So there you have, for instance, the average alcohol percentage for each wine. Alright, awesome. So let's go back to the original data frame, dframe wine. Just see the head of it, the first 5 rows. Okay. Nice. Now let's add a quality to alcohol content ratio. So what I'm interested in, I want to see if that quality rating has a link to the alcohol percentage of the wine. So I'm going to do that by adding a new column to this data frame. I'm going to say dframe underscore wine, and then I'm going to name this column, I'll say qual divided by alc space ratio. So this is the quality to alcohol content ratio, and it will be equal to the quality column, so this column right here, quality, divided by dframe underscore wine, the alcohol content column, this column right here. Alright, so let's run that. So now we've created that new column. Let's go ahead and check out the head now. Okay, and there's our column now, the quality over alcohol ratio. Great. So we have a whole column. We got that going. So just to go over some other stuff we've learned in the past, let's go over pivot tables. So we could have used pivot tables instead of group by. So how would we do that? We would say dframe wine dot, and instead of calling group by, we could have also have called pivot table like we've done in the past. And in this case we could have specified that the index be equal to the quality column. Whoops, let me spell that right. Quality column. Excellent. And now let's take a look at that, and you get the pretty much the exact same thing we got when we used the previous methods of group by. Great. So we're not quite yet at the data visualization section, but I'll give you a little preview taste of what that might look like. In order to show you the plots, I'm going to need to call matplotlib and inline. So that will allow us to see the plots inline in the notebook. And then what are we going to plot? How about we make a scatter plot? So we'll say dframe underscore wine, and I'm going to call a plot method on that data frame. So we've seen this once before, but we'll see it in much more detail in future lectures. So the kind of plot I want to make, let's just make a scatter plot just for the heck of it. And on my x, I will make quality values, and I'm going to plot those versus the y, I'll say the alcohol. Okay, let's go ahead and do that. Alright, so now I've made a scatter plot of alcohol versus quality, and it's plotted all the points, so all the wines based on their quality, rating, and their alcohol percentage content. So that's pretty interesting. So we can see that the data is probably better fit for a box plot of some sort. So we can get a more concise view and maybe add some standard deviation lines and get averages. So we're going to learn about box plots in the future. I'll leave it as a challenge to you if you want to figure out how to do box plots right now. But don't worry about it. We have a whole section on data visualization. This is just a little taste of it. Most important thing to learn from this lecture was data aggregation. So let's scroll back and make sure we got that. So remember, data aggregation is basically just functions or methods you call that allow you to have a scalar result afterwards, such as mean, count, sum, etc. You can just call these by saying .mean, .sum, .count, and you can also, the important part is, make your own aggregation. So we did that. We made a function called max to min, and you can pass aggregation functions on your data frame by using .agg. And then you can also pass string aggregation methods by just saying .agg and then the string name of that aggregation. Alright, so we got a little taste of what it is to work with work with real data sets, and I'll see you at the next lecture, lecture 45. Awesome. Hey guys, welcome to lecture 45. This is going to be on using splitting, applying, and combining, so otherwise known as split, apply, combine. So we'll do the usual imports. I'm just copying and pasting these from the IPython notebook viewer link that I have for you guys. Alright, so what is split, apply, combine? The best way to look at this is just through a visual demonstration. So for instance, you can have a data frame or just a data set, split it up by a certain index. So in this example, it's split up by that letter in column on the X column, so A's, B's, and C's. You can apply something to it to get a new value, and then you can combine it back again. So in this instance, looks like the Y column was averaged out, and so you get the average of everything, and you can use this, do this by group by methods or other ways using pandas. So this is the general principle of split, apply, combine, and we're going to learn about it a little more. So let's go ahead and get some data to work with. So let's go ahead and use the same data frame we used in the last lecture, the wine data frame, and we'll open this up by using pd read underscore CSV and saying wine quality underscore red dot CSV. And remember, the delimiter slash separator was a semicolon in this case. And then to make sure we actually got it correct, we'll just check out the first 5 rows. Alright, great. Okay, so in the last lecture we kind of explored alcohol content versus quality. So what if we wanted to know the highest alcohol content wine for each quality range? We can use group by mechanics to do a split, apply, combine procedure. So first what I'm going to do is I'm going to create a function that assigns a rank to each wine based on alcohol content, with 1 being the highest alcohol content. So what I'm going to do is I'll make a function. I'll call it ranker. It's going to take a data frame, and then from that data frame it will set alc content rank And let's go ahead and make this one term, so I'll put underscores here. So it's going to create that column and set it equal to arrange a group of numbers by the length of the data frame plus 1. And then it's going to return that data frame. Okay. So we'll be using this function later on. Then let's go take a step back and look at the dframe underscore wine. So let's sort the data frame by alcohol in ascending order. So I'm going to say dframe underscore wine dot sort. I'm going to sort it by alcohol. Say ascending, pass that argument, put it to false, and then in place equal to true, so it affects our data frame. Okay, so now we have a data frame sorted. Now we're going to group by quality and apply our ranking function. So this is how we're going to do this. This is going to be the split apply combine technique. So I take my data frame wine, and I'm going to set it equal to dframe wine group it by quality, and this is where the apply comes in. I'm going to pass the method apply, and I'm going to apply that ranker function that we just created. So again, this ranker function assigns a rank to each wine based on alcohol content, with 1 being the highest alcohol content. So I'm applying that ranking function to the data frame as it's been grouped by quality. Okay, so take a moment, think about what the ranker function is actually doing, why it's arranging by the length, and why it's adding that 1. And then once you understand it, go ahead and preview what your data frame is going to look like. So let's go ahead and check the head of that data frame. Okay, so what do we got for our data frame now? We can see that the index of the rows has been jumbled up a bit, but if we come over here and look at the alc content rank, it looks like your data frame's been sorted by the highest alcohol content. So this is number 1 alcohol content for the quality of 5. This is the number 1 alcohol content for the quality of 8. And you can see these are pretty high alcohol content wines, 14.9%, 14%. So we can now get closer to finding the highest alcohol content for each ranking. So how do we finish this up? We can just call for the data frame where the alcohol content rank, this last row right here, equals 1. So we can say set an object called num of qual equals dframe underscore wine quality value counts. And then let's go ahead and see what that looks like. Okay, so what is this? This is just the number of wines in each quality count. So at quality 5, at quality 6, 7, 4, 8, and 3. And this is, so there's 681 wines that have a quality rating of 5. 638 wines have a quality rating of 6, etc., etc. So let's go ahead and show the combined information for the wines that had the highest alcohol content for their respective rank. Alright, so this is how we're going to do that. We'll take our data frame and then say dframe wine, call that last column we made using our ranker, content underscore rank, and say equal to 1. So dframe wine where your alk content rank was equal to 1. So when it's equal to 1, that means it had the highest alcohol content of any wine in its quality class, if you will. And then we'll just get the head of that. And how many dframes do we want to see? Well, we just want to see, or I'm sorry, how many rows do we want to see? We just want to see the same number of rows as there are quality batches. So we'll say num of qual. And looks like I forgot an E. Okay, let's run it again. Alright, there we go. So, if you look at the alk content rank, they're all equal to 1. So there were 6 quality rankings in total, 3, 4, 5, 6, 7, 8. And these are the row indexes of the wines that had the highest quality, or these highest alcohol content for their quality class. So you can see these all have pretty high alcohol contents. They're all the highest in the class, and you can see how they relate to quality. So something we might want to ask ourselves is, are there any trends between the ranking of the wine and the alcohol content? You might start to wonder, is there a ranking between a higher quality ranking and a higher alcohol percentage? That might be an interesting thing to investigate. So the important thing about splitting, applying, combining is that we were able to get from a data frame, pass, and apply a function to it. So you're able to use group by to do the splitting and combining, and you're able to use .apply to apply functions to your data frame. Alright, so that's it for that. We'll go in lecture 46, we're going to learn about cross tabulation. Okay. Hey, welcome to lecture 46. And this lecture will be on cross tabulation. So for this lecture, we're just going to need to import pandas as PD. So this is going to be a quick lesson on cross tabulations. They're basically just a special case of pivot tables. So let's create a quick data set. And since this is going to be such a quick lesson, I'll show you a little trick in addition to the lesson. So I'm going to, from string IO, I'm going to import string IO, and that will allow me to create some data like this. So I'm going to make some comment lines, do a new line, set. I'm setting right now the column names as one line, and then for my sample animal intelligence columns, I'm going to have sample number 1. The animal will be dog, its intelligence will be smart. I'll have sample 2, it's going to also be a dog, it's also going to be smart. Sample 3, I'm going to have a cat, it's going to be dumb. Sample 4, I'm going to have a cat, it's also going to be dumb. And then sample 5, let's make it a dog. I guess we'll have one dog be dumb. Sample 6, we're going to make it a cat, and we'll have one smart cat. And then I'm going to end this just by ceasing that comment chunk. Okay, so this is just a little trick for using string IO to read data. So this data is basically just a big comment, and then I can store it as a dframe by saying pd.read_table, and this is where we're going to use string IO. It will analyze that data, and then the separator is just going to be equal to \s plus. So don't worry about this. You can explore string IO documentation in Python if you wish. This is just kind of a little trick for creating data sets. And we won't be creating any more data frames this way. It's just that cross tabulation lecture is going to be pretty short, so I figured I'd add a little trick there for you. Okay, and our data frame worked out well. We got our sample numbers, the animal type, dog or cat, and its intelligence. It's either smart or it's dumb. Okay, so now we can create a cross tabulation table, and it's basically just a frequency table. So if we call PD crosstab, that's how you can create a cross tabulation table. And we're going to create it using the animal column, the intelligence column as arguments, and I'll set margins equal to true. So what is this going to do? Well, nothing apparently, unless I spelled something wrong. Margin, should be margins, excuse me. There we go. Okay. So what does this do? It creates basically a pivot table that is almost like a frequency counter. So it's counted the total number of cats, it's created this all column, it's counted the total number of dogs, and then the total number of all the items. And then it's separated out by the second input argument, which was intelligence. So it's grabbed all the animals as your first input, it's separated them out by intelligence, and then it's counted their frequencies. So you have 2 dumb cats, 1 smart cat, all of them are 3. You have 1 dumb dog, 2 smart dogs, all of them put together are 3. And then for all the animals, you have 3 and 3, and all of them together is 6. You could have also done this using a pivot table, but crosstab is just a little shortcut for the special case. Okay, and that's really it about cross tabulations. We won't use them anymore throughout this course, but it's important that you know about them in case you find yourself needing to use them. Okay, and that's it. The next lecture is lecture 47, and we'll be learning how to install Seaborn. I'll see you there. Hey guys, this is lecture 47, installing Seaborn. So in this lecture, I'm just going to go over very briefly how to install Seaborn. So Seaborn, you can just go ahead and click the link to the IPython notebook viewer. It'll have this link on it, stanford.edu. It'll take you to this Seaborn page, so just install and get it. You can just use pip install for Seaborn. The dependencies are NumPy, SciPy, Matplotlib, and Pandas. You should already have those because of all the other installations we've done in the past. It has recommended dependencies. You might not have downloaded those yet. That's going to be stats, models, and Patsy. So you can go ahead and pip install those, and you can also do a conda install if you ended up downloading the Anaconda distribution. Seaborn is a really great visualization library for statistical data sets. Here's just the example gallery off their website, and we're going to learn how to make a lot of these types of plots for analyzing our data. Another nice thing about Seaborn is you can choose different color palettes, has a lot of options for you, and it even has colorblind options in case you're colorblind, so you can explore that as well. But as far as installing Seaborn, it should just be a simple either a pip install and then Seaborn, or conda install Seaborn if you downloaded the Anaconda distribution. Alright, so that's about it. Just go ahead and install Seaborn, and we'll get started with learning how to visualize our data in the next lecture. I'll see you there. Hey everybody, welcome to lecture 48, histograms. So in this lecture we'll be learning about how to use data visualization to create histograms. Alright, so this is going to be the first lecture in the data visualization section. So we're going to do quite a few imports here. First we're going to do our standard imports. So that's going to include import NumPy as NP. Then we're going to import Pandas as PD. And then we're also going to need from numpy.random import randn. Okay, so we got those imports. Then we also need some stats imports. So I'm going to say from SciPy import stats. And then we're also going to need the plotting imports. So I'm going to import matplotlib as MPL. We're going to import matplotlib.pyplot as PLT. And then we're going to import Seaborn as SNS, and that's the convention for Seaborn. And then finally, we're going to give a command, matplotlib, that we've done in the past, inline. And this %sign matplotlib inline, that allows us to see our plots in IPython Notebook. And there we go. So you can go ahead and see there's in the link for the IPython Notebook viewer, all these imports are in one cell. So you can go ahead and feel free to copy and paste that for all the data visualization lectures. I'll be doing that in the future. All right. So first of all, if you want source information for what a histogram actually is, you can go ahead and just go to this link, URL. It's the Wikipedia link for histogram. If you're a little fuzzy on your stats, you can go ahead and just check it out. And this will give you all the information you need to know about histogram. So I'll assume for the rest of this lecture that if you felt unfamiliar with histograms, that you can read about it on the Wikipedia page. Otherwise, I will continue. They're pretty straightforward things. So let's go ahead and create a random normal distributed data set. So I'm going to say dataset 1 equals rand n, and we'll have 100 data points there. And now I'm going to plot a histogram of that data set. And in order to do that, all I got to do is plt.hist. So I'm using matplotlib.pyplot, and I'm calling the hist method on it, and I'm going to input my data set to get that histogram. Okay, and there we have it. So if you notice, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins. So 10 bins is the default number of bins that plt.histogram or .hist will create. So it's going to separate all your data, no matter how many points you have, into 10 equally spaced bins. All right, great. So let's go ahead and make another data set. We'll call this dataset 2. And we'll have this one only be 80 points. And we'll also plot a histogram of it. Hist. And we'll say data set 2. And in this case, I want the color to be red. And I want it to be a particular shade of red, so I can pass the color argument. And there's a color called Indian red, and I will choose that. So let's go ahead and check that plot. Okay, so there's that histogram, and it's now the Indian red color. So what if I wanted to see both these histograms on the same plot? I can totally do that. So what I can do for that is say plt.hist dataset 1. And since they both have different numbers of data points, so this is 80 data points and dataset 1 is 100 data points, I have to normalize my plots. So I can do that by saying, passing the argument normed equal to true. I'll set dataset 1 to have the color Indian red this time. And I'm also, since I'm going to be plotting them right on top of each other, I'm going to want some transparency there. So to control transparency, the argument is alpha. So if I set my alpha equal to 0.5, you can set your transparency from 0 to 1. So 0.5 is that transparency level. So you'll be able to see, in a sense, through the histograms, even though they're on the same plot. And you'll see what that looks like in a second. And let's get some more bins, and I can get more bins. The default is 10, but I'm just going to double that. I'll set bins equal to 20. So that's another argument we can do. And then in the same cell, I'm going to say plot hist, and I'm going to plot dataset 2. Going to set the normalization equal to true, so they're both normalized. I won't worry about the color, I'll just have it use its default blue color for dataset 2. But again, I will set it to have some sort of transparency using alpha, and I will also make that second dataset have 20 bins. Alright, so let's go and see what this looks like. And there you have it. So we have the two histograms now plotted, and they're stacked on top of each other, and where they overlap, since we set alpha equal to 0.5, there's a little bit of transparency there, and you can see that it creates a purple color automatically where the histograms go over each other. Great. So now let's learn how to do something similar with Seaborn and try to get some more information out of this. So I'm going to make two more data sets. I'll say data 1 equals random, and let's get a ton of points. So let's say 1,000 points, and we'll do the same for data 2. We'll have that equal 1,000 points. Let's go ahead and do that. Great. So now I have these two very large data sets. So I can represent this as a joint distribution using joint plots. So the way we do this is we call Seaborn, SNS, dot, and then we can call the method joint plot. And what I'm going to do is I'm going to input my two data sets. So I'm going to say data 1, data 2. And let's see what that looks like. Great. So now we actually have a joint plot of both data sets. So you can see the distribution of dataset 1 and the distribution of dataset 2. It gives you your p-value, and then it individually plots all the data points and where they overlap. So we can also do this if you don't want to see all these points. You can use hex bins for a more concise picture. So let's go ahead and see how that works. So SNS dot joint plot again. Again, we're going to put both data sets. So I'm going to say data 1 and data 2. And now I can pass the argument kind and set that equal to hex to get a hex plot in the joint distribution. There we go. And so that will be a little easier to read, and I'll give you a little more visual information than just all these points themselves. Alright, great. So that's the basics of histograms. If you just want to get a run-of-the-mill histogram, all you got to do is say plt.hist, input your data set, and you can check the documentation for PyPlot if you want to know more arguments to pass. There's colors. Remember to do normed if you want different data sets with a different number of points on the same plot. And then you can do joint plots with histograms on them using sns.jointplot, and you just pass both your data sets there. And if you want a hex bin on this joint plot, you just say the kind and pass hex. Okay, great. Next, we'll learn how to use kernel estimation plots. Hey everybody, welcome to lecture 49. So in this lecture, we're going to be learning about kernel density estimation plots, otherwise known as KDE plots. So if you're a little fuzzy on your statistics and can't quite remember how exactly the kernel density estimation plots work, you can go ahead and just check out the Wikipedia page on kernel density estimation plots. They're basically just ways to estimate the PDF, the probability density function of random variables. And you can see here, here's a histogram on the left, and on the right is the kernel density estimate. And these KDEs are constructed from just Gaussian distribution plots on every data point, and then you just sum them up. So what we're going to do in this lecture is manually create this plot by summing up those Gaussian curves, and then we're going to use Seaborn to do the shortcut method on that. And we'll go over a little bit of bandwidth selection. We'll be using the Gaussian approximation for it. Alright, so let's go ahead and get started. We're going to have to do a lot of imports like we did last time. I highly suggest you just edit copy, edit paste like I'm doing right now from the IPython notebook viewer. So we just have our normal imports, the stats imports, the plotting modules, and the libraries we'll use. Let me fix that. Okay. and where you have matplot inline, so the plots appear in the IPython notebook. So let's go ahead and start off with making a KDE plot manually. Let's just start with a simple rug plot, or some people also know them as carpet plots. All a rug plot does is it just puts a tick wherever a value occurred. So in order to plot something, we need something to plot, so let's get our data set, and let's create that from rand n 25 points. So we have our data set there, and then we can use Seaborn rug plot, so sns.rugplot, and call it on that data set. And now we have our every tick is a spot in that data set, a value in that data set. So to make it a little clearer, let's go ahead and set some y limits on that. So I'm going to say plt.ylim, and then I can set the lower and the upper y limits. So I'm going to set it from 0 to 1, so I just get a bunch of little ticks. Okay, great. So every tick is a point on that data set. Excellent. So let's go ahead and plot a histogram on top of that. So the way to plot a histogram is you can say plt.hist hist, input the data set you want to plot. In this case, it's just called dataset. And if you want to make it transparent, you can do that by passing alpha. So you can put an alpha from 0 to 1, 0 being totally clear, 1 being totally opaque. And in this case, I'll just use a value of 0.3. And since I also want to have the histogram on top of my rug plot, I will say my rug plot in the same IPython notebook cell, and I will pass my data set through it. Scroll down a bit. Okay, great. So it's actually pretty obvious now what a histogram is doing that we saw last time. Basically, for every bin, it's just counting how many ticks are in each bin. So for instance, the bin all the way on the left has 1 tick in it, so the bin is 1 high. If we move to the next bin, it has 0 ticks, so it's 0 high, and etc., etc. It's just counting the number of ticks in each bin and then making the bar that high. Okay. So the kernel density plot, what it's going to do, it's going to represent each of these tick marks with a Gaussian basis function. So we're going to do this manually first before we see Seaborn's shortcut. So this is going to be a big cell. So we're going to say rug plot, SNS rug plot, pass the data set, and then we're going to set up the x-axis for the plot. So we need a min and a max. So I'm going to set the x minimum to be equal to the minimum value in that data set minus 2 for some range, and I'm going to do a similar thing for the maximum. I'm going to set the x max to data set, the max value in there, plus 2. Okie doke. And in that same cell, I'm going to set my x-axis. So I'm going to set x-axis to be 100 equally spaced points from xmin to xmax. An easy way of doing that is just by using np.linspace, so linear spacing. And the inputs here, I'm just going to go from my start to my stop, and then the number of points I want. So I want it to start at xmin, stop at xmax, whoops, and I want 100 equally spaced points. For setting up the bandwidth, I'm just going to use the bandwidth estimation, which, if you're unfamiliar with, you can go down and see here again on the Wikipedia page, the practical estimation of bandwidth, and we're just going to be using this equation. So this equation is just the bandwidth is equal to 4 times your standard deviation to the power of 5 over 3 times n, which n is the number of points in your data set, and all of this to the power of 1 over 5, or 0.2. Okay, so let's put that estimation equation into Python. So I'm going to call it the bandwidth. And first we have that 4 times the standard deviation of our data set. So 4 times, and we can get the standard deviation just by calling std on that data set. And then all of that was Well, the standard deviation to the power of 5. So we have that part, and then the denominator of that estimation equation was 3 times the number of points in the data set. So to get the number of points in the data set, I can merely just check the length of the data set. So I can use len on the data set. And remember, that whole thing was to the power of 1 over 5, which is the same as to the power of 0.2. Great. So next we're going to create a list for those kernels. Remember, we're going to have a kernel density estimation plot, so we're going to set a little Gaussian plot for each of those kernels. So I'm going to make a kernel list, and I'll set it as an empty list, and now I'm going to make a little for loop to build out that list. So I'm going to say for every data point in my data set, I'm going to do 2 main things. I'm going to create a kernel for each point and append it to the kernel list. So how do I do that? Well, I'll create an object called kernel, and I'm going to use the SciPy stats library to do that. So I'm going to say stats.norm, because it's going to be normally distributed. I'm going to take it on that data. It's going to make a normal continuous random variable distribution. So it's going to take that data point, so basically that singular tick, and it's going to make a normal distribution curve using the bandwidth estimation that we just figured out. And then the kernel will be the probability density function method called off using the x-axis that we created earlier. And then once we have that kernel, let's go ahead and append it to the list we made. Alright, so that's the first part. Create a kernel for each point and then append it to the kernel list. And then let's go ahead and set up a scale for plotting. So I'm going to set the scale. I'm going to say every kernel, basically every Gaussian basis plot on each of those kernels, which we're labeling right now as just kernel. I'm going to set it to be divided by the max of the kernel value. And then I'm going to resize everything by 40% just so it reaches a max of 0.4. And then we'll plot everything. We'll say plt plot along the x-axis. Go ahead and plot that kernel. I'm going to set the color equal to gray. And I'm going to make it a little transparent since, remember, we have that red plot on top. After all that, I'm going to just set my y limit axis like we did earlier. I'm just going to set it from 0 to 1. So before we click enter, let's make sure we got everything right. We're going to create a rug plot, set our x minimum and maximum values, then using linspace, create an x-axis values, 100 linearly spaced points between the min and the max, using the practical estimation of the bandwidth, Gaussian approximation, or the normal distribution approximation basically. We created our bandwidth, created an empty kernel list, and then for every data point in the data set, we created and plotted that kernel. Alright, so let's check if this worked out. And there you have it. So you can see the ticks in color here, and you can see the Gaussian basis function plot for all of them. So that's pretty cool, and you notice they all peak at 0.4 since that's what we set it to be. So we normalized everything by the max, and then we set it to go to 0.4. Alright, great. So now that we have that, to get the kernel density estimation plot, we need to sum all those. So how do we do that? We can say the sum of KDE is equal to, using NumPy, np.sum of that kernel list we made, and we'll do it along axis equal to 0. And now we can plot that. So I'm going to say fig for figure is equal to plt dot plot, and I'm going to plot along the x-axis. I'm going to plot my sum of all those kernel densities, and then I'll set the color to be equal to Indian red, like we previously did before. And then I'm going to add a rug plot just so we can get a good look at all the ticks. So I'll say rug plot data set, and then plt, let's go ahead and get rid of the white ticks so there's no confusion. So this will get rid of all tick marks by just putting an empty list there. And then we can go ahead and title our plot by saying sup title, and we'll label this as the sum of the basis functions. So we're going to sum up all those Gaussian basis functions. Alt enter, and what do we get? Alright, great. So now we have the kernel density estimation plot by adding up all of these Gaussian functions for each of the tick marks. Great. So we did it the long way. We can do this in one simple step using Seaborn. This is why Seaborn is so awesome. We can use sns.kde plot and just input our data set. And there you have it. So you can see that Seaborn can do a kernel density estimation plot just in one simple go. And we can adjust the bandwidth of the Seaborn KDE plot to make it less, well, more or less sensitive to high frequency data points, or data sets, I should say. Okay, so to show you what I'm talking about, let's go ahead and make a rug plot. So I'll make another rug plot using my data set, and this time I'll set the color equal to black so it's really visible. Won't make it transparent. And then I'm going to plot kernel density estimation plots for various bandwidths. So I'm going to say for BW, or bandwidth, in the NumPy range, np.arrange, let's go from a bandwidth of 0.5 to 2 in steps of 0.25. So for each of those bandwidths, I'll make a kernel density estimation plot by passing sns.kd plot on my data set. The bandwidth argument for that, we can just say it's BW equals BW. I'll set the LW value to be equal to 1.8, and I'm going to label each of those plots by their bandwidth value, and you'll see what that looks like in a second. So let's go ahead and plot all of those. So now you can see, based on your bandwidth choice value, what your kernel density estimation plot would look like if you specify a particular bandwidth. And just running it with no bandwidth specified, Seaborn will automatically get the bandwidth estimation for you. Alright, great. And then we have all our ticks down at the bottom of that rug plot. We can choose different types of kernels. So for that information, you can go ahead and check out this URL. So this is just a Wikipedia page for what a kernel is in statistics. So if you're feeling a little fuzzy on the statistics of what we just did, you can go ahead and check out that. So let's go ahead and check it out right now. So we can check out on the Wikipedia page the different kernel functions here. And so you can use these different functions in Seaborn if you want to. So let's go ahead and see how all these little different functions work. So we can say, let's go ahead and create some kernel options. So I'll make a list called kernel options equal to, so you have a bunch of different kernel options like cosine or EPA. Let's make a Gaussian. Whoops. And you can check out the Seaborn documentation or just the kernel Wikipedia page if you want to know more about each particular kernel option. But if you're interested in this, you're probably already a pretty advanced user of statistics. And then for kern in kernel option, we will plot, sns.kd plot. We'll plot that data set, and I will set the kernel type to kern. So for each kern in all of these options, we're going to do all of these, and then I will label it the kern type. So let's go ahead and see what Seaborn can do. And there you go. So you get a bunch of different types of kernel density estimation plots based on the kernel type you want to use. And you can go ahead and read more about it either in the documentation or just in the Wikipedia statistics page for what kernel functions look like. All right. Another quick thing we could have done is do some shading. So if you wanted to shade all of these to see where they overlap, you could have set shade equal to true here. Let's do it again. And there you go. You have shading on all of them. So that's something you can do. If for some reason you wanted to plot on the vertical axis, so the y-axis, you can do that as well. I'll show you an example. You can say kd plot dataset and just set vertical equal to true, and you'll be plotting on the vertical axis. Okay, awesome. Finally, we can use a KDE plot also to create a cumulative distribution function, or a CDF of the data. If you're feeling a little fuzzy on that one as far as statistics goes, you can just check out this URL or check out the link on the IPython notebook. And I will go to this link right now. So you can check out the CDF. So it just describes the probability that the variable x is going to be found in that distribution. So if you're familiar with statistics, you're probably familiar with a CDF already. So if I wanted to plot that, I could just say SNS KD plot your data set. And if you want the CDF, you can just set the argument cumulative equal to true. And there you have your CDF. All right, great. You can also do KD plots for multidimensional data. So that would be a multivariate density estimation. All right, so in order to check that out, we are going to create a new data set. So let's go ahead and make the mean, or the center of the data. So I'm going to make an object called mean, and I'm going to set the mean at 0, 0. So the x and the y mean on that data set. I'll set the covariance as well. I'll just set 2 pairs. I'll go 1, 0 and 0 to 100 as those covariances. And now let's go ahead and create a data set using NumPy. Let's go ahead and call it dataset 2. We're going to say np.random, and then we're going to call multivariate normal. So multivariate normal, and here we can pass the mean, the covariance, and the size we want. So this is going to draw random samples from a multivariate normal distribution. So let's go ahead and pass our mean, our covariance values, and the number of points we want. Let's just make it 1,000. And now it's been a while since we used Pandas, which we took a whole bunch of sections to learn about, so we can bring that back. Let's go ahead and put that data into a data frame. So we'll say pd dot data frame, and I'm using pd because I don't believe we imported series and data frame separately. So I'll say dataset2 columns equal to xy, and I'll go ahead and plot this using KD plot. And so notice the really great thing here before I click enter, you're using Seaborn in perfect sync with a Pandas data frame. Let's go ahead and see what happens. And there you have your multivariate density estimation using the KD plot and a straight up Pandas data frame. If you wanted to, you could have also passed two vectors separately. So you could have said sns.kd plot, and we could have just passed the x and the y vectors. So I could have said dframe.x, dframe.y. So instead of just passing the whole data frame, pass their two vectors separately. Go ahead and see that, and you'll get the same thing. Another option you can do is you can shade. You can do that just by passing the shade argument, set it equal to true, and now you have it shaded instead of those contour lines. And you can again specify bandwidths. So just like we did in the other plots up here, as far as specifying the bandwidths, you can do the same thing. So scroll back down. You can say KD plot your D frame, and again set bandwidth BW equal to whatever value you want. So I'll make it some ridiculous value 1 just so we can see the heavy change. And there you can see that bandwidth change on your multivariate KD plot. Or if you just want to use that the Silverman estimation that we used before, you can actually call it by a string. So you can say KD plot, call your data frame from Pandas, and then set your bandwidth equal to the string Silverman, and that will run your Silverman estimation bandwidth, or Silverman's rule of thumb, it's also called. And there you have that bandwidth. Okay, and then lastly, we can also create a KD joint plot. So similar to the hexbin plots we saw before, I can say sns.jointplot, and let's go ahead and we can label it x and y for the axis. Pass your Pandas data frame, and then if you want a kernel density estimation plot, you can label it as, pass the argument kind, and then pass KDE as the kind of joint plot you want. So this is the same as the joint plots we did before, except now we're specifying it that it's a kernel density estimation plot. Let's go ahead and do that. And there you have it, your two multivariate kernel density estimation plot. All right, so we just went over a ton of stuff. Go ahead and look back, make sure you understood all of it. This particular lecture was really dependent on your understanding of certain statistics. So go back and look up on Wikipedia those Wikipedia links if you're feeling a little fuzzy or don't remember all of those or just need to learn them in general. And then you can come back and then really understand the different plotting techniques we just did. Okay, so that was kernel density estimation plots. Up next, we're going to learn about combining plot styles using distplot. Okay, I'll see you there. Hey everybody, welcome to Lecture 50, Combining Plot Styles. So in this lecture we're going to be learning how to combine plot styles. I've already copied and pasted the imports we're going to be using for the data visualization section. So you got your normal inputs, the stats library, and then the plotting modules, as well as matplot inline command. So this lecture will be quite a bit shorter than the last lecture, and we're going to learn a lot. So we're going to learn how to combine different plot styles. So let's get something to plot. Let's go ahead and make a data set. we'll set that equal to this random 100. So let's get 100 points. And then to make a combined plot, Seaborn has a built-in dist, so dist plot, and this allows us to combine plots. So if I pass my data set through this and I set my bins equal to 25, by default bins are set to 10 in Seaborn. I'm going to hit Alt Enter. So by default this dist plot combines a kernel density estimation plot, this line that we discussed in the previous lecture, with a histogram, which we also discussed in previous lectures. Great. So we can also choose whether it's a rug plot, a kernel density estimation plot, or a histogram. Those are all input arguments to dist plot, and we can either turn those plots on or off. To show you what I'm talking about, let's go ahead and call the dist plot, call it on the data set. Again, set your bins equal to 25. And now what I'm going to do is I'm going to set rug equal to true, so I can see a rug plot. And I'm going to set hist equal to false, so I don't see the histogram anymore. Let's go ahead and hit Alt Enter. And so now by default it showed the KDE, but I set rug to true, so it's showing my rug plot, and it's not showing the histogram anymore because I set hist to false. Excellent. So let's say I want to control specific plots within the combined plots. So if I wanted to do, maybe set a certain color to the rug plot, or set certain parameters on the KDE plot, I can do that by passing dictionaries into dist plot. So I'll show you how to do that now. So we can call SNS dist plot, call my data set, set the number of bins, let's call it 25, and what I can do is I can pass dictionaries. So the way we can do that is by having a plot underscore KWS argument equal a dictionary. So what I mean by that is if I want to edit my KDE plot, and hold on a second, I forgot the S there. Like I was saying, if I want to edit my KDE plot, I'll set KDE and then underscore KWS for those arguments, and I'll set those arguments equal to a dictionary. So I have my color key, and I can set that equal to a color, so I'll select Indian red, and then I could also make a label specifically for the KDE plot and set that key equal to KDE plot. And then let's say I wanted to also edit my histogram that came along with the dist plot. I can do that just by saying hist, again underscore KWS equal, and then I can pass a dictionary again with certain controls. So let's set the histogram color to blue, and let's label it. So set the label key, and its value will just be hist. I'll capitalize it. Okay, let's go ahead and see if that worked. Great. So now you can individually control the subplot, not quite subplots, but each individual plot in the combined plot, just by passing dictionary and then the plot subname underscore KWS. Great. Alright, so again, we learned so much about pandas, and Seaborn works really well with pandas. We can use pandas data objects for this, so I can say from pandas, let's go ahead and import series. And let's create a series from a data set. So I'm going to say ser1 equals series from the data set, and I'll set that series name to be the string my underscore data. And then let's go ahead and see what that series looks like. So there's my series made from those 100 points. Great. And now we can use Seaborn, SNS.dist plot. You can pass a Pandas series, and again, just let's say bins 25, and it'll plot the Pandas series. So Seaborn works fantastically well with Pandas. It's a great data visualization library that works really well with Pandas. Okay, so let's go ahead and go to the next lecture where we're going to learn about box and violin plots. I'll see you there. Hey guys, welcome to lecture 51. This lecture will be on box and violin plots. So I've already imported on my first cell all the imports we've been using for the data visualization section. And in case you're a little fuzzy on box plots or violin plots, you can go ahead and check out this link. It's just a link to the Wikipedia page for box plots. So they're pretty straightforward. It's just another way of representing a probability density function using quartiles. So you can see here, this figure kind of shows how the probability density function relates to the box plot. So let's just take a look at that. Okay, so let's find out how to make these box plots. Alright, so let's just start off with two data sets. So I'm going to make data 1 equal rand_n, just 100 points. And I'm going to do the same thing for a second data set, rand_n 100. And now let's go ahead and create a box plot. So the way we can do that using Seaborn is SNS dot, and you probably guessed it, box plot. And let's go ahead and pass both data sets, and we can do that using a list. So I'm going to pass data 1 and data 2. Let's see the result. Alright, and there you have your box plot. So if you notice here, on top of this blue box plot, you still have an extra outlier point. And if you want to include those into the range of the whiskers, you can. And you can do that by calling box plot, again, both data sets, data 1 and data 2. And this will be passed as a list, so put them in brackets. And then you can have the whiskers include any outliers by setting it equal to npy.inf infinity. So numpy infinity, and there you go. So you can see now the whiskers on the blue box plot have jumped out to that outlier. And so now your whiskers include all your outliers as well. You can also set it horizontally if you wished. So box plot, let's just do one data set. We'll just do data 1. And if we want to set it horizontally, we can just pass the argument vert for vertical equal to false. And now you have a horizontal box plot. Great. So while box plots are really useful and great, especially for things like financial data and stocks, we can also use violin, or some people call them viola plots. And that combines the simple format of a box plot with the information of a kernel density estimation plot. So let's see how we can make those. First, I'm going to show you an example where the box plot won't give you the full picture. So in order to do that, I'm going to first make a normal distribution. I'm going to rename data 1. And I'm going to use stats.norm to make this distribution. And so what we're going to do is call it from input 05, and then I'll use .rvs to get 100 points from that distribution. And then I'm going to also make 2 gamma distributions, and then I'm going to use I'm going to concatenate them together. So I'm making some really specific data sets to show you the example of when a box plot won't give you the whole picture. So don't worry too much if you don't get how I make this second data set. It's not actually a big deal as far as learning how to create a box and violin plot. So I'm going to use NumPy concatenate. We've actually learned how to use that before. And I can call the stats gamma to get a gamma distribution. And I'll just run it 5, and I'm going to get 50 points. And I'm going to subtract 1 from that. And then, since I'm going to use concatenate, I'm going to make another gamma distribution using stats. And again, I will run it with 5. And in this case, I will also call 50 points. But what I'm going to do here is on the second gamma distribution, I'm just going to multiply it by -1. Alright. And then I'm going to box plot both data 1 and data 2. So I can do that by saying SNS.boxplot and then pass a list of both those guys, data 1 and data 2. And let's set our whiskers to include any outliers, so I'll have them go to infinity. Oops, and I spelled gamma wrong here. There we go. Okay, so if you just quickly look at these two box plots, you could say that both distributions are pretty similar. Just one's a little wider than the other. But if you want to get the full picture, you might need to look at the kernel density estimation plot. So that's where the violin plots come in. They're going to basically combine a KDE plot with a box plot. So in order to do that, I am going to call violin plot. So SNS violin plot. And then let's go ahead and call data 1 and data 2. And now you can see the distributions look actually quite different. So this is pretty revealing. Here it's clearly a normal distribution, and then you can see here the set of the two gammas, one positive and then one negative. So the box plot definitely doesn't show you that whole picture there. So violin plots can be pretty revealing for your data. And just like we used for the KDE plots, we can also change the bandwidth of the kernel used for the density fit in a violin plot. And you can do that just by passing your data and then specifying the bandwidth. So if I specify some ridiculously small bandwidth, so it's super sensitive to the frequency, that can affect your violin plot. So you can decide what bandwidths you want to do if you want to input specific bandwidths into your violin plots, just like we did for kernel density estimation plots. So also, kind of similar to a rug plot, you can include the individual points. So what I mean by that, to show you an example, is let's have our violin plot, data 1. So here's our violin plot, data 1, and let's say I want to include, just like a rug plot, all the individual points. Well, I can do that either with points or sticks. So I can pass the argument inner equal to stick, and now I should get a line, and all these lines are individual data points along this distribution. So it's basically bringing the idea of the rug plot to a violin plot. Alright, and that's pretty much it as far as box and violin plots. Just remember, you can call them using either violin plot and box plot, and it's always good to keep in the back of your mind about the kernel density estimation plot, just to make sure you're getting the whole picture of your data. Okay, and that's about it. In the next lecture, I will be going over multiple regression plot. Alright guys, let's go ahead and start lecture 52. And this will be on regression plots, or multiple regression plots. Okay, so I've already filled out my cell with the normal inputs and imports for the data visualization section. And we're going to learn how to visualize multiple regression with LM plot. So Seaborn comes with some example data sets, and we can use those in conjunction with a Pandas data frame. So let's go ahead and upload one of those data sets. So I'm going to make a data frame called tips, and from Seaborn SNS call load underscore dataset, and then the name of this data set is tips. Wait for it to load. Alright, once it's loaded, let's just go ahead and check out the first 5 rows by calling tips head. Okay, so what's in this data set? We got a total bill, the tip left on that bill, the sex, whether the person was a female or male, were they a smoker, the day they paid their bill, the time of their meal, and the size of the party. Alright, great. So now that we have that information, let's go ahead and plot it. So let's plot the total bill, or the tips versus the total bill. So we can do that using SNS, and we're going to use lmplot to do a regression plot here. So let's put in total underscore bill, and we'll plot then tip, and then the data frame is going to come from is tips. So let's go ahead and plot that. Alright, awesome. So first off, we can see a scatter plot of all the points on tip versus total bill, and then we see the linear regression line, and that's just an estimated linear fit model for all the data. So this is the linear regression fit for all this data that's been scattered on this plot. Alright, so just like before, we can use dictionaries to edit individual parts of that plot. So to show you an example of this, let's go ahead and say SNS lmplot. Again, we're going to do the total bill, and then the tip left, and we're going to grab it from the tips data frame. And now, if you remember from previous lectures, we can say the name of the plot type underscore KWS, and now I can set a dictionary for some additional arguments for each individual plot. So let's say I want my scatter plot to use a particular marker type. I can say marker as an argument and have that key have the value of O. And you can look at the documentation. You can also put in stars and other different markers for scatter plots. And then I'm going to set the color of the scatter plot, have the key color be Indian red. Alright, and then for the line, for that linear regression plot, let's see, I'm going to set some of those. I'm going to set the line width. So I'll set that equal to 1, and then I'll set the color key equal to blue. Well, not equal. I'm sorry that I keep saying that, but it's a dictionary, so it's your key and then your value associated with it. You're not actually typing in equals. Alright, so let's go ahead and see how that plot works out. And there you go. So now on this multiple regression plot, you've been able to individually pass arguments on the scatter plot and the linear plot separately. Okay, so this is just a first order trend line. We can also do multiple higher orders if we want to do some quadratic fits to this data set. So for instance, the way I can do that is by passing order. So I'm actually going to do it on the previous cell. Since we'll keep all the information the same, I can indicate what order polynomial fit I want. So if I wanted a fourth order, I just pass the argument order 4. So let's see how that changes our fit. And so now we have a different fit on the data. So you can use that in case you don't want a linear fit. You can just specify what order fit you want. Okay, so we can also just not fit a regression at all. We can just have it be a pure scatter plot. So we can say SNS lmplot, Again, the total bill, the tip, and then the data frame we're going to get it from is tips. And then if we want to just get rid of the regression fit, I can say, whoops, I can pass fit underscore reg equal to false. And if we do that, let's go ahead and see the plot. And so now we basically just have a scatter plot of all the data. So lmplot also works on discrete variables, such as the percentage of the tip. So let's go ahead and see what that looks like. So to get the percentage of the tip, let's go ahead and just remind ourselves what the data frame looks like again. Alright, so we got the total bill, the tip, and then the other columns. So let's go ahead and make a new column. So we'll say tips, and I'm going to say tip underscore PECT, so it's a tip percentage. And I'm going to set that equal to 100 times tips, the tip column, divided by the tips total bill. So now I'm just making a new column onto this tips data frame called the tip percentage. So what percentage of the tip was the total bill? I'm sorry, what percentage of the total bill was the tip? And so I'm going to say 100 times tip divided by the total bill to get that number. So let's go ahead and do that. And now let's take a quick look at that column. Here we go. So for instance, in row 0, the total bill was almost $17. You had a $1 tip, and that's about 6% of the bill. Great. So let's go ahead and plot that then, since we're going to check how it works with discrete variables. We can do SNS lmplot. And now I'm going to plot the size. So I'm going to plot tip percentage versus the size. So I'll have my x be size, and then my y be tip percentage, or tip PECT. And then again, the data frame we're grabbing this information from is called tips. So let's go ahead and see that. And so there you go. So now you have discrete variables, and they've been plotted using lmplot. So here's the size of the party, and then the tip percentage they left behind. If we want to make this a little easier to read, we can add a jitter to it. If you're unfamiliar with jitter, you can go ahead and check out the Wikipedia link for jitter. So I'll leave it there for you guys. If you're already familiar with jitter, or after you've read that link, you can come back. And the way to add jitter is, again, we'll run size, tip, tips, and then we can set the x jitter. For jitter related to the x-axis, we'll just equal to 0.1, just get a light jitter. So it should spread out our data a little bit more. There you go. It just makes it a little easier to read, so not as many points overlap with each other. All right, great. So we can also estimate the tendency of each bin. So each bin is the size of the party in this case. So if I wanted to do that, I could say SNS lmplot. Again, size for the x-axis, tip underscore PECT for the y-axis. Data frame I'm going to use is tips. And now I'm going to say x estimator equal to np or numpy dot mean. All right, and so now this shows the estimate for the tendency of each bin, depending on what tip percentage for the size of the party they'll leave behind. So it looks like there's a little more variance for party sizes of 1 than of 2 through 4, which is a bit interesting. Another thing we can do with lmplot is we can use the hue facet to automatically define subsets along a column. So I'll show you an example of what I mean by that. So I'm going to say SNS.lmplot, And in this case, I'll have the total bill be the x-axis, and then the tip percentage be the y-axis. Again, I'm grabbing it from the tips data frame. And now I'm going to pass the hue argument, HUE. And I'm going to set the hue equal to the sex column, so whether they were male or female. And then I'm going to add a markers argument as well, and I'm going to pass a list for markers. So in this case, I'm going to use X markers for the female and O markers for the male. And using the hue argument, we're going to automatically create hues for the sex column. So let's go ahead and see what happens when I do that. Okay, so now I basically have two regression plots right on top of each other. The green is the male, and the blue X's are the female. So I got both scatter plots and then both linear regression plots. So this could be a really interesting case study in who tips more, females or males, and what's the tendency for the tipping amount. All right, so what if we wanted to know, does the day make a difference in how much the tip is? So we can do that as well. I can ask for the regression plot. Let's go ahead and set X to the total bill. Set Y equal to the tip percentage. Take it from the tips data frame. And in this case, I'll use hue again, HUE. And now I'm going to set it to the day. And I'm not going to pass the markers argument. I'll have them all be the default, same scatter marker. All right, so let's go ahead and pass hue for day. And now we can see whether the tip percentage changed on the total bill versus the subsets of the column for day. So how much did people pay percentage tips on Friday? What was the relationship between Saturday and Sunday versus just Thursday? So you can get a lot of interesting information off these multiple linear regression plots. All right, and then finally, it should be noted that Seaborn also supports what you can call local regression model fitting. So this is definitely a more specific statistical analysis technique. We won't be using it in any of the projects, but in case you're familiar with statistics, you should know that Seaborn can do this. Sometimes it's called LOES or LOESS, so you can look that up too. So let's go ahead and see what local regression can do for us. So we can say total underscore bill, tip percentage as the y-axis, tips is the data frame we're going to graph from, and so we'll set LOES for local regression equal to true. And now I'm going to edit my line, and if I want to edit my line, I can do that by saying line underscore KWS as we've done in the past, and like we've done in the past as well, set a dictionary. So I'll set the color key, set that to have a value of black, so it shows up against the scatter plot. Okay, and that's what your LOES line looks like. Again, this is a pretty specific statistical thing, so don't worry too much if you don't quite understand what just happened. It's really more of a specific task that you may want to do in the future. Okay. Now let's zoom out a bit. LMplot is actually using a lower level function called regplot or regplot, depending how you want to say it, regplot, which is just for regression plots. So let's go ahead and look at that lower level function. So sns.regplot for regression plot, and then I can insert total bill, the tip percentage, and tips. And so regplot is the lower level function that lmplot was built on top of. So this is the more robust, if you will, plotting function. So here we have tip percentage versus the total bill. And regression plots, they can be added to existing axis of subplots without modifying anything else in the figure. So if you had a figure with two subplots, you could use this reg plot or regression plot along with other plots, such as like a violin plot. So to show you what I'm talking about, let's go ahead and create a figure with two subplots. So I'll say fig, and then two axes. We'll say axis 1 and axis 2. So I'll set these equal to plt.subplots, and that's how we can create subplots. Whoops. That should be a dot. Okay. Call the subplots method on the plot, and then say what you want the plots to look like. So the number of rows and the number of columns. So I'm going to say 1 row and 2 columns. So 1 by 2 plots, and then I'll say Sherry equal to true, so they align better, and then I will call the regression plot function with the total bill on the x, the tip underscore PECT. On the y, we're going to grab that information from tips, and I will set axis equal to axis 1 for the subplot. And then I can also make a violin plot for one of the subplots. And I will have the violin plot be, let's have it be the tip percentage column. And we'll have it be the size of the party. Tips, size. Alright, and then let's choose a color scheme for this. So let's say color equals, and for color schemes, if we want it to be reds, we can pass this, reds underscore R, since there's going to be multiple violins. And then in this case, we'll set the axis equal to axis 2, because it's going to be the second plot over. Alright, so let's go ahead and see what these subplots look like. Oops, and looks like there should be no underscore there. My apologies. There we go. Alright, so using reg plot, you're able to use it in a subplot figure. So here's a figure with 2 subplots, 1 regression plot, and 1 violin plot. Alright, and that's it. Next up, we're going to learn about heat maps and clustered matrices. I'll see you there. Hey guys, welcome to lecture 53. This lecture is on heat maps and clustered matrices. Alright, so this is the last lecture in the data visualization section. So let's go ahead. As I mentioned before, Seaborn comes with some great data sets that we can play and learn with. So in this case, we're going to grab a data set called flights underscore dframe. Remember to input all your imports into a cell, the usual ones for the data visualization section. And then we'll set flight underscore dframe equal to SNS load underscore dataset. And the dataset string name is flights. Okay. So let that load. Great. Once it's done loading, let's go ahead and preview it. So we can say flight underscore dframe. And we can check out the first 5 rows. Alright, so what do we have here? We have the year, the month, and the number of passengers that took a flight, either on this airline or on a specific plane. Doesn't really matter for our case. Let's go ahead and pivot this data frame so it's easier to manage. So as we've learned in the last, or not the last lecture, but some couple lectures ago on pivots, we have flight underscore dframe, and we're going to set this equal to the pivot and we're going to pivot it by month, year, and then the values we want are passengers. So just a reminder about pivot and pivot tables. We set the rows we want, so we want the rows to be months, we want the columns to be years, and we want those values to be filled out with the number of passengers that took a flight. Let's go ahead and show this data frame now. Flight underscore D frame. There we go. So now it's in a much better format for us. Great. And this almost looks basically perfect to make a heat map or a cluster matrix visualization from this. So let's go ahead and show you what we're talking about here. If we want to make a heat map of this data, we just call sns.heatmap, and we're going to pass that data frame through it now. Alright, and now we have a data visualization for a heat map for the passengers. Now let's say you wanted to actually know the number of passengers and annotate each cell with the number of passengers, not just have it be by color. You can do that. So let's go heat map. Again, we'll pass that data frame. And then we'll say annotation equal to true. So in this case, ANNOT equal to true. And let's set FMT equal to D just for some formatting. And there you have it. So now you have annotated each cell with the number as well as the color. So Seaborn is going to automatically try to pick the best color scheme for your data set, and that basically just depends whether it's a converging or diverging color map. So in this case, it's chosen a converging one, so it's gone from a light to a dark. But if you wanted to choose a center, if you will, for your color map, you can do that. So you can specify if you want a center for your color scheme. So to show you what I'm talking about, let's go ahead and do SNS heat map. We'll call the flight D frame on it. We'll set center equal to flight underscore D frame dot, and then we'll get the location. So we'll say LOC, and we'll have it be January 1995 or 1955. Excuse me, 1995. Okay. Alright, so what is this going to do? Well, let's go ahead and take a look. Alt enter. So now we have a diverging color scheme. So we've created our own center. So white now is going to be at January 1955. Values above that are going to have a more red color scheme. Values below that are going to have a cooler blue color to them. So instead of like the first one where it converges all the way up from 600, now it's diverging from the January 1955 value. So that's how you can choose your color schemes. We can also add heat maps on axis of subplots to make more informative figures. So just like we did with regression plots and the violin plots in the last lecture, we can do something similar for these plots. So let's go ahead and try making a figure with multiple subplots. So I'm going to say F for the figure name, and then let's make two sets of axes. So I'll say axis 1, axis 2. I'm going to set that equal to plt.subplots like we did in the last lecture. So we'll say 2, 1. So in this case there's 2 rows and 1 column. Now I'm going to say, I'm going to call my yearly flights object equal to flight D frame, take the sum. So what I'm doing is I'm taking the sum of all those columns, and the columns are the years. So you can imagine if I take the sums all along 1949, I will have the total number of flights for that year. So that's the yearly flights object I'm making. Okay, so since yearly flights, if you were to look at it right now, it's in a little bit of a weird format. We'll have to grab the values we want with a series and then put them into a data frame. So I'm going to set years equal to pd.series, and I'm going to grab it from yearly underscore flights, and then I'm going to get the index values, and then I'm going to set years to be equal to a data frame. So I'm going to make a data frame out of that series. So I created a series and then ran that series through a data frame. We're going to do the same thing for flights, and this is just to take care of some formatting issues in the yearly flights data. Do a similar thing here, except in this case I just want the actual values, not the index values. And we'll create a data frame using that series, pd.dataframe, flights. Alright. And now we're going to make the data frame complete and name the columns. So I'm going to say year underscore dframe equal to pd.concat. So I'm going to use a concatenate. And I'm going to put together years and flights. And I'm going to do this along axis equal to 1. And then I'm going to name my columns. So year underscore dframe.columns equal to, so now the columns, let's give them a name. So they should be year and flights. Great. That way they go with each of the series, or I guess they're data frames now that were concatenated together. Alright, so let's visualize that data. I'm going to make a bar plot, and you can make a bar plot in Seaborn by passing bar plot. And I'm going to say bar plot of the year. So let's see, bar plot, bar plot year. I'll set y equal to flights, so the total number of flights that year. My data is going to come from the year underscore dframe, so that data frame we just made. And I'll set the axis, or ax, equal to axis 1, because it's on a subplot. And then I'm going to create a heat map below it. So I'm going to say sns.heatmap flight underscore dframe. And then we're going to say, let's go ahead and get a color code or color palette for that. The way we can do that for a heat map is by passing the cmap argument. And in this case, I'm going to choose blues. And you can look at the documentation for other color schemes. We'll also say axis is equal to axis 2, so it goes below. And then something I want to do is, if we scroll back up, we can see that this color bar is set vertical. I want to set it horizontal. So the way I do that is I pass, as we've done before, I can say cbar underscore kws and just pass a dictionary. So in this case, the key is going to be orientation. And I'm going to give its value as horizontal. Alright, so that way the color bar is horizontal. So we've done a lot right now. Let's go ahead and see how we were able to visualize it. Yearly values is not defined. I probably have a spelling error somewhere. Let's go back up and try to catch it. Yearly values, this is in line 8 of flights. So yearly values, I should have written yearly flights. Not sure why. I see. I wrote that twice. That should have been flights. Okay, now let's try it. Okay, there we go. Alright, so now I have my bar plot on top and I have my heat map on the bottom, and my color bar has been oriented horizontally, so it's on the bottom as well. And you can see now that the years match up, and you can get a really nice data visualization here. So that's great. Finally, we're going to learn about using a cluster map. So let's go ahead and create one. So a cluster map is going to reformat the heat map so similar rows are next to each other. So I'm going to say sns.clusterMap of that data frame, so flight underscore D frame. Okay, and here we have our cluster map. So if you notice, the months are no longer in order. January, February, November down here, December's over here. But in this case, similar rows are next to each other. And you can see they're grouping and linking, they're clustering, if you will, on top and on the left. And here you have your color bar scale. Okay, so let's go ahead and just uncluster the columns. So we can do that by saying sns.clusterMap. Let's pass flight D frame again. And in this case, I'm only going to cluster by the rows, so I'm going to call col cluster equal to false. See what that looks like. Okay, so now I've only done it by the rows, so by the actual month. We don't care about the years themselves. We'll keep those independent of each other. So it's only being clustered by the month. All right, so since the number of flights increase every year, as we saw above, if we scroll up a bit, you can see the number of flights is increasing every year. So we should set a standard scale. So let's go ahead and standardize. So I can do that by saying sns.clusterMap. Say flight underscore D frame. And I'm going to set a standard underscore scale and set that equal to 1. So now what that means is I'm going to standardize by the columns or by the year. So let's go ahead and do that. All right. So now what do we see here? You can really tell now that the summer months are the heavier usage months, since everything's been standardized by the year. Now if you look at your scale, it goes from 0 to 1. So here we've eliminated the problem of flights increasing every single year. We could also scale it by rows. So we could say sns.clusterMap flight underscore D frame, so pass the data set, and then set the standard scale underscore scale equal to 0. And this would then scale the rows. All right, great. And then finally, we can also normalize the rows by their z-score. So this is going to get a bit into some heavier statistics, but this subtracts, so what a z-score does, it just subtracts the mean and then divides by the standard deviation of each column. So then the rows have a mean of 0 and a variance of 1. So this is going to be the very last thing we go over. So it's going to be cluster map, flight underscore D frame. And if you want to normalize by their z-score, you just input the argument z-score equals to 1. Again, what the z-score does, it just subtracts the mean and divides by the standard deviation of each column, so that the rows have a mean of 0 and there's a variance of 1. And so this is what the result looks like. So you can really tell that it's the summer months are where you have higher number of flights. Okay. So that's it for heat maps and clustered matrices. You should give yourself a huge pat on the back. You've made it all the way through lecture 53. Great job. Next up is a whole new section, and we're just going to be doing projects that you can do to add to your portfolio, and we're going to be using real data sets. We're going to take all the tools we've learned and hammer out some great data analysis projects. I'm really excited for you and the next section. Let's do this. Congrats again on finishing all the way up to lecture 53. Hello everyone. In this lecture we're going to be going over just interactive command prompts, IDEs, integrated development environments, what they are, what are different practices for running Python code, and we'll get a quick introduction on why we decided to choose Jupyter Notebook for this course in general, and what other options are out there. In future lectures we'll get a deeper dive into Jupyter Notebooks in general, but for now I just want to show you a couple things. So you might be wondering, how do I actually run Python code? We saw a little bit earlier with the with the IDLE that comes in with Python, or idle it's sometimes known as. Let's go ahead and try that again. So here I'm on Windows. What I'm going to do is type in Anaconda command prompt. If you're using a Mac, you can just use the terminal for this. So if you're on Mac, just go ahead and open up the terminal. Now, most users are on Windows, so I'm going to say Anaconda command prompt, open up my command prompt, and here what I'm going to say is Python. And if I type out Python, what happens is I'm actually running Python within this command prompt, or within the terminal. And now I can put in Python commands, so I can say print hello world. I can do 2 plus 5, it'll return 7. Now I can actually interact with Python and work with Python. If I want to quit, I just say QUIT, open and close parentheses, enter, and now I'm back in my terminal line. So if I try to say print hello world now without calling Python, you'll notice I get an error. That's because I'm not actually running Python. I'm just exploring the command prompt or the terminal on my computer right now. I'm not actually running Python. So what are our options for running Python code? I'll go through a couple of options and different ways to run Python code in general, and then I'll settle at the end on the Jupyter Notebook and discuss it a little bit further. So what's a way we can run Python code? Well, the first way is what we just did, right? I can type in Python and I can run Python code this way. So I can say 4 plus 5, etc. And I know you guys don't know any Python yet, but don't worry. Hopefully these are simple enough commands that you can see what's going on. Now, you can imagine if I have some really long code, I don't want to have to type it in here line by line. So what would I do then? Well, I could get a text editor. So any text editor would do. Right now I'm just using a simple notepad. And I can type in print hello world, and what I'm going to do now is file, save as, and I'm going to save it as first underscore program.py, and I'm going to save it in the same directory that was showing up here in Python. So I have C users, my username, Anaconda. Okay, so that's where I'm going to save it. So let me find that location. OSC, scroll down to users, my username, go to Anaconda, and I'm going to save it right here. And notice I'm going to save it under all files type, so it takes the .py. And this is actually now going to be a Python code. So I can come back here. I'm going to quit the Python instance that's running. Notice now I'm back on just normal command prompt. And then I can type Python space, and then I can actually say first underscore program.py. And if I hit enter, you'll notice I can put hello world out there. So this is how I could theoretically run larger programs. I could type it all, if I knew the syntax, into this text file. So I'm going to print some more stuff here just so you realize it's actually working. File save. And then if I press up on my arrow key to get that code again, just that statement of Python space first underscore program.py, and I hit enter, you'll notice now it's running everything I put into the text file. So this is one of the most basic ways to write a .py file and have Python run it. You go to your command prompt or your terminal if you're a Mac user, say Python space, make sure you're in the location. So here I'm at C users, my username Anaconda. You have to be at the correct location for this to work. Say Python and then whatever that .py file is, and it will automatically run it for you. So you might be thinking, this looks kind of ugly. I don't really want to use Notepad all the time. So what are better options? And this is where your options were really spread out and you have a ton of them. So I'm going to go over a few of them and then end up on the one we'll use for this course. So one option is just to use a nicer text editor. So some text editors that are really common are Sublime Text. So Sublime Text is a free text editor, and it'll actually highlight, and you can see some videos going on here, highlight code syntax and help you out a lot in that fashion. It has a lot of features and is one of the most common text editors used. Another common text editor is Notepad++. So here I've just Google searched Notepad++. It's another common text editor, and depending on how you save your file, so if I save a file as .py, it'll actually do highlighting. So you can see here there's some highlighting based on what the syntax is. So that's one version. Just get a nicer text editor. Then there are other integrated development environments, IDEs, that are specifically for Python. Some of them include Wingware, Python IDE. So it's an intelligent development environment for Python programmers. Another one is Komodo. So Komodo is actually more of a text editor that just like Sublime and Notepad that you can also use. There's PyCharm, which is another Python specific IDE. And then there's Spider, which if you're coming in maybe from a language such as MATLAB, Spider will feel like a really familiar environment feel to you, and it's based heavily on scientific computing. And then another one, which is a little different, is Jupyter. And this is the one we're going to be running our course in. So if you go to jupyter.org, remember we've already installed Jupyter through Conda install Jupyter or Conda update Jupyter. I'm going to go ahead and scroll down and say try it in your browser, and I encourage you to do the same thing. So this is what Jupyter looks like when you run it in browser or run it in your own notebook. And you can click here, top right. I'm going to zoom in a bit so you can see better. And future lectures, you'll notice Jupyter, it's way more zoomed in, so I apologize if you couldn't see. But what's nice about the Jupyter Notebook is it supports other languages such as R, Julia, Bash, Haskell, Scala, Ruby. So if you ever decide to work in other languages, Jupyter Notebook's really nice in that way. Here I'm going to create a new notebook using Python 2. So I clicked New there. And you'll notice what's really nice about this that I think makes it ideal for teaching Python and learning Python is if I say, you'll notice I have a little cell here in. If I say print hello world and then click run, so run cell, you'll notice the output is actually put right below that cell. So you have an input and then an output directly. This is a really nice system if you're just starting to learn Python because you can directly interact and see what code comes out when you have code in. It's also really nice because it's really easy to share these notebooks. I can name these notebooks, so I can name this first program, save it, upload it to the internet, share it. You'll notice there's going to be Jupyter notebooks for every single lecture in this course. And this makes it an ideal environment for learning Python. It's a lot nicer, it's a lot more direct. You can download the notebooks that I've made for you, and that's why we're going to be using it for this course. Now, will Jupyter scale to much larger programs? No, it won't. So if you begin to want to go into full stack web development with Python, you'll eventually have to abandon Jupyter notebooks and go for something a little more heavy duty, such as PyCharm or other text editors. What is Jupyter really good for? Jupyter is really good for, like I said before, learning and teaching Python. It's also been extremely popular in the field of data science. So there's a lot of features that Jupyter has that we'll talk about in the next lecture that allows you to really take into account a lot of the new data science modules and libraries for Python, and that's personally why I really like it and use it. And it's really common just for ad hoc analysis and quick data analysis in the data science field with Python. So that's where you'll see it used in a more professional state. It's also really nice just to make games with it. Again, if you're making a more heavy-duty game, you'll eventually abandon Jupyter. But for right now, for this course, it's the ideal learning environment, and I think you'll really learn to love Jupyter, and you're going to be a big fan of it by the end of this course. Okay, so I've talked a lot about Jupyter, but haven't said much of how it actually works, how you can run it on your own computer. So let's go ahead and go to the next lecture where we can learn about Jupyter, which were previously known as IPython notebooks, just to let you know. And let's learn more about how we can make Jupyter run on our own computer and how they work there and the various features of it. Okay, thanks, and I will see you at the next lecture. Hello everyone, and welcome to the lecture on Jupyter Notebooks. So in the previous lecture I explained about general IDEs, how you would run a normal .py file, but now we're going to explore the IDE or development environment we're going to be using a lot for this course, which is the Jupyter Notebook. Let's explore some more of its features, how it works, how we can start it up on our own computer, etc. Okay, so as I mentioned before, you can always do or use Jupyter online for free at try.jupyter.org, and then you can start a notebook. So if I go back here like we did in the previous video, it'll take you to something like this. You click New, Python 2, or Python 3 if you are already familiar with Python 3. Title your notebook, hello, and then you can start using your notebook. Now, what if you want to save these files onto your own computer? There's various ways to do that. You could click Save here, etc. Or let's show you the more common way, which is to start this on your own computer. So how would you do that? If you're on Windows, what you're going to do is type in Anaconda command prompt. If you're familiar with PowerShell in Windows, that would work as well. But I'll assume you're not too familiar with PowerShell, so we'll use Anaconda command prompt. If you're on Mac, just follow these directions on your terminal, same with Linux users. And what you're going to do is type in Jupyter Notebook. Now note, I'm not starting Python, I'm just straight up in my terminal or command prompt typing Jupyter space notebook. I hit enter. It'll take a little bit to run. Notice a new tab has opened, and right now I'm running Jupyter on a local host 888/tree, so I'm running this on my own computer. Something to note is that Anaconda will start the Jupyter notebook wherever I was in my command prompt. So if I check my command prompt here, I was under C users, my username Anaconda, so all my files will be saved here. If you want to start your Jupyter notebook somewhere else, you can use cd or change directory commands within your command prompt to change to whatever directory you prefer to save your notebook files in. Alright, so let's go ahead and see what this looks like. It's going to be pretty much exactly the same as it was online, except now we're running it on your own computer. So make sure you're using a browser such as Google Chrome or Mozilla Firefox. Some browsers such as Opera are not supported by Jupyter Notebooks yet. So I'll go here to New and click New Python 2 Notebook. So I've started up a notebook, and now let's go ahead and look at the various features. If I want to name my notebook, I click here, Untitled, and name my notebook. So I'll name this My First Notebook. Hit Enter or OK. And now what we're going to do is check out all the various buttons and features. Something I want to point out, that if you Google manual Jupyter Notebook and click the first link here, it'll take you to a more official Jupyter Notebook user's manual, and this goes over everything. It's actually super extensive, so I'm just scrolling down here. This goes over a lot on various cases of cells, markdown cells, shortcuts, etc. I'll just go over the important stuff here that we'll be using throughout this course. So first thing you're going to want to know is File. You can make new notebooks here. You can open old notebooks, make copies, renames, save and checkpoint your notebooks, print preview, and you can also download your notebooks as .py files, so you can run them in a more traditional format. You can download them as HTML, Markdown, or even PDF, so you can share them with other people. Or The normal format is this .ipynb file, IPython notebook file. As I mentioned before, Jupyter notebooks used to just be called IPython notebooks, but now that they support both Julia and R and other languages, they're called Jupyter notebooks. Okay, so let's see what else we can do. We can edit, we can cut cells, copy cells. So what is a cell? A cell is what I have here, so in cell. So what I want you to do is say print, single quotes, hello world, and I know we've done this a lot. And there's various ways I can actually run this cell. Cell is where there's going to be an in cell, and cell is where you can input code and then run it. So one way to run it is to click this run cell button here. It looks like a play button. And if I click that, I will run that cell. Another way to run cell, which is what you're going to be doing more often, is, for instance, print, and I'm going to write shift plus enter will run a cell. And that's exactly the case. So if I click shift enter on my computer, it will automatically run that cell. That's really important to know. That way you're not constantly going up and clicking this play or run cell button. If you notice a cell is taking a long time to run, you can click right here and that will interrupt the kernel. The kernel is what your cell is running. You can also, like I mentioned before, save and checkpoint. This button will insert a cell below. So if I click this button here, it inserts a cell below the current cell I'm at. So cells are where you input your code. The output will occur right below it. Let's say I wanted to insert a cell between these two. I could click plus, and I'll insert a cell there. You can cut a selected cell, copy a selected cell, paste cell below. Those are very similar to all the edit commands here. There's view commands, which will toggle the header and toggle the toolbar. This is the toolbar, this is the header, so you can toggle those on and off. I'll leave them in place now. You really have no reason ever to toggle them off. You can insert cells above and below. So if I wanted to get my top cell and insert a cell above it, I can do insert cell above, and I have the cell here. The cell itself, if I'm clicked inside a cell and click the cell, I will be able to run the cell, run all above, run all below, etc. So something to keep in mind is that cells remember which ones have been run and which ones have not been run. And you'll notice the number here indicates the order. So this was the first cell I ran, into is the second cell I ran, etc. Okay, zooming in a little further, there's a kernel. Kernel is basically the code that's running. So you can interrupt, restart, or reconnect your kernels in case you run some code that's taking forever to run, or you notice you have some buggy code and something's wrong. Click kernel, click interrupt, restart, or reconnect, depending on your error. You shouldn't see that many errors right now that we're learning because we're going to be typing out pretty simple code. And then help. So there's help for a variety of the libraries and Python in general, so you can use that. And now what I'm going to do is go for some really common shortcuts and teach you those shortcuts in Python, which are the ones in the Python Jupyter notebooks, which are the ones you're going to be using the most. So what are the shortcuts I want you to know? Definitely the first one is print, shift enter will run a cell. So I click shift enter, it will run a cell. Another shortcut that I really want you to know is stuff that has to do with help and tab autocompletes. So as we learn more about Python, we'll learn about stuff called methods and different data objects. That's going to be the next section. So you'll notice I'll be able to, and I know we haven't learned about lists yet at all, but I'm going to make one just to illustrate this topic. So here I have a list of 1, 2, 3. Don't worry, we have a whole lecture on this. But something you'll notice me do is suddenly I'll get a pop-up that looks like this to call methods. What I'm doing is I'm clicking the tab button or key on my keyboard. So the tab button. So what I'm going to say here is print tab will show a pop-up of the methods on an object. Now don't worry if that doesn't make sense right now. As you go throughout this course, you'll look back and think, oh, so that's what tab does, those are methods, etc. We'll learn more about this in the Python objects and data structure basics, but I want you to be aware of it for right now. One more thing I want you to be aware of is Shift Tab will basically make an expanded view of that. So I'm going to say L.sorts, and I know we haven't done this yet, but if I click Shift Tab after this, I'll get a document string. And I know you don't know what that means yet, but just keep in mind that print Shift plus Tab will show help pop up for doc string. Okay, so Shift Enter, Tab, and Shift Tab are probably the key shortcuts to know. Another thing I want to go over is just help in general in Python. Jupyter Notebooks have a nice built-in help here, and they'll take you to links. But if you ever want help on anything in Python, you can just write HELP, help, parentheses, and then put in the side of the parentheses whatever you want help about. So let's say I wanted help about that list. Then you have this total output here that says help on list object. It'll tell you about different methods on that list, various doc strings, what you can do with it, etc. So never be afraid to use the help within Python. It's super useful. So I'm going to delete all this and then click Shift Enter to run a blank cell. That cleared out the output. And finally, what I want to go over is the different types of cells. So right now, these are all what are known as code cells, but I can also change these cells to be markdown cells. And what markdown cells are, it's just markdown text. So I can write normal text here. This will not run as code. Not. And then if I do Shift Enter here, you'll notice this is just markdown text, just normal text. It's not going to run as code. Now let's say you wanted to do this within a cell block. Now we're going to learn about our first real Python lesson, and that's how to do comments in your Python code. There's two ways to do comments. Hashtag. This is a comment. So that's how you can run comments in code. Python will ignore anything that has a hashtag in front of it. You'll also notice it's a different color from the rest of the code. So if I Shift Enter to run this cell, you'll notice nothing happens. One other way to write comments in Python is to do triple quotes. So I have triple single quotes here, and this is for larger comments. Larger multi-line comments. And you'll notice here in this larger multi-line comment, it's also colored differently. It looks like a string, and it is one, but it will be ignored as the doc string within a function. So I know that doesn't make too much sense right now, but I just want you to be aware of it. It's the way to write a larger doc string comment in your code. We'll learn about that much further on in the course. But for right now, if you ever want to comment your code, you can either, since you're using Jupyter Notebooks, change the cell to a markdown cell, write notes in markdown. That's the key takeaway here. Or use hashtags to comment your code. Okay. That's it for the main introduction to Jupyter Notebooks. I know we haven't done a lot with pure Python right now, but don't worry, once we get started with the Python object and data structures, we'll go headfirst into actually learning how to code. Let's just do a quick review of what we've done so far. If you ever want to start up a Jupyter Notebook, you could, option A, just go to try.jupyter.org and do everything in browser, online, or go to either your terminal or Anaconda command prompt, right here, type in Jupyter space notebook. You'll see some stuff pop up automatically. It'll open up a new tab in your browser. Remember, use Chrome or Firefox. And it'll open up your home page. You're going to click New Python 2 Notebook. So I'm going to do that right now. It's going to create a new notebook for me. After the notebook's been created, I can go to it. For instance, I have my first notebook here. This one actually didn't open because I closed Python earlier, so it's actually not running anymore. But you could do new notebook, you'll get something that looks like this. If you ever want to find out where your notebooks are, you can do pwd, which stands for print working directory. Run that cell, and it'll print out where you're actually working as a directory. Right now it's not doing anything because I mentioned before I stopped Python running already. You can do Shift Enter to run a cell. This tab will show a pop-up of methods on an object, just clicking tab, and Shift Tab will show a help pop-up for a docstring. Worry about those later on in the course, but right now, main takeaways are how to start a Jupyter Notebook either on your own computer or online, how to use Shift Enter to run a cell, markdown text, and how to do comments. Okay, in the next lecture what we're going to go over is how to get access to all the Jupyter Notebooks that go along for every lecture. We'll learn about some additional resources to help you answer questions in Python, and that'll be it, and then we'll get started with actual coding. Okay, I'm excited. I hope you are too. I'll see you at the next lecture.